Riju sir, when you take over, kindly unmute yourself.
We can start.
So good morning, everyone. Welcome to the 26th annual conference of the Society of Nuclear Medicine India Southern Chapter. I am Dr. Harishankar. I am the organizing secretary of the conference, and I work at Madurai Meenakshi Mission Hospital as senior consultant and head. So I'd like to welcome you all for this wonderful event. And we are also having several firsts in this Southern Chapter meeting. So as you all know, this is the first online meeting of the Southern Chapter. And this is the first time we have had more than 550 registrations and participations. And we are also having some foreigners attending the meeting. So Madurai is synonymous with the the goddess Meenakshi. So what does Meenakshi mean? Meenakshi literally means the goddess with fish-shaped eyes. Fish-shaped eyes is considered to be extremely a beautiful thing to have. She was actually a warrior princess of Madurai. She was proficient in almost all the skills, including war. And the history says that she was born with 3 breasts. And there was a prophecy that her 3rd breast will disappear when she meets the love of her life, which she met. She conquered the whole of India. And when she was fighting in Kailash, she met Lord Shiva, when she realized that is her soulmate. And at that time, her 3rd breast disappeared. So they both came back to Madurai, and they got married and started ruling Madurai, which has been going on for thousands of years. So let us now invoke the divine blessings of Lord Meenakshi, the bestower of wealth and protector of the people of Madurai, for a smooth and successful conduct of the conference. We will start with the prayer song. I'd like to hand over the opening session, which will be the technologist session, to our very famous chairpersons, Dr. Pushpalata ma'am from Hyderabad and Dr. Riju from Trivandrum. Dr. Riju, the president of Southern Chapter, will start the opening remarks.
Good morning, you all. So then, thank you, Dr. Harishankar, for organizing this wonderful meeting. And this on behalf of Society of Nuclear Medicine India Southern Chapter. So this 26th annual conference is going to create history. As you rightly said, the Madurai is an historical town, and the meeting which is going to be held in Madurai is going to be historical in every respect, in terms of number of registrations, number of international participants, the vividity of the content, and this various interesting components which you have incorporated in this meeting. So very warm welcome to you all. So then I was told that a significant number of registration is already happened, and the people are all already logged in. So without wasting much of that time, so I think we have to go into this right into the topic. And we are starting with interesting area. And this, as rightly mentioned, and over it is the rightly made as the title of the conference, and nuclear medicine from infantry to the precision strikes. So it's a very interesting capture to put, as the title of the conference. So because then it covers the entire journey of nuclear medicine till today. So we started with rectilinear scanners. Now we are talking about this molecular imaging down into the subcellular level. So to capture this kind of, then advanced imaging technology, so we need more sophisticated imaging techniques. So that we are all living in an era of digital imaging. So the digital aspects are covered in almost every aspect of our life, and this PET is no exception. So we have talking about digital PET in a big way right now. So probably that will be the future of PET imaging. So we have to talk about, or generally, then we'll talk about the technology session, so that we'll have a kind of a general impression about the update on technology. So the digital PET is an interesting area which we are all talking about. Probably that will capture this future of PET imaging. And right now it has started in few centers in India, and it has generated significant curiosity among all the users. And to talk about this interesting technology, and we have an expert, or that the person who have a direct experience on this. So where we have with us Mr. Suresh Kumar. He's a senior technologist. He's working in Upon Proton Cancer Center, Chennai. And he is a proud prodigy of Western Medical College, Vellore. And then this CMC Vellore is known for his then great legacy of producing excellent technologies spreading all across the world. And thank you, Suresh Kumar, for taking up this assignment to tell about this the technology behind digital PET. Over to Mr. Suresh.
Good morning, everyone. Myself, Suresh Kumar, as a nuclear medicine technologist from Apollo Proton Cancer Center. So today my topic is about behind digital PET-CT. So first we'll see the PET-CT. So during PET-CT imaging, gamma rays comes from the patient and hits the crystals, and output of the crystals is light signals, and that is always analog signals. In conventional PET-CT, this light analog signals gets converted to digital signal by the help of photomultiplier tubes. Therefore, output of PMTs are always digital, and it process further in imaging chain. So PET system with PMTs. So you can see gamma rays from the body. So it hits the crystals, then light photons are created, then PMTs converts into the digital signals. This is what happening in the in digital PET system or silicon photomultipliers. In SIPM based PET-CT, PMT replaced by silicon photomultipliers. Role of silicon multiplier is also to convert analog light signals into the digital signals. So here the PMT is totally replaced by the silicon photomultipliers. So why silicon photomultipliers instead of PMTs? Main criteria of replacing PMTs with silicon photomultiplier is to reduce electronic noise from the PMTs and improve time of flight temporal resolution. So with the PMT technologies, it is challenging to get lower than 500 picoseconds temporal resolution with silicon photomultipliers. One can achieve better temporal resolution. Therefore, technically, PET-CT with PMTs and the silicon photomultipliers both are analog plus digital. Only the difference is conversion method of analog to digital. Benefits of the silicon photomultipliers. So in our work practice, PET-CT with the time of flight technology is most advanced technology to identify small lesion in PET-CT. So TOF is proven technology to reduce noise from the images. improve the detectability, high patient throughput at lower radiation dose. So above T wave benefit is positive correlation with temporal resolution of T wave. If the temporal resolution is higher, better the T wave benefits. PET-based PET-CT offers, PMT-based PET-CT offers nearly 550 picoseconds temporal resolution. So it achieves better than 500 picoseconds because PMT technologies introduces noises during analog to digital conversion. Therefore, another technologies are required that allow to get better temporal resolution. So the following comparison of various models of PMT-based PET-CT systems and the silicon photomultiplier-based PET-CT system. So you can see the PMT-based PET system gives the temporal resolution is 540 picoseconds and the effective TO of sensitivity is 16.5 counts per second. Peak effective NECR is 225 kilocounts per second. So here we can see the digital one. So TOF temporal resolution is 214 picoseconds and effective TOF sensitivity is 55 counts per second and peak effective NECR is 998 kilocounts per second. So by achieving better temporal resolution, for example, in our institution, we are using biograph vision. It gives 214 picoseconds. So this system offers better image quality, higher NECR values, flexibility to reduce the dose and fast scanning. So the other benefits of the digital PET system. So biograph vision is having 3.2 by 3.2 crystal size and 214 picoseconds TOF temporal resolution and 100% coverage of silicon photomultipliers by optostochastic detectors. So here you can see silicon photomultipliers PET-CT system offers better and lesser background and higher SNR. So this is the first image showing PET system with the PMTs, and the another one is acquired from the digital one. So you can see the better resolution and the sensitivity of the images. So these are the images, the same patients, sagittal and coronal reconstructed images. Thank you.
That's interesting starting. So then, Mr. Suresh, then that was very nice, and you have a direct experience on it. So
Yes,
then, to have a very simple questions as a clinical perspective. So I have seen many, digital PET-CT images. So then one problem which I found was, it is an over smoothness of the images, and you will see a lot of lesions which without, because there is a gradient is very high with the conventional PET. So you will have the lighter to the darker like at a normal gradient. Here it is, you will see very sharp findings versus no absolutely zero background. So sometimes you will get confused whether to how to then pitch down the finding which you get. And especially the brain images which I have seen, it is looks like so over then a smoothened image, and you will get confused, or probably you may have to have a different kind of the eyeballing, and probably over a period of years you will get adjusted with that. But what is the experience then over the feedback which was from your doctors?
Sir, actually here also the same problem will face sometime, but we can reduce the radiation dose is very less, sir. and according to the radiation dose, we can reduce the timing also. So it may avoid the over smoothing of the images. So
That means that by reducing this time of acquisition, you will
yes,
reduce this more.
yes,
Okay. Okay. So then, so that that is the general consensus in your department.
yes. Practically, I have faced the problem also.
And you have the
Initially,
conventional PET in your department.
sorry, sir.
You have the regular PET in your
Yes.
department. You have both.
Yes, sir. Yes.
Anytime you compare this acquisition acquired images in both set of patients, and you found that is something which you are overestimating in the digital PET compared to the conventional PET or something like that, because you are the first user, so you have to come up with a very clear, accurate comments. So I request your and the doctors to make a strong, a presentation on one-to-one comparison and then realistic comparison, so that it will be helpful for all of us.
Yes.
Thank you so much, Suresh. So now we'll move on to the next session. So then let me invite Dr. Pushpalata to introduce the next speaker. Dr. Pushpalata, please.
Thank you, Dr. Reju. Good morning, all. And let us move on to the next talk by Mr. Radhakrishnan. He's the Chief Nuclear Medicine Technologist and RSO Level 2 from Kovar Medical Cancer Hospital, Coimbatore. And he did his DMRIT from RMC. And he's a guest faculty in medical physics. And he had more than 25 scientific research papers to his credit. Now I welcome Mr. Radhakrishnan to present on labeling of alpha particle for therapy. I welcome Mr. Radhakrishnan.
Good morning. First of all, I'm thankful to the organizing committee for giving this opportunity. I will be speaking on labeling of 225 actinium for alpha therapy. I have structured my talk in the following way. Introduction, radionuclides for targeted alpha therapy, why alpha particles, 225 actinium, production of actinium-225, radiolabeling with dotatate and PSMA 617 with actinium-225, radiation protection and waste disposable, and conclusion. Introduction. Globally, cancer is one of the major health problems with high mortality and high morbidity. Approximately half of them receive radiotherapy along with other treatment modalities. Radiotherapy is based on three modalities such as tele, brachy, and targeted radionuclide therapy. The goal of targeted radionuclide therapy is to kill maximum tumor cells by delivering high radiation doses while minimizing damage to normal cells. Usually, we use alpha or beta emitting radionuclide for targeted radionuclide therapy. On comparison, alpha shows a short range of transit with high linear energy transfer, providing excellent treatment effect in cancer with minimum side effect to adjacent cells, while that of beta particle with long range and low linear energy transfer brings moderate treatment effect with increased side effect to the surrounding cells due to crossfire effect. Beta energy ranges from 0.05 mega electron volt to 2.5 mega electron volt, where that of alpha ranges from 2 to 10 mega electron volts. Tests such as monoclonal antibodies, peptides, and small molecules labeled with alpha emitting radionuclides are used for targeted alpha therapy. Targeted alpha therapy is very much beneficial for multiple micrometastases. Because of high linear energy transfer, the probability of double-strand breakage of DNA is high and thereby reducing the chances for repairing, as well as short range causes minimal surrounding tissue damage. Ideal radionuclides for targeted alpha therapy. Sufficiently long half-life for better logistics or generator-based short-lived radionuclide. Higher percentage of alpha emission is appreciated. If multiple alphas are emitted, the half-life of daughter radionuclide should be very short to prevent redistribution of radioactivity. Low energy gamma emission is desirable. Good radiochemistry along with easy availability and affordable cost. Why actinium-225? Actinium-225 is relatively long-lived alpha emitter with a half-life of 9.92 days. Predominant alpha decay yields 5 alpha particles with energies ranging from 5.8 to 8.4 MeV. 3 beta max emission of 0.6 to 1.6 MeV. Useful gamma emissions of 218 kiloelectron-volt of francium-221 with an abundance of 11.6%, and the emissions of 213 bismuth of an energy of 440 kiloelectron-volt with an abundance of 26.1%. Actinium is a block element with atomic number 89, first element of actinide series. Actinium was first extracted in the year 1899 from pitchblende by Andre Louis de Broglie. Abundance of actinium in Earth crust is estimated to be about 0.0005 parts per trillion by mass. 32 isotopes of actinium is present, which all are radioactive. 227 actinium is the most abundant isotope with a half-life of 21.7 years. The most significant isotope for targeted alpha therapy is actinium-225. This is the decay scheme of actinium-225. In this, you can see the 5 emissions of alpha, 3 emissions of beta, and 2 emissions of gamma with an energy of 218 kiloelectron-volts and 440 kiloelectron-volts of radionuclides, 221 francium and 213 bismuth, respectively. This is the linear energy transfer of various alpha emissions of 225 actinium. There are few alpha-emitting radionuclides labeled radiopharmaceuticals used for targeted alpha therapy. Ready-to-inject radium chloride is available for castration-resistant prostate cancer with bone mets. 225 actinium radiopharmaceuticals needs in-hospital labeling. Actinium labeled PSMA and actinium labeled DOTA are the 2 radiopharmaceuticals that are prepared in our hospital. Production routes of 225 actinium. Radiochemical extraction from thorium-229. The conventional way of producing actinium-225 is production from 229 thorium. Thorium-229 is produced from the natural decay of fissile uranium-233. That is, thorium-232 under neutron radiation produces uranium-233, which undergoes fission to form 229 thorium, and on alpha decay produces 225 actinium with 225 radium, which have a half-life of 9.92 days and 14.9 days respectively. Alternate production routes are nuclear reactor and accelerator. In nuclear reactor, 226 radium on N2N reaction forms 225 radium. On beta decay of 225 radium forms 225 actinium. This needs an intense source of high neutron energy. The limitation is that limited amount of actinium-225 is produced and the co-production of 227 actinium, which makes chemically impossible to separate 227 actinium and 225 actinium. In accelerators, high energy particles and low energy particles used to form 225 actinium, which are solely used for the research studies. Globally, there are 3 main producers for actinium-225. Joint Research Center in Germany, Oak Ridge National Laboratory in USA, Institute of Physics and Power Engineering in Russia. Isolation of thorium-229 source has also been reported recently from Canadian nuclear laboratories. Annual average global production is 1.7 curie of 229 thorium. Chemistry of actinium series. Much of actinium chemistry is not known as there is no stable isotope available. Electronic configuration is radon 61-7s2. Actinium exists most stably in +3 oxidation state. Due to its large size and low charge density makes the actinium +3 is the most basic +3 ion. Metal ligand bonding in actinium complexes is due to electrostatic interaction and steric constraints. Bifunctional chelating agents. For labeling, we need bifunctional chelating agent. Tumor targeting vector and bifunctional chelating agents must be covalently linked to form thermodynamically and kinetically stable complex with actinium 3+. Actinium 3+ must be retained in the cancer cell over the course of nuclear decay. Recoil effect. One of the drawbacks is the recoiling daughter atom. This leads to the release of daughter from its original site and undergo redistribution and cause damage to normal healthy tissues and unwanted radiation exposure. DOTA. DOTA is a dual-membered macrocyclic chelator that provide octadentate coordination via 4 tertiary amine nitrogen and 4 carboxylic acid pentate arms. Radiolabeling of data requires short period of time and high incubation at 95 degrees Celsius. In vivo stability in humans at 37 degrees Celsius is 90% intact over 10 days. Radiolabeling of actinium-225. The standard dose is 150 to 200 microcurie. Actinium chloride is applied in 0.04 molar HCl. The volume will be of 100 to 200 microliter in 2 ml vial. The purity of actinium delivered will be around 99.9% with no non-carrier added. Labeling of DOTA and PSMA. Before labeling, we have to prepare a buffer. The procedure for preparing the buffer is we have to weigh 160 microgram of sodium ascorbate and 40 microgram of ascorbic acid, and we have to dissolve this in 1 ml of ultra pure water. It should result in a pH of 4.5 to 5. Preparation of actinium PSM. Dissolve 200 microgram of peptide with 100 microliter of ultra pure water. Take 1 ml of buffer in append of centrifuge vial and transfer the peptide into it. Transfer this mixture to 225 actinium vial using 2 ml Luer lock syringe. Shake the vial for few seconds and keep it in the dry bath for 25 minutes at 90 to 95 degrees centigrade. Remove the vial from dry bath and allow to cool for 5 minutes. Purification of the preparation. Before purification, we have to precondition the CPAC C18 cartridge. CPAC C18 cartridge should be washed with 2 or more ml of 100% ethanol, followed by double the volume of ultra pure water and dry it. We have to make sure that the CPAC cartridge is not fully dried. For the elution of radiopharmaceutical, we have to elute with 70% of ethanol. For that, we have to make 70% ethanol. For that, take 7 ml of 100% ethanol in 10 ml vial and add 3 ml of ultra pure water into it. Purification of 225 actinium radiopharmaceutical. Withdraw the radiopharmaceutical in 2 ml Luer locking syringe with steric needle. Pass through the preconditioned C18 cartridge drop by drop. Wash the reaction vial using 5 ml ultra pure water and pass this through the cartridge. Wash the cartridge using 5 ml of ultra pure water for twice. Air dry the cartridge. Elution of radiopharmaceutical from the cartridge. Elute the C18 cartridge using 2 ml of 70% ethanol and air dry it. Average labeling yield is around 80 to 85%. Quality control of radiopharmaceutical. Quality control is performed in ITLC silica gel as the stationary phase. There is 2 type of mobile phase is available. If we are using mobile phase as trisodium citrate, the point of spot will retain the label radiopharmaceutical, while solvent front will be having free actinium and daughters. If we are using acetonitrile with water in 1:1 ratio, the point of spot will be having free actinium and their daughters, while the solvent front will be having labeled radiopharmaceutical. For the quality control, we require chromatogram scanner, since the accuracy of well counter and dose calibrator is not sufficient for alpha decay, for detecting alpha decay. Radiation protection and waste disposal. As 225 actinium is alpha emitter and abundance of gamma is less, external radiation hazard is very minimal. Need special care for Indian radiation hazard. Strictly avoid ingestion and which may cause serious effects. Double gloves and face masks should be used to avoid any ingestion. Conventional half-life protocol may be followed for waste disposal. Better allow 6 months time before disposal of solid and liquid waste for complete decay. Conclusion. Alpha therapy with 225 actinium has proven its efficacy. 100 to 200 microcurie per cycle is sufficient. Radiation dose to non-target tissues are less compared to other targeted radionuclide therapy. Quantification of alpha radionuclides is an issue. Most post-preparation purification is must. QC is difficult and a challenging part. The cost of treatment is very high. Availability of 225 actinium is limited and has to be increased substantially. acknowledgement. I would like to express my gratitude to my colleague and for their support and guidance for preparing this talk. I am extremely grateful to Mr. Mohammed Junaid and Dr. Ramkumar for their sincere support for preparing the slides. Thank you.
Thank you, Dr. Radhakrishna. It's a very
Thank you,
lucid
madam.
presentation.
Thank you, madam.
Very, very lucid, and you have made it so clear. I just have one doubt. Like you said that labeling of alpha particle is efficiency is 80 to 85%. Do you have any practical issues with that? Only 85% labeling efficiency?
Actually, we tried maximum, madam. Actually, we got only 80 to 85%. We asked our company person also. They told they are expecting only this range efficiency.
Clear, practical, and in a clinical aspect, did you get any problems with this? Did you face any?
No, actually, we could not do much imaging, madam. That's what we cannot say about the quality of the radiopharmaceuticals.
Okay, okay. Okay. Thank you, Mr. Radhakrishna. Very nice presentation.
Thank you, madam.
Raju, next, we'll move on to the next.
Thank you, Radhakrishnan. It was a wonderful talk, to get this general idea on alpha particle therapy. Now we move on to the next session, that is imaging after beta and alpha particle therapy. It's an interesting topic because we all came to know it's almost like the waiting and outside the labor room to see the baby. So then after the wonderful the administration of the the therapeutic agent. So we'd like to know how it has been distributed in the body. So that is something that is a very precious moment for everyone to see the effectiveness of PRRP or radioiodine therapy or alpha therapy, whatever it's. So then we would like to know this the tips and tricks concerned with this post-therapy imaging. So we have then a very interesting topic, and another we have a senior technologist with us, and then Amir Suhail. He sails from Kerala, so he completed his graduation from Jipar Pondicherry. Currently, he is employed in Asian Institute of Gastroenterology in Hyderabad. So over to Amir Suhail, and we are all curious to listen to you about the tips and tricks on post-therapy imaging and alpha and beta particle therapy. Over to Suhail.
Nucleus. This radionucleus can be categorized into subcategory like nucleus which are used for therapeutic purpose, and nucleus which are used for diagnostic purpose. Today I will be talking only about nucleus which are used only for the therapeutic purpose. For therapy, we are mainly using alpha and beta particle because of their high linear energy. So this therapeutic radionuclide can be subcategorized into 3 categories, like radionuclide which are having beta emitting property, and radionuclide which is having beta emitting along with gamma emitting property, and radionuclide with alpha emitting property. You all know this beta and alpha particle is having a high linear energy compared to gamma photons, and they are having less penetration power as compared to gamma photons. So the conventional scintigraphy method will be challenging in this case. So we have to apply a different idea for imaging purpose. So I'll be talking about that. These are the example for pure beta emitters. These are mainly used radionuclide and phosphorus 32, strontium 89, and yttrium 90. So imaging yttrium this radionuclide with pure beta emitter, we are applying Dunstone imaging property. Dunstone images are obtained. This beta particle with a high energy, when they are interact with the surrounding atoms, they will get decelerated or deflected. So their kinetic energy will be converted into photons known as Bremsstrahlung photons. This Bremsstrahlung photon is having discrete energy range. So that energy range depends on the energy of the charged particle and the atoms which it is getting interacted also is depends. The Bremsstrahlung photon energy increases with the energy of the charged particle, and it also increases with the interacting particle atomic number also. So that's why we are not keeping pure beta particle empty radionuclides in a lead container. So for imaging, because they are having discrete kind of energy, we have to use broad energy window like getting 70 to 85 electron. Then only we will get an adequate image by increasing sensitivity. And one more thing, we need to use high energy colorimeter, high energy or medium high energy colorimeter. As compared to normal scintigraphic image, these images, images are having poor quality because there are a lot of factors affecting this image degradation. Those are tissue attenuation and about energy range of this Bremsstrahlung imaging, and less spatial resolution. These all are the factors which is affecting Bremsstrahlung image. I will show you an example of the Bremsstrahlung image. Yttrium-90 has got a different characteristic apart from other radionuclides. Yttrium-90 is mainly a pure beta emitter, but a small amount of internal production is happening in yttrium nucleus. That is 32 per million decays will result in an internal production. That will be producing an ionization radiation that can be made by PET-CT modality. As we compare with this image obtained from yttrium from PET-CT image to SPECT image, there is a high superior image quality as compared to SPECT image obtained from the yttrium. I have given an example here. This is an image obtained from a patient having colorectal carcinoma with a left hepatic mets. So the first image which I have shown here is a planar image obtained from the gamma camera with an energy window 111 kV to 150 kV energy. And the second image is obtained here is an image obtained from the SPECT-CT system. And the third image is image obtained from the SPECT-CT. So as we compare these images, we are having PET-CT images are having high superior quality compared to the SPECT image. So this is a modality for imaging pure beta emitter. There is one more imaging modality known as luminescence imaging. So the basic principle is of luminescence imaging is when a charged particle moves in an aqueous solution more than the speed of light, it will get deflected. Speed of light, the water molecule will get depolarized. The electromagnetic energy and radiation will be disrupted. So for getting equilibrium, they will be emit and they will lose their energy by releasing some amount of ultraviolet rays as well as visible rays. So this visible rays will be get detected highly sensitive luminescence detecting devices, and then we will get an image from that. This is the basic principle of Cherenkov luminescence imaging. This Cherenkov luminescence system is less cheaper as compared to normal SPECT-CT system, PET-CT system. So nowadays we're getting good applications for Cherenkov luminescence imaging. Now we'll be talking about alpha emitters imaging. As we all know, this alpha particle is having high linear energy compared with beta particle, but they are having less penetration effect as compared to beta particle. Even with a paper, it will get stopped. So normal convention may absolutely not possible with this alpha emission. So we are employing a different idea, like presence of gamma emission in the daughter product we are applying for imaging purpose. I will give you an example. Actinium-225 will decay into various daughter products, that is francium-211, astatine-217, bismuth-213, and polonium-213, thallium-209, lead-209, bismuth-209. So basically, this actinium-225 decay will lead for alpha particle and 3 beta particle accompanied by 2 gamma emissions of francium-211 with a gamma emission of 218 kilo neutron volt, and bismuth-213 with 440 kilo electron volt. This by using this gamma emission, will be able to involve distribution of radiopharmaceutical. So we'll be getting an image. So I will give you an example of the image which I obtained after actinium-225 PSMA post therapy of a patient with a prostate cancer. Same like actinium-225, other radio nucleus with pure alpha emitters. Like radium-225 and thorium-227, astatine-211, and terbium-149 also have their daughter product with the gamma emission. So with the use of this daughter product, you can get an image with the gamma camera. And terbium-149 have a specific characteristic like yttrium. They are having positive emission as well as gamma emission with the short range alpha particle. While by using this positive emission, we can image from image yttrium-149 labeled radiopharmaceutical by PET modality. So we can call as alpha PET. So this is for alpha emitting imaging, and now we will be talking about radionuclide imaging, radionuclide with the beta emission and gamma emitting. These are the examples of nucleus with the alpha and beta emitting as well as gamma emitting. Radium-131 is having high gamma emission of 364 energy. We'll be using high energy polymeter, and Samir-153 is having gamma emission of 103, and lutetium-177 is having a gamma emission of 208 with 11% abundance. Same like Rhenium-186 and Rhenium-188 also having characteristic gamma emissions. So we can employ for image easily. So these all are imaging modality of therapeutic radionuclides. Thank you for listening to this. And special thanks for Dr. Sunita and Dr. Mohandu for giving an opportunity for this speech. Thank you all.
Thank you, Mr. Sahil. It was a very nice presentation. So I would like to then get one, then comment from you, because then most of this post therapies can, especially with this, then this routine use which we are, practicing today, that is, then rotation based, or whether it is an actinium. So it's then it's more of a medium energy. So then, do you recommend this medium energy polymeters are mandatory nowadays in future? Because many of these departments are, and when they are purchasing gamma camera, they will go for the leap. I mean, this low energy and high energy, and the medium energy is almost like an obsolete component. Now it has become more relevant because of this, to get a proper appropriate person of imaging with this rotation or cleaning requires, medium energy collimator. So what is your comment on that?
Please unmute.
The use of medium energy collimator is not recommended. Even with low energy, high resolution collimator, also will be able to get a good amount of good image for left tissue and all. Medium energy collimator is not highly recommended.
It is not highly recommended, but it is make a distinct difference in this quality of the images which we are acquiring with this, than high energy or low energy versus medium energy. So that is fine. So then this, I think so, because we are running short of time, so we have to get into the right, time schedule. And thank you, then Amit Sahil. It is a very nice talk, and congratulations. And we will move on to the next talk and over to Dr. Pushpala to introduce the next speaker.
Thank you, Dr. Chu. Our next speaker is Mr. Prabhu. He's the senior technologist from CMC Vellore, and he's working since 2005 in CMC Vellore. And he's a tutor, and he teaches the undergraduates and postgraduate students. Now I welcome Mr. Prabhu to present on preparation of Technetium-99 Pro.L injection.
I am Prabhu Titus Devakumar, Senior Technologist from CMC Vellore. I thank the organizer and my institution for giving me this opportunity to share my experience and knowledge on the topic of preparation of technetium product for injection in next couple of minutes. So what all I'm going to cover is introduction, indication, description, materials and instruments required, preparation, comparison, radiochemical purity, dosage and administration, precaution and safety. So introductions. Preparation of technetium product injection to trace the dopamine transporter in patients suffering from neurodegenerative changes like Parkinson's disease. It's a receptor binding. Imaging of dopamine transporter is located in the dopaminergic neuron terminals, and it's used for differential diagnosis of Parkinson's disease from non-Parkinson's disease, early diagnosis of Parkinson's disease, diagnosis of other movement disorders such as McAdoo-Joseph's disease, reduction of DAT due to other genetic mutation, blocking of DAT due to drugs such as methylphenidate, monitoring the effectiveness of deep brain stimulations. And description. Product kit provides a pre-dispensed sterile formulation for reconstitution with sterile technetium sodium pertechnetate injection. Each vial contains product 0.3 HCl is 0.126 milligram and sodium glucoheptanate 0.32 milligram, disodium ethylene diamine tetraacetate dihydrate 0.93 milligram, stannous chloride dihydrate 0.032 milligram, mannitol 20 milligram, anhydrous sodium phosphate dibasic 4.1 milligram, sodium phosphate monobasics 0.46 milligram. Product vial are lyophilized and sealed under nitrogen. No bacteriostatic preservative is present. After reconstitutions with sterile sodium pertechnetate technetium injection, the product form is suitable for IV injection. The pH should be 6.5 to 8.5. The reaction vial should not be reconstituted with any solvent other than sodium pertechnetate technetium injection. So what are all the materials and instruments needed for this preparation is technetium generator, sterile vial, lead shield container, 0.5 ml sterile syringe, 0.9% saline, 75% alcohol, gloves, long handle forceps, dose calibrator, autoclave instrument, and gamma camera. And the instruction for the preparation is to ensure the quality of technetium product injection. Use aseptic techniques throughout your preparation. Suitable shielding to minimize exposure, and wear waterproof gloves. And allow the kit vial to attain ambient temperature. Place the vial in a suitable lead shielded container and swab the rubber septum with an alcoholic sterile swab. Add freshly eluted required technetium sodium per technique. And before withdrawing the syringe from the vial, withdraw 5 ml of gas from the space above the solution to maintain atmospheric pressure within the vial. Shake the shielded vial for 10 seconds to ensure complete dissolution of the content. So after adding this, we can, I'm comparing 3 companies. According to the companies, the volume and maximum activity and the temperature, it's changing. So we can see the volume for Brit Indian company is maximum volume is 1 ml, and Taiwan 5 ml, and Iran 1 ml, and maximum activity for Brit 60 millicurie, and for Taiwan 40 millicurie, and for Iran 40 millicurie. And coming to autoclave temperature and timing, the Brit company is saying 100 degrees centigrade for 40 minutes preparation. Taiwan is 121 degrees centigrade for 30 minutes, and Iran even 95 degrees centigrade for 30 minutes. And the shelf life also changing for different companies. The Brit company is saying 2 hours the shelf life, and Taiwan is for 4 hours, and Iran is for 6 hours. And coming to radiochemical purity, there are 2 methods. The first method is reversed phase high performance liquid chromatography analysis on a Gemini C18 cartridge and column. This is eluted with a mixture of acetonitrile and 5 mm dimethyl glutaric acid, and the buffer should be 7 in the ratio of 3:2. The flow rate is 1 ml per minute. The retention time for this is 19 to 31 minutes. The radiochemical purity should greater than 90%. The second method is ITLC silica gel plate. In this, we need 2 types of mobile phases. One is 0.9% sodium chloride, and the another one is acetone. Pour adequate amount of each mobile phase into 2 distinct developing tanks, respectively, to the depth of less than 2 cm. Cover the tank for solvent to equilibrate for 10 minutes. And place 1 drop of the technetium triodat at the center of the plate, 2 cm from the bottom of each plate. The system 1 is to develop the plate with 0.9% sodium chloride solution in the covered TLC tank for a distance of 12 cm from the bottom of the plate. The second system, develop the plate with acetone, the covered TLC tank for the distance of same thing 12 cm, and after drying from the acetone, then you have to place it into 0.9% of sodium chloride solution. And we have to measure and distribution of technetium activity by appropriate radiation detectors. How to calculate this is the radiochemical purity of this second method. It's triodat equal to 100 minus the radioactivity of the solvent friend of the system 1 plus the radioactivity of the origin of the system 2. Then this radiochemical purity should come greater than 90%. So how to the dosage and the administration we have to follow. Its recommended dose is for only IV administration, and the maximum activity up to 28 we can go, 22 to 28 millicurie for adult, and SPECT imaging should be performed 4 hours post administration. And what are all the precautions we have to follow? Strict aseptic practices shall be employed during all the above stages of formulation. Use only sodium pertechnetate injection eluted less than 6 hours from a generator, and the moly technetium generator should be eluted within 24 hours from the previous emission. We can avoid giving product scan on Mondays because Sunday we won't elute the generator. Then do not use if any suspended particulate matters or coloration is observed in the reconstituted injections. Perform the recommended hospital radiopharmacy quality control before injection. And safety point of view, the content of product kit are not a radioactivity. However, after sodium pertechnetate is added, adequate shielding of the final preparation must be maintained. Product kit are not to be administered directly to the patients without reconstructions with technetium. And to minimize the radiation dose to the bladder and the other organs, patient is encouraged to drink fluids and void frequently during 6 hours after injections. Contraindication is not known, and adverse reactions as reported occasionally like dizziness, back pain, hypertension, and numbness. And the storage. The product kit should be stored in a refrigerator 2 to 8 degrees centigrade when you are receiving, and it should be protected from light until it use. An expiry date of this is they will give for 6-month expiry date, and it should be stored in 2 to 8 degrees centigrade. Whether pregnancy can inject the product, it means animal reproduction studies have not been conducted with technetium product. It's also not known whether this drug can cause fetal harm when administered to pregnant women or can affect reproduction capacity. Therefore, technetium product should be given to a pregnant woman only if clearly needed. A nursing mother. Technetium product can be excreted in human milk during lactation. Therefore, formula feeding should be substituted for breastfeeding. The sterility test. So the kit sterility test for technetium radiopharmaceuticals are carried out as described in US Pharmacopoeia. And pyrogen test, LOL test, and rabbit test on kits of technetium radiopharmaceuticals are carried out as described in US Pharmacopoeia. And the DAT scan images can do inspect gamma camera, and the images will look like this. This is the normal scan for DAT scan, and the Parkinson disease will be looking like this. Thank you.
So I'd like to thank all the 4 speakers and the chairpersons for successfully conducting the first session. As we say, well begun is half done. We are up to a fantastic start. So before going to the next session, I'll just show you one of the highlights of the conference, which will be the quiz. So what is a conference if we don't have some fun and we don't have some means to stimulate our brain and question our senses? So one of the highlights that we are going to have in this conference is quiz. So this is how you will have to answer in quiz. This is the conference portal entrance scheme. There is a quiz button in the right side lower corner. When you press on this button, you will get the options. Please be careful that only the options are mentioned. The correct answers are not mentioned in the options. So we have called this the Q pay, the quiz that pays. We will have around 20 questions for clinicians and 5 separate questions only for technologists during the entire program. The quiz questions can be asked at any point of the conference. Each question will have 4 options. One option is the correct answer, and one winner for every question will get cash prize. So potential of total of 25 prizes are to be given out. So you'll have around 10 to 20 seconds for choosing the correct answer. Organizer's decision is final. So we have put up a dummy question. This does not have any prize. This is the question. You can see this gentleman here. Identify the gentleman. The options are option A, Amit Shah, option B, Narendra Modi, option C, Manmohan Singh, and option D, Atal Bihari Vajpayee. You can just try answering the quiz. The further questions will carry prizes. Identify the gentleman. So while we get the answers, we'll move on to the next session. The next session is basic nuclear medicine. For this, we have Dr. Krishna Kumar sir from Adayar Cancer Institute, a nuclear medicine physician and head, who is a DNB teacher, DNB examiner, and also technologist teacher, joining the session. And the second chairperson is Dr. K.K. Kamaleshwaran, consultant and head of nuclear medicine in Kovai Medical Center Hospital, Coimbatore. He also holds the post of treasurer of Southern chapter. I hand over the session to the chairpersons.
Yeah, thank you, Dr. Harishankar, for conducting such an event and inviting me as a chairperson. Are you able to hear?
Yes, please go ahead.
Yeah. Okay, so the second session of the day is general and basic nuclear medicine, which we start with Dr. Indrani Madam. She is the senior consultant in Apollo Hospitals, Chennai, and they are running the DNB program for a long time. So this topic will be a very interesting topic, which is guide to setting up a nuclear medicine teaching facility. So now I think nuclear medicine is the most wanted field. As I heard in the last NEET counseling, PG counseling, DNB nuclear medicine was taken by most of the students before radiology and even MD nuclear medicine. So now the corporate and private hospitals, everyone is interested to start DNB nuclear medicine. So I asked Dr. Indrani to start the session with the guide to setting up of a nuclear medicine teaching facility.
For inviting me to give a talk. I was requested to give a talk on guide to setting up a nuclear medicine teaching facility. For convenience purpose, we shall divide this into two parts, that is nuclear medicine technology course and the DNB course. Coming to the steps to start a nuclear medicine technology course for any institution from Tamil Nadu, as it is depending on the local state university, each state may have little variations in applications, and the course has to be affiliated to the local state university with the application and the requiring format for preparing the documents. And there will be a list for submitting. One is on doctor's list. One senior doctor has to be designated as a course director, and there will be other specialist doctors who are attached to the same course. And there will be an equipment list on which the nuclear medicine technology course will be depicted upon. The nuclear medicine technology department statistics also for the last 2 years has to be submitted. The consent from the senior doctor with the qualification, experience, photo, PAN number, Aadhaar number, and driving license has to be submitted. The infrastructures as detailed below, like building sketch and the library facilities with the book list given by the university, and the syllabus from the university with the required hours of training. For example, basic English, physics, and clinics, each containing of 50 hours has to be included. And also for technology course, it is a must to include the cyclotron training. The memorandum of understanding has to be done with the external institute for the same. And also, as long as the syllabus is concerned, it is better before we start the course to apply to the AERB asking for the guidance to define the syllabus that they would require, so that later there is no discrepancy between the university syllabus and AERB required syllabus when we go for a AERB approval. That is a must to be noted. Then there will be an inspection fee which can be made online. Then university will depute to government doctors to verify the infrastructure, After inspection, the university will give the permission to start the course. As we start the course, we have to apply for the Atomic Energy Board approval as well. Then the AERB will depute the scientist for the inspection and approval. This is basically the structure that is needed for the technology course. Coming to the Diplomat of National Board NBE course, that is NBE agreement is a must. National Board of Examination was started in the year 1975 by the Government of India with expecting to have a very high and uniform standards of postgraduate examination and education. The qualification award afforded by the NBE in various broad specialties are termed DNB. In the broad specialty, which is for 3 years, there will be an online portal registration of the applicant hospital, then submission of the application, accreditation fee payment, and hard copies of the applications to be sent. After fulfilling all the NBE accreditation criteria, one will be offered the accreditation for the DNB program. We can consider this under the subheading of about 8, the second of which will be the approval of the faculty for the program. The faculty status in the department, guide for the DNB thesis, change in the faculty has to be informed to the DNB. The DNB training consists of the selection of the candidates, joining of the candidates, academic program, formative assessment once in every 6 months, and appraisal of the DNB trainees once a year, and finally, of course, the DNB final examination. The approved infrastructure, facilities, and patient load should be available for the accredited hospital. The minimum required beds and minimum required beds in both the hospital as well as the department with the patient load has to be met with. The guidelines for the accredited hospitals as well contains the rotational posting of the students with a memorandum of understanding for a minimum of 6 months, minimum of 3 months in a year to the relevant related departments for the broad specialty course. There comes the training charges and fee guidelines and stipend guidelines, comprehensive training support guidelines, which will be explained in the later part of this talk. All these protocols has to be met with for the accreditation purposes. And as we sign the NBE agreement in the initial period, the effect of agreement also has to be met with in the form of certificate of adherence, annual review, applying for the renewal of accreditation once in every 3 years. Withdrawal of accreditation is to the DNB's jurisdiction. There comes the grievance redressal committee, which is a must for the each and every hospital to be met with. The most that we are interested is the minimum accreditation criteria. The minimum accreditation criteria depends on the clinical establishment of the applicant hospital, bed strength of the hospital, and the requirements in the applicant hospital in the form of beds, faculty, patient load, physical facilities, and supportive services, teaching, training, requirement of academic department, and the rotational postings, fees, stipend guidelines, functionaries, and grievance redressal committee. These are the minimum requirements. Coming to the faculty, the research experience of the faculty also is an important fact. At least 5 research activities the faculty should possess. In any form of publication, presentation, case reports, in any of these forms, the proposed faculty required to submit a faculty declaration form. The full-time status of the faculty of the applicant hospital, the faculty should work in the applicant hospital for a minimum of 6 to 8 hours per day. Part-time and visiting consultant shall not be considered as a faculty for the NB courses. Minimum 2 senior residents are required for a candidate, single candidate's approval. That is 2 senior residents Pursuing academic course will be called academic senior resident. Those who are not pursuing academic course shall be called non-academic senior residents. Faculty. The full-time status of the faculty has to be confirmed by full-time declaration form and also Form 16, Form 16A and Form 26AS as proposed by the Traces website. Thesis guide and co-guide. A senior consultant can guide maximum of 2 DNB candidates, 1 post-MBBS, 1 post-diploma. In case post-diploma is not available, 2 DNB candidates primary can be guided. Junior consultant can only be a co-guide for the DNB trainee in the applicant department. Each consultant who has been shown as a faculty should at least devote 10 hours per week for teaching or training in the applicant hospital. The minimum teaching program per week shall consist of 5 hours of didactic teaching, 5 hours of clinical or bedside teaching. The patient load is also described by the DNB. For the minimum requirement of the patient load both in OPD and IPD has to be met with, and the load of the last 2 years has to be submitted to the DNB. The physical facilities and supportive services in the form of outpatient department, inpatient department, emergency medical or critical care, OT complexes and supportive services like biochemical, histopathological and microbiology supportive departments has to be shown. Teaching and training facilities in the basic sciences has to be shown, which can be taken by the various specialty doctors. In our hospital, the first 30 days of candidates joining has spent on the basic science teaching program, which is a pre-programmed protocol or program which is designed by the hospital for all the trainees. And there is a requirement of institutional ethics committee which has to be registered in the Department of Health Research in the Ministry of Health and Family Welfare. The ethics committee shall comprise of chairperson, 1 to 2 persons of basic medical sciences, 2 clinicians, 1 legal expert, and 1 social scientist, 1 philosopher, 1 lay person, and 1 member secretary. Library facilities. The requirement of minimum 4 journal subscription in the name of the applicant hospital, particularly of which 2 can be international. The recommended textbooks and reference books for the specialty has to be available in the hospital library. The accommodation is to be provided for the NBE candidates, for which the hospital can collect 1 amount per annum. The requirement of academic department for the purpose of accreditation is an academic office for the department, rooms for faculty, duty rooms for trainees, departmental library, specialty specific clinical areas. Guidelines for the rotational posting is also given in the agreement form, where minimum of 6 months has to be given, 6 to 9 months in case of 3 years. That is 3 months per year has to be under the rotational posting with a memorandum of understanding if it is going to be an external hospital. Fee to be paid by the DNB candidate to the DNB is and comes under tuition fees, library fee, annual appraisal fee and accommodation charges. These are paid straight to the NBE. From the NBE it will be given to the hospital, attached affiliated hospital. The stipend guideline for the post-MBBS DNB 3 years course is for the first year 35,000, second year 37,000, third year 39,000 as of now. There are minimum requirements of the functionaries of the applicant hospital, like head of the institute, chief medical superintendent, and then NBE course coordinator, head of the department or senior faculty in charge. Thank you for your patient listening. If there are any questions, I am willing to answer it. Thank you.
Yeah, the very interesting talk, madam. Actually, so what is the minimum number of seats we can get if we start a DNB course? Minimum and maximum.
Minimum number of
Seats, DNB, total seats.
That's on your faculty.
Okay.
One candidate, you have to have this many numbers of faculty. So there is no limit for number. You can be afforded 4 to 6 also. But for
Okay.
each candidate, you should have a senior consultant, junior consultant, and 2 senior residents. These are for single candidate.
Okay, madam.
I think
So what are the total number of DNB seats in India now?
Including this topic.
Madam?
I think this is Harishankar's idea of including this topic.
Yeah, because everyone now.
We have been talking a lot about setting up of nuclear medicine department, but we have never spoken about setting up a teaching facility. So that is the reason why I wanted to have this talk.
Yeah, the teaching facility, as I have already explained, both for the DNB as well as the paramedical course also, the number of hours, everything is predefined. And first of all, you have to decide whether you can manage the course or not. If you cannot afford particular hours of teaching, you should not take it. First, you decide and see whether you can manage the teaching part of it. Otherwise, there's no point in taking up the students and not teaching them at all. You have to design a theory module and you have to design a practical module. If you can manage all that, please take it. Otherwise, don't take it.
What is the validity period of your approval?
3 years.
So for 3 years, that means you are permitted to take one candidate every year for these 3 years?
Yes. One senior consultant can take 1 primary and 1 post-diploma. If you don't have a post-diploma, then you can have 2 primaries for a single senior consultant.
Suppose at the end of 3 years, you don't get the renewal. What is the fate of the 2 students there?
Continue.
So that doesn't affect.
Continue.
Those students are not affected.
No way the students are affected. In fact, we have saved some students where other institute which is not qualified to have, only a diagnostic institute have taken, and we have saved those students from discontinuing the course. In fact, help them with the DNB to finish the course successfully. And she's finished also and got.
Now, at present, total number of seats DNB in India, how much, madam?
There is no limit. It is like if you have that many facilities, you will have that many students. We were offered even 6 students, but we don't want it because we know in our setup and area how many students we can manage. If you are having some 4 students per year, for 3 years, it is going to be a 12 student. Whether you can manage that many or not, you have to decide. So on the basis of which we have actually surrendered 2 seats. We didn't want it.
Okay.
You have to justify in taking the students. It's not simply you taking up and not able to do. Like the same for the technologists, they offer even 20 students per year. But that is not justified, So we tell the paramedical college principal, you should not take up that many. For this year, we can manage only this many per year. So we cut down the numbers per year so that we know how much we can manage, how many students teaching can be done.
Okay, thank you, madam.
Interesting. We can proceed to the next talk.
Yeah, thank you.
So the next speaker is Dr. Gayana. She has got a very great academic record.
I think Dr. Krishna Kumar sir is muted.
Okay. Sorry. Now, are you able to hear me?
Yes, sir. Kindly proceed, sir.
So we are now having the second speaker, Dr. Gayana from Mysore Medical College. She has got a lot of academic laurels as shown in the slide. And she finished her MD nuclear medicine from PGH Chandigarh. And now she is holding the post of consultant and senior chief of the Department of Nuclear Medicine from Fortis Hospital, Bangalore. So now I am audible. So I request her to start the talk. Thank you.
Good morning, everyone. I am Dr. Gayana S. I lead Department of Nuclear Medicine at Fortis Hospital, Bannerghatta Road, Bangalore. First of all, I would wish to extend my sincere gratitude to the organizing committee of Society of Nuclear Medicine India Southern Chapter for providing me this wonderful opportunity to speak on getting your workplace precise, that is accreditation process of nuclear medicine department. So why this topic? As more and more hospitals and diagnostic centers are applying for NABH and JCI accreditation, so we thought it would be good to discuss on how to keep things ready for this NABH or JCI audit. We all love our work. We are trained in best of the institutes and we want to provide best of quality care to our patients. Then why do we need external validation for this? Why do we need this accreditation process at all? So here goes a saying, thinking of accreditation as a tool for quality improvement rather than an outside mandate or stamp of approval highlights the true value of this accreditation process. Benjamin Franklin said, by failing to prepare, you are preparing to fail. So we need to be prepared for every situation that we encounter in our medical practice and in our day-to-day life. And accreditation process makes it easy to keep things sorted. And why do we need to be precise? Bertrand Russell said, everything is vague to a degree you do not realize till you have tried to make it precise. So precision is important. So what are the accreditation boards? These are NABH and JCI. NABH is the Constituent Board of Quality Council of India, and JCI has been associated with more than 100 countries, that thus promoting medical tourism. Who are the beneficiaries of this accreditation process and why do we need this accreditation at all? Hospitals and healthcare organizations should be places of safety, not only for the patients, but also for staff and other stakeholders. Quality of patient safety at hospitals and healthcare services is of great interest to the government bodies, NGOs, insurance agencies, professional organizations representing healthcare workers and patients. Accreditation focuses on establishing quality and safety in relation to predetermined standards, and accreditation encourages healthcare organizations to pursue continual excellence. Who are the beneficiaries of this? Mainly the patients, the organization, the staff, and the insurance bodies. So how are the patients getting benefited? They are the biggest beneficiaries here by getting the high quality of care and patient safety. The patients are serviced by the credentialated medical staff and right of patients are respected and protected. Patient satisfaction is regularly being evaluated. What are the benefits of organizations from the accreditation process? It helps the healthcare organization to stimulate continuous improvement. It enables the organization in demonstrating commitment to quality care and patient safety, thereby ensures best clinical outcomes. It raises community confidence in the services provided by the healthcare organization as services provided by credentialated medical staff. It also provides opportunity to healthcare unit to benchmark with the best. And accreditation status also provides marketing advantage in a competitive healthcare. The HCO standards have been certified by ISAQA, gives an international recognition, which will also help to promote medical tourism. Finally, accreditation provides an objective system of empanelment by insurance and other third parties. How it benefits the staff? The staff in an accredited hospital is satisfied a lot as it provides for continuous learning, good working environment, and leadership. Efficiencies and competencies of the staff also gets improved in an accredited hospital. It improves overall professional development, knowledge, and competencies in systemic ways with defined ownership and accountability of all the staff, including medical and paramedical staff. I should agree on this because I have worked in both NABH, JCI accredited or not accredited setup. And when it comes to accreditation, and we definitely thrive to maintain highest of the standards, and we are trained in handling emergencies, which definitely help us and our staff and the patients. So how does it benefit the paying and the regulatory bodies? The accreditation provides an objective system of empanelment by the insurance and other third parties. Accreditation provides access to reliable and certified information on facilities, infrastructure, and level of care. Now we know why we need accreditation. So how do we keep our department ready for this accreditation process whenever an NABH or JCI audit is due? First and foremost important thing is having SOP, that is Standard Operating Procedure Manual. We need to have a hard copy as well as soft copy of this manual in the department. This has to be prepared collectively by the technologist and the consultant and need to be signed by the medical administration. What are the points that we have to mention in this SOP? It is the introduction to the department, that is what are the facilities we have in the department, the functional organizational structure, that is who reports to whom, and this definitely helps in maintaining the workflow, the scope and objectives of the process, what are the nuclear medicine policies in place, how are the appointment and dispatch procedure being carried out, the consent procedure, the job description of each staff in the department, from nursing staff to the technologist to the doctor, and then the patient preparation and protocol for the gamma camera, PET-CT, as well as therapy procedures, management and receipt of radioactivity, radioactivity waste management, radiation surveillance, preventive maintenance of imaging equipments, quality control of gamma camera and PET-CT, and management of all the information pertaining to the department. Why do we need to have mention these procedures? Because it not only ensures the smooth flow, but also it gives comfort to the patient because they are well aware of what they are going through and how much time it will take for them to undergo this procedure and what are the precautions they have to take and what are the benefits as well as the risk by undergoing this procedure. It is very important that we convey all this to the patient when we receive the patient to the department. It is so important that the auditor, in fact, called a patient's attender and he asked what are the instructions that were given to him when he arrived with the patient and does he really know about the procedure. So education of patient is very important because we are providing the service and they are receiving our service and they have every right to the information. And they also want us to have a turnaround time in place. That is, what is the TAT for the reports that we dispatch. In our department, we have kept it as 2 hours within the performance of the gamma camera study and within 4 to 6 hours after the performance of PET-CT study. It may vary from department to department, but it is important to stick to the stat, and the stat has to be displayed in the patient waiting area so that patient convenience is being met. Then receiving the radioactivity. This is very important for any health organization or for a diagnostic center because when receiving the radioactivity, if it is done by a non-trained staff, it might be disastrous at times. So when it comes at the security gate, receiving the radioactivity, that is either technetium molybdenum generator weekly or fortnightly, or receiving FDG every day, or it is the therapeutic radiopharmaceuticals. The RSO in charge and our technologists have to be vigilant. And if at all, if they find that any package has been damaged, then they have to follow the steps and these steps needs to be put in the SOP. Unlike the hospital waste management, radioactive waste management has a special place with respect to not only NABH or JCAs, but also with day-to-day handling of our radioactive waste management as per the AARP requirements. So the register need to be maintained. Usually the radioactive waste, the syringes and the vials are discarded after 10 half-lives. That has to be mentioned and that has to be adhered to. And the release of effluents from the delayed tanks has to be strictly monitored and the register needs to be maintained. And radiation surveillance, that is what is the background radiation in each of the area within the department needs to be recorded. For this, we will have to take a printout of a small blueprint of the department, and we will have to mention what is the background radiation in each and every area, and this record has to be done every month and needs to be put it in a file and recorded. So the next thing they look into is a detailed consent form. Whenever a patient is undergoing either a diagnostic procedure or a therapeutic procedure, the patient is entitled to know the details of the procedure So we need to put in, for example, this is the prototype of the consent form for our PET CT, and they want us to put in what is the radio tracer that we are injecting, what is the half-life of this radiopharmaceutical, what is the likely radiation dose the patient is getting by this, what are the risks and benefits of the procedure, what are the alternatives to this procedure, what are the side effects they might expect whenever they are getting the contrast administered, all this to be put in the consent form. And the consent form has to be signed by the patient unless the patient is a minor or the patient is disoriented, not to understand the procedure, in which case a surrogate or the legal guardian needs to sign. And this is very important here, where the consent form has to be taken by the doctor and not by the nursing staff or the technologists. So we doctors, the nuclear medicine physicians, we have to sign in each and every one of these consent forms. When it comes to consent form of MPI, they are really particular because this is one procedure in the nuclear medicine department which involves certain amount of risk. So we will have to explain to the patient why he is undergoing this test, what are the alternatives available, that is dopamine stress echo or the cardiac MR, and what are the methods of stress, that is either physical or pharmacological stress. When it comes to pharmacological stress, we need to mention the side effects of dopamine or adenosine, and there needs to be a patient self-assessment form before we put the patient on TMT, which the patient declare fit, and then only we can take the patient. They also want the consent form to be in the regional language, that is the local language. Whenever a patient cannot understand English, they have the right to know it in the regional language and they have to sign the consent form. For the therapeutic procedure, they want us to put in what are the alternative methods of therapies available and what are the side effects that the patient might experience in detail to be included in the consent form. Again, they want who is performing this procedure and the doctor performing the procedure need to sign this consent form. Maintaining of the records is of utmost importance when it comes to the audit. What are the records that needs to be maintained? It is the daily QC report of the gamma camera and the PET CT, whether it is the CT or the PET QC, daily QC, or it is the gamma camera QC for the uniformity peaking and other things. We have to maintain a register that is hard copy. And the technologist who is performing the daily QC has to mention the time at which the QC has been performed and has to sign in the register. If at all, if there was any error or if there was any failure of the QC procedure, then they'll have to mention what was the failure which was noted, and we will have to also register what was the corrective action taken, when was it rectified, and who was the concerning authority, and what was the time within which it was rectified. Again, it all comes down to the fact that they want the best quality care to this patient, because if at all and the patient register needs to be maintained where the amount of radioactivity injected to the patient needs to be registered, and a complaint log, that is the register where patient register has to be maintained in detail, where the amount of radioactivity injected to the patient needs to be recorded and mentioned, and the person, that is the technologist or the doctor injecting the radioactivity, needs to sign in this register. And whenever there is breakdown of the equipment, that is either PET CT or gamma camera or any hot lab equipment for that matter, it needs to be the complaint needs to be logged, and the rectification of these complaints needs to be also documented. It all boils down to the best patient care, where they want to know in cases of breakdown of the equipment, what was the alternative arrangements made to the patients and how was the smooth flow of the patient care maintained. And then as we are injecting IV contrast for all the patients who are undergoing, most of the patients who are undergoing PET CT, any contrast reaction that we encounter has to be documented, and the radioactive waste disposal register has to be maintained in stringent. When it comes to the nuclear medicine physician's role, we have to keep the critical value register. That is, whenever we find a critical value which impacts the patient treatment or within a few minutes or hours, then we have to note down the such recordings and inform to the referring physician, which includes pulmonary thromboembolism, any brainstem lesions or coning or obstructive hydrocephalus, or there is any pneumoperitoneum or obstruction. These findings needs to be communicated to the referring physician, and the timing at which it was communicated needs to be mentioned. A separate copy needs to be taken out, signed and filed it in a register. Then for the peer review, if there are more than 2 nuclear medicine physicians in a department, the job becomes easy. But whenever there are when there is only one nuclear medicine physician, then the peer review can be done by sending the study and reports to any of the fellow nuclear medicine physicians and get it reviewed. We have to put it in SOP as to how much of the reports, that is either 1% or the 2% of the reports that we are getting reviewed. And then it comes to the therapy register maintenance, where the nuclear medicine physician will have to note down the date and time of admission of the patient and date and time of discharge of the patient, and what was the exposure at 1 meter when we were discharging the patient, and if at all if the patient encountered any adverse event within the hospital stay. And then the radiation review committee report. All the hospitals or the diagnostic center must have a radiation safety committee, and this committee needs to meet at least twice a year. In this committee, we discuss about the steps taken for best radiation safety practice within the hospital, and we discuss about the occupational exposure in minimizing the occupational exposure to the radiation workers involved. And those report need to be communicated to all the radiation workers, and these needs to be maintained and has to be filed in the committee report as well. All the staff in the department has to be trained for ACLS, including the nuclear medicine physician. And we all need to know the emergency course, fire and safety training, and emergency evacuation plan, to an extent that the auditor did ask our technologists to show how we would use a fire extinguisher. So with this, I would want to say that we now know what are the things we have to keep it in place when it comes to NABH or JCI audit. System awareness and system designs are important for health professionals, but they are not enough. They are enabling mechanisms only. It is the ethical dimensions of individuals that are essential to a system's success. Ultimately, the secret of quality is love. You have to love your patient. You have to love your profession. We have to love your God. If you have love, you can then work backward to monitor and improve the system. That is what Avidin Donabedian, a famous philosopher and a poet, said. So with this, I would say that we all love our profession and we are striving towards achieving best and to the best of our ability for the patient care, as well as to the progress of the nuclear medicine community. Thank you again.
If there are no questions, Arun, would you like to project the quiz question?
Any question, I would be happy to take.
Yeah. So if a hospital does not have NABH or JC accreditation, can we get separately for only nuclear medicine?
Sir, usually it is the part of the hospital process. Only for the department wise, they usually don't give. But if at all, if you are in particular wanting to take it, you can always apply.
So a separate diagnostic center can take this.
A separate diagnostic center can have it, but in a hospital setup collectively, having NABH or JCI audit only for the nuclear medicine department does not make any sense, because we cannot apply code blue, we cannot use various safety measures, and entire collective procedure cannot be in place.
Okay. Okay. Thank you.
Thank you, sir.
With that, we will move to the next speaker.
Just before the next question, Dr. Arun will show the first quiz question.
I hope my screen is visible.
Yes, yes, Arun, proceed.
Yeah. So we officially move on to the first quiz question for the day. Now, I think for anybody who has joined late, the quiz will work like this. So basically you have a option to answer as shown in the arrow. Lower down there is a question answer station. So once a question is displayed, immediately thereafter you can select the option and give your answer. You cannot change your option, and whoever gives the first correct answer would get the prize. So all the best. Anybody who has registered for the quiz can participate in the, registered for the conference can participate in the quiz. Okay, I think even the faculty can participate. Correct? So this is your first question. Now have a look at the picture. Careful look at the picture. So I'll show you the question. Yeah, you have to identify the place.
Show the image once again.
You want to see the image? This is the image. These are the options.
Dr. Kamlesh, you have to answer in the quiz, not live.
I think faculty cannot answer.
No, you should have entered from the
through the
normal website only.
Yeah.
Okay,
and
Arun,
this is how you answer. Okay. Time out?
Yeah, we can proceed to the session.
Okay. So the winners would be declared later in the day.
So I'll introduce the next speaker. I think Dr. K. Kumaresan does not need introduction, as most of the people in India knows about him. So he is the consultant nuclear medicine physician in KK Nuclear Scans, Hyderabad. He is the senior consultant. And I think in each conference, everyone will be interested to hear his talk. So he will be presenting about this time Dusras and Googlies with interesting scintillations in general nuclear medicine. Sir, you can proceed.
Good morning, Kamaleshwaran. I think you can pause the video for some time. Yeah. See, I have been in nuclear medicine for 34 years, and then I am part of the Southern chapter. Now we are 26 years past. I think now there are a lot of people in the field, and I'm sure everybody will have a lot of interesting images. And then I am looking forward to see all those things I think in the coming sessions, probably. I do not know. Still, I have been given this. So in the limited time, I am just going to share some few thyroid cases, because we all know that we know the natural course of the disease from our clinical medicine. And then we used to see all these case reports, but there is never end for surprises in this world. And nuclear medicine is an exciting field, you enjoy whenever you encounter such things in your practice. So let me have the video now, please. This thyroid function test showed suppressed TSH and T3T4 elevated. So he was considered that he is in thyrotoxic state. I don't know for what reason, for some strange reason, this person has undergone FDG PET CT, that too in a cancer hospital. And then they reported, as you can see here, this is FDG avid nodule in the left lobe of thyroid. It was reported about 1.8 centimeter size, and then SUV max is about 14.6. And then the interpretation was probably this person is having a AFTM. And then it was recommended they should have an evaluation with their technician conducted scan. Well, this is just 2 days after the FDG PET CT. We are doing the technician scan. And you can see here, this PET CT scan, in the technician scan, you can see there is gland is not at all visualized because there is absence of any trapping of present by the thyroid gland. So if you do not have this PET CT report, if your patient has come directly for you, and then I know that everybody will put a straightforward diagnosis of a subacute thyroiditis. But then here, there is a history of IV contrast for doing the PET CT, and just 2 days. So we do not know whether the contrast is interfering with the uptake of technician by the thyroid gland. So we said, yeah, this could be subacute thyroiditis, but we do not know whether this is due to the IV contrast, whether it is, we are not able to confirm a AFTM in this particular scenario, because that can be blocked by the contrast with it's possible, still we do not know. And we have no knowledge about those things then. So we said we have to wait and repeat the scan. Well, follow-up of the patient was treated as subacute thyroiditis because of his clinical presentation. As you can see, the neck pain and then fever, everything. So it was treated as subacute thyroiditis and it cleared over time and patient became euthyroid subsequently without any medication. So it is now the problem is, many situations like, in our practice, people try to go and get a PET scan, FDG PET scan done. This is not the first time I'm coming across. I've seen many other cases. We don't follow the protocol and then we just jump and then many of our younger colleagues, nuclear medicine physicians who are working only with the PET CT, when the patient is referred to them by a physician, whether it's right or wrong, they don't have the courage to say no, and they end up doing the scan, and then it complicates our situation when we try to interpret the subsequent technician scan. Now here is another patient, 65 years female. In March 2016, this lady had undergone sustained a fracture in the right femur, for which was fixed internally, and then fracture was not healing. And the image-wise, it was looking like a pathological fracture in 2017, and then they were trying to investigate where is this, because there is no information about any biopsy from the fracture site. So now when they were investigating, they did a chest X-ray in a cancer hospital, and they have done a mammography, and then chest X-ray shows that there is a nodularities, fine nodularity in the lungs. And then you can see in the breast, the right breast, the lesion was found. FNAC, what surprisingly said, there is a metastasis from the thyroid. This is the first time in my life I'm hearing thyroid metastasis in the breast tissue, though it is reported in the literature. And then excision biopsy of this also confirmed that this is a thyroid metastasis. Now we go back to the history. Now patient says that patient had a thyroid surgery for left lobe nodule 10 years earlier, but the records are not available. I am sure everybody would have come across such a patient, that some thyroid surgery done some 10 years earlier, it was reported adenoma or no records available. So now we know that that was a follicular carcinoma. So thyroglobulin is more than 10,000. Ultrasound scan shows 1.5 centimeter. Now the remaining right lobe, the patient is subjected to total thyroidectomy, then followed by iodine therapy. As you can see now, this iodine uptake in the remnant, iodine uptake in the pathological fracture site in the femur, and then there is uptake in the slight lesion in the skull. We don't see any uptake in the lung, but possibly that we will be able to see that now. After once the remnant is ablation, maybe the second dose probably will be likely to go to their lung tissues also. Okay. Now this is happening quite often in our practice. Now let us see in a different case. This is another very big surprise. This is a 34 years female, and she is a doctor by profession, and she was based in United Kingdom. And then she was found to have a long-standing neck mass, which was a nodule in the left lobe of thyroid. She was investigated a few times, like about some 6 years period, ultrasound and FNAC. They reported multiple nodules in the thyroid gland, and with the cystic component, predominantly one nodule in the left lobe and sub-centimeter nodules in the right lobe isthmus. FNAC was done maybe about once or twice, and it came as benign nodular goiter. And she was euthyroid, and then she was not prescribed any medication, and she was following with the same endocrinologist who subsequently didn't do any investigation. He was just seeing her and then leaving her alone. But gradually the size was increasing. And then recently, they decided to do a CSCT, and the CT scan showed a cystic nodular mass in thyroid, macronodules in lungs, and then decided they did a CT of the abdomen. They went down and they found a solitary lytic bone lesion in the intertrochanteric region of left femur. Now the patient decided to come to India. So when the patient came to me, first thing I asked, said, going through the history and everything, I suspected this could be a follicular carcinoma of thyroid. With the way it's presenting, serum thyroglobulin turned out it was more than 1,000 nanogram. So I said, you don't need FNS, you go straight away for a total thyroidectomy. They were very much hesitant to go for total. They said, oh, they said in UK, they said it is benign. Could it be some other lesion? Is this some other malignancy? Okay, they was convinced, and then total thyroidectomy was performed. It was histopathology came as more than 9 centimeters cystic nodule in left lobe of thyroid with 4.6 centimeters solid component, multiple subcentimeter nodules right of isthmus. The thing is, there is no evidence of malignancy in the entire specimen. Findings suggest only adenomatous. This report was given by the top histopathologist and expert authority in thyroid histopathology in Hyderabad. And then when I discussed the case with her, I said, what's happening? You can have difficulties in thyroid FNAC to say whether it's adenoma or carcinoma. You have the entire specimen and you are saying this is a goiter. Come on, this is a follicular carcinoma. This is the presentation of the patient. And then she says, okay, you confirm it by the suggested radioiodine scan for confirmation. I mean, this is the first time it's happening. Some pathologist does thyroid histopathology and then he requires radioiodine scan for you. Can you do a radioiodine? I said, no, I don't do a radioiodine scan. I give a radioiodine therapy and then do a scan of this patient because this is thyroid. So we gave a recombinant TS assisted therapy of 100 MCI and then we do a scan. You know, you were right. You can see the lung nodules also was taking the tracer, and then this is the lesion, solid pre-lytic lesion. This is also heavily taken. So this confirms this is a carcinoma thyroid. So these things all over the world can happen, not just India, that you still have, there are many situations. So it is even histopathology can fail. It is the natural course of the disease and the clinical course of the presentation has to be taken seriously. Okay, now here is another different scenario. Here's a patient, a 53 years male presenting with a chest wall mass. He is presented in March 2016. He has the mass in the left lobe of thyroid, and he has got a chest wall mass. Turned out is investigated with the FDG PET CT. You can see highly avid uptake here, as well as in the another lesion, the clavicle. There is another smaller lesion in the proximal left femur, and then you can see the thyroid mass. Okay, it was confirmed as follicular carcinoma, and then the patient had thyroidectomy, and then we are given iodine. So you can see, as expected, it's a differentiated malignancy. Even though FDG is positive, you can see good uptake of iodine in all the lesions, but no uptake is seen in the FDG negative lung nodules. Okay. So now one possibility is that we are not seeing, or we are not able to target the lung lesions because of the bulky skeletal metastasis taking away all the iodine particulate. So if you, in this scenario, we all know that if you keep repeating the iodine again and again, you will see the lesions. These lesions are not, we are not going to cure them, this bulky metastasis, and then you are not going to target all the diseases. And then the prognosis is not really good if such a scenario. Now the surgeon is a young surgeon, is a very aggressive, very competent surgeon. He decided to take out the bulky metastasis. Now, in 2017, he had done already given 2-3 doses. We don't see any great response either in the imaging wise. Then, if you see, once he resected the rib metastasis, then when we give iodine, you can see the lung uptake now, and they can see the clavicle. So he now went ahead and removed the clavicle metastasis or excised. Now you can see there is no residual metastasis in those two sides. Now, whatever is the residual disease, the lung and the femur is able to be targeted with iodine. And patient is, and we do hope. And we used to be very skeptical when we do touch a bulky metastasis. Sometimes there's a flare up of the disease, the dissemination of the disease, and then we have had earlier patients dying very fast with the rapid progression of the disease. In this patient, it was a pleasant surprise. Patient doing very well, and he's being on follow-up. We are just following him on thyroxine. Now here is one case, and this is the last case. In year 2000, this is a long story. This is a 37 years female. When she came first time, she is a nurse. She is assisting a surgical oncologist in the theater. She used to assist all kinds of head and neck surgeries in the thyroid cancers. And she was found to have a left supraclavicular lymph node mass. It was biopsied. It came as metastatic papillary carcinoma, lymph node biopsy. She was subjected, there is not a very big nodule not a palpable nodule in the thyroid. There was some kind of lesion in the left lobe, and total thyroidectomy and functional neck dissection was done. Histopathology turned out 1.5 centimeter tumor in the right lobe of thyroid, which was a papillary carcinoma. And 11 lymph nodes were taken out, and then in histopathology, none of them was reported as metastasis. This is what sometimes it happens. You have a lymph node FNAC says metastasis, you have a lymph node biopsy specimen gives metastasis, but when you take out all the nodes, then you don't see any metastasis. It was a very large mass. It was like 3.5 centimeters mass in the supraclavicular region. On the other hand, they said there's a chronic, non-specific inflammatory sinus tract on the left side of the neck within the lymph node mass. I don't know. Now we decided, okay, we said, okay, this looks like a low risk case. Maybe the lymph nodes are not metastasis. We said, okay, 3 millicurie when the scan was done. We see there is a avid uptake of lesion, some residual activity, thyroid bed, and the sternal notch. So 25 millicurie was given. And next, subsequently, we did a follow-up scan. When we did a follow-up scan in 2004, you see still there is significant activities remaining, and it looks like now it is in the superior mediastinal node. And then we see faint activity, diffuse activity in both lungs. So we suspected there is a lung metastasis, and then we went ahead and then we treated her with when we checked, the stimulated TG was 118, and then we gave 100 millicurie in 2004, and the second dose of 160 millicurie in 2005, because this mediastinal lymph node was looking very significant, little bit bulky, and then probably this may not go off with one dose. It is not very amenable for surgery also. So then when you give second dose, luckily with 2 doses, on follow-up, we found that everything was ablated. We don't see the mediastinal activity, we don't see the lung activity, and then with the stimulated thyroglobulin dropped to something around 20, between 20 and 25. And she has been following up very regularly. And then we have repeated 2006, 2007, 2009, and 2012. And then she was remaining clinically as well as imaging wise very stable. And then the TG dropped even, with the not a very good stimulation, of course. TSH was only 20, we had 8 nanograms. And radiographically, there's no progression of the disease. So we will follow. Everything going very fine. She's a Christian, Malayali Christian. Every Christmas, she brings me a very nice, delicious homemade cake. But then the story changes. You see here, she was developed diabetes. She was put on glyphosate and glycinase. Now she was on thyroxine, 100 microgram with very good suppression of TSH. We are very careful that the disease should not relapse further. Then in 2013, 2014, when we were following, because she was telling bone pain and we thought it's osteoporosis, and then we decided we'll attempt to reduce the dose based on, because her weight was around some 55 kg, 56 kg. So when we attempt to reduce the thyroxine dose to 75, the TSH was going up to 11. We went back to then again, we were forced to go to 125 microgram. 2017, she had an episode of hematuria, right? Casing was found, but Cox infection was suspected, but we couldn't have any evidence. She was stented for 8 weeks and stent was removed. She was fine. 2018, on 125 microgram, we were reassured that TSH is suppressed very well, and thyroglobulin was also under control. But now the COVID pandemic has come, and then in November 2020, on telephone, she was trying to contact us, and we could see that she had developed florid hypothyroidism, myxedema, hoarseness of voice, everything, weight gain, and her TSH came as 43 when the endocrinologists were treating the diabetologist. When you check, the TSH was 43, and then it was repeated and it was found the dose was increased to 200 microgram, but TSH was again 50. And we confirmed by T3 and T4 were very low. And then I was very furious. I was thinking probably she was not taking her medication. She was throwing tantrum. But Well, she's a very, very nice person, very sensible. She's a nurse. She knows her problem. And she reassured that she has been taking the tablets very religiously. And then there's no doubt. We couldn't understand why of all the sudden, when between 2002 and 2018, the thyroxine dose has been very well working around 100 or 125 with very good suppression. All of a sudden, then she will become into hypothyroid state. And we could see that medication is not entering. It is not as spurious TSH. So then we discussed, the endocrinologist decided he raised the dose to 250 microgram. And then she advised her to follow a gluten-free diet to avoid all kind of wheat products and everything. She says that she doesn't have any different new dietary changes in her life. Always she has been following the same diet now. Then we do not know what happened. But when you put her on gluten-free diet, within a month, we found that TSH went down to TSH, T3, T4 went up, TSH got suppressed. So then we could slowly bring down the dose from 250 to 200 to 152. Now in 125, it is again back. So she's fine. She also came again last Christmas with a cake. She's doing fine. But we do not understand what really happened in this period. One who has been taking, and then how that, because increasing the dose we are doing, and then when the gluten-free diet, when it is introduced, and then she came back. So maybe people who have this kind of experience, how they have managed it, they can tell us what is happening. So to conclude, so life is full of surprises. As you can see, surprises in cricket in the form of googlies and dusras. Nuclear medicine practice is no exception. Even a lifetime experience is too small to conclude that mine is the first experience. It is said that anything you see today, somebody has seen it sometime in their life in the past. So somewhere in the world, these things are nothing new. All these things are happening again and again. It is only new to us in our short life. So I am very happy to share this with you in this particular forum. Thank you very much.
Thank you. Your talk was very good. Only thing is still we could not understand why that gluten is giving that problem, whether it is interfering with the absorption of L-toxin. We are not sure. I mean, it's a very nice phenomenon you have brought it out. It's a very interesting thing. We don't know the reason.
Obviously, it is only absorption problem of thyroxine for her. She says there was no change in her dietary this thing because she was a Malayali. I thought whether she is taking tapioca suddenly or something, it changed cassava, which interfere with the thyroxine. But she says she lives in Hyderabad, of course. And,
actually, some time back, you may be aware that when they gave L-toxin along with the calcium, both of them were not absorbed in the intestine and they were excreting it outside. I think that phenomenon also is well known, sir.
Yeah, you know, I have heard a difficulty in finding out where is the thyroxine coming because somebody who is ablated, somebody we are not able to demonstrate thyroid tissue presenting with thyrotoxicosis. So that has been a problem, you know. But now someone who has been on 100 suppressed but suddenly becoming like this, it was really perplexing. And then the only way I could see that we could bring her back to the thing because after we stopped all the wheat products in that diet.
It's a very great task you have done, sir.
Thank you, sir. We'll move to the next talk.
Thank you. Thank you.
Kamleshwaran, you are going to introduce or shall I introduce?
Yeah, you can introduce, sir.
So Dr. Vijay Harish also is not unknown to us. She is quite a popular physician, nuclear medicine physician. He finished his DNB, PhD, and is a fellow of European Board of Nuclear Medicine. And he is now the senior consultant in Rajagiri Hospital, Kochi. So I request him to start the talk.
Good morning, everybody. Thank you, Dr. Harif, and the rest of the organizing team for having me here. My talk is titled Milk Scan, Newer Aspirations of a Basic Investigation. And what I would be doing over the next 10 to 12 minutes is a brief review on pulmonary aspiration, the different
Okay, okay.
neutralizing
நான் அதுக்குள்ள சரி
techniques that
அவரு
we have to
வந்துட்டே இருந்தார்
evaluate
ரூமுக்கு,
pulmonary aspiration
அதனால
apart
போய்
from just the milk scan. Swallowing in the setting of clinical oncology. And then I would speak about a modification of a traditional nuclear medicine technique for a new indication titled Old RP in a New Bolus. And with that, I'll be concluding. So to begin with, pulmonary aspiration has been defined as a repeated passage of food material or gastric refluxate into the subglottic airways, sufficient enough to cause recurrent pulmonary symptoms. So as we all know, the pediatric age group whom we normally encounter for a reflux study, it may be physiological, but it's no more physiological if the child is symptomatic. And aspiration can happen in two ways. One is an antegrade aspiration, that is during swallowing, and retrograde aspiration, which is known to occur subsequent to gastroesophageal reflux. And the children who most often come to us, in them, pulmonary aspiration is diagnosed if we are able to demonstrate recurrent gastroesophageal reflux or a dysfunctional swallow, or are able to clinically witness an aspiration. And the indications with which patients usually present to us for aspiration evaluation are with recurrent lower respiratory tract infections, with a history of regurgitation or vomiting after feeds, nocturnal cough, and long-standing symptoms. They present sometimes with failure to thrive, and older kids usually present with a feeling of food getting stuck in their throat. So one thing that is to be remembered is that antegrade aspiration is documented as more common and a more common cause for LRTI than retrograde aspiration. Nevertheless, it is the reflux study that is most commonly asked for in clinical practice, possibly because it is more convenient and easily available. So we will begin by describing gastroesophageal reflux scintigraphy or the milk scan. The tracer of choice is sulfocolloid or any colloid, as long as it is not any radiopharmaceutical that is not being absorbed by the GI mucosa. And what you would want is at least 4 hours of fasting. Ideally, these scans are timed in such a way that the timing of the scan is coinciding with the timing of the baby's feed. So there is the best compliance of that scheduling. What we do is we ascertain from the parents what is the normal volume that is being fed to the child. And in a small part of it, around 5 ml of it, we mix the sulfocolloid, and which is administered first, followed by the non-regulable milk or formula feed, whatever is being given to the child. And in case of in infants and small children, it is through a nasogastric tube. Or older kids, if they are able to drink, then we can administer it orally. I just need to ensure that there is no staining of the oral cavity and the esophagus. One thing that needs to be remembered is the NGT needs to be removed after administration, so that because the presence of the nasogastric tube sort of compromises the gastroesophageal sphincter. The position is supine, and dynamic images are required posterior projection for over 60 minutes. I prefer the posterior projection because that way the child or the patient is more compliant. And if you're evaluating aspiration, it's always good to have a look at the patient for any change in color, especially in babies, in case they're aspirating. So this is how a normal milk scan looks like. That is the tracer within the stomach, well distended, and this normal progression of tracer into the intestinal loops. And this is a positive study or a reflux and multiple episodes of reflux seen throughout the study. It is very rare for us to demonstrate the refluxate actually entering into lungs in a milk scan. However, there is enough evidence to show that in a symptomatic child, if it is GR positive, then it's more likely because it's more likely that the child has pulmonary aspiration. So besides the visual interpretation, a lot of quantification has also been done. For example, the grade of the reflux, a grade 1, 2, 3, that is evaluated by drawing ROIs over the esophagus, the number and frequency of episodes, the duration of reflux, and the percentage of reflux. And there is a good correlation between these indices and the clinical status and prognosis of the child. Now, quickly moving on to the saliva graph, the next scintigraphic procedure. Again, the tracer of choice is a technician labeled colloid. It was originally described by Heyman et al., wherein they said that a drop of the colloid is placed on the tip of the tongue of the child, and the child is positioned supine. And as the baby salivates and swallows, the saliva is stained by this sulfur colloid, and we are able to image the normal passage of saliva. But later, investigators found that the technique described by Heyman was not very sensitive, because sometimes the tracer just quickly went away from the mouth. So what they introduced was the infusion technique. So basically over here we had a 10 ml suspension of the colloid, the same activity, around 200 to 300 microcurie of activity, in a syringe which is attached to an infant feeding tube, and the tip of the tube is placed within the mouth of the child, and in a very, very slow rate, around 5 ml per hour, it is infused into the mouth of the child. And this is the technique that we followed. So this is what we see, posterior projection images, the tube containing the tracer coming into the mouth, and as the baby swallows, entering into the stomach. So this is a normal study or a negative scan where we did not see any aspiration. And this is a positive study where around the 6th minute, you'll see an abnormal extension of the tracer into the right bronchus and the right lung field, and eventually into the left lung field also. So that's about a salivograph. Another scintigraphy technique that is very, very rarely performed is something called a swallowing scintigraphy or oropharyngeoesophageal scan. For here, basically, it's around 10 ml of water containing labeled colloid, which the patient is asked to hold in his mouth. He sits upright in front of the detector, and on command, he is made to swallow with imaging performed, rapid dynamic images performed. And what we basically try to see here is the rate of transit of the bolus from the mouth into the pharynx into the esophagus. As I said, it's a seldom performed technique. So that's about the nuclear medicine techniques. Now coming on to swallowing. Since aspiration is many times described as a multifactorial and anatomically defined event, it is good to understand the different steps of swallowing, which traditionally has been described as 4 steps. The oral preparatory stage, which is under voluntary control. This involves mastication of the food, mixing with the saliva, and basically it's the preparation of the bolus for the swallow. Then the oral propulsive phase, which again is voluntary, and it is moving of the bolus to the pharynx, that's the back of the mouth. The pharyngeal stage, that is involuntary, and this is where most of our airway protection mechanisms come into play. And then the esophageal stage, which is basically movement of the bolus down the esophagus into the stomach. Now, how is this swallowing mechanism affected in head and neck cancer patients? So dysphagia is an unfortunate post-treatment complication that commonly occurs in patients with head and neck cancer. And it's both because of anatomic as well as neurological insults, and they produce site-specific patterns of dysphagia. Basically, their dysphagia depends upon the site where the tumor is present, the nature of the treatment, whether it was surgery or it was chemoradiation. Again, the surgery, the type of reconstruction, primary or was a flap used, and also other confounding factors such as the presence of mucositis or xerostomia. And pulmonary aspiration is a very common complication among this patient group, and it's most often underreported, possibly because of a silent nature, referred to as microaspiration, as it's not demonstrable. So how is dysphagia evaluated in head and neck cancer patients? It all begins with our clinical evaluation bedside. Then there's the video fluoroscopy, which since the 1980s has been considered as the gold standard. There are also other techniques that are commonly used, such as the flexible endoscopic evaluation of swallowing, SNMI, and manometry. Now, why do we need to understand, or why do we need to document and monitor dysphagia in head and neck cancer patients? It's mainly for the rehabilitation, because most of them would be on tube feeds and then need to be brought back to oral feeding. And during the rehabilitation, there are different techniques to rehabilitate them. Some of them being the use of swallow maneuvers, use of exercises to strengthen the muscles, the jaw, as well as the tongue. Optimization of bolus size, which is quite important because it is not always that a smaller bolus produces lesser aspiration or vice versa. Because some patients, they may actually benefit from a larger bolus as it provides a greater sensory input from inside the oral cavity, assisting in their swallowing. And as far as consistency is concerned, patients who have problems in the oral phase of the oral stage of swallowing have difficulty handling thick feeds. So that is why it's important to optimize the bolus size and consistency. And also there are other techniques such as electrical stimulation, tactile and thermal stimulation, and sometimes the use of oral prostheses also. So coming back to VFS or the video fluoroscopy. So this is how a patient is positioned for a video fluoroscopy. Then he's given different volumes of something called a barium meal, which is basically a thick viscous liquid, which is asked to hold in his mouth. There are different volumes, 5, 10, and 15 ml, which is asked to hold in his mouth and swallow on command. And the fluoroscopic images to monitor the movement of this bolus through his mouth into the pharynx and the esophagus. The greatest advantage of this technique is the excellent anatomical details that it provides. So the clinician interpreting this can have a good assessment of the integrity of the airway protection before, during, and after the swallow. And also, since it's performed with the patient sitting in the upright position, different maneuvers and different boluses can also be attempted. The greatest disadvantage of this being because of the high radiation exposure, this needs to be quickly performed. So the patient compliance may be low. And also, barium is not a natural food. And it's a very thick viscous liquid. The results may not actually correlate with the actual clinical status of the patient. And some patients may actually refuse to swallow the barium meal. So it was in this background that we introduced a scintigraphic procedure for the same thing, that is bolus volume estimation for head and neck cancer patients. This is the position of the patient. What we did was we used the same traditional sulfur colloid. We mixed it with around 100 ml of fruit juice, which was used as stock solution, and different bolus volumes, 5 ml, 10 ml, 15 and 20 ml, similar to the VFS, was given to the patient, which he holds in his mouth and swallows on command. And each radioactive bolus was followed up by a bland bolus, so as to wash out any residual activity. Upright position, anterior and posterior projection images. And these are the results. So we have a VFS of we have a corresponding VFS of the same patient for comparison. This is a normal study where you have the normal movement of the bolus into the esophagus. And again, in a scintigraphic study, different volumes with the normal movement of the bolus into the stomach, no evidence of any aspiration. This is a positive study where the patient aspirated on a 10 ml barium bolus volume. So we see the barium entering into the esophagus and outside the trachea. And we were also able to pick up the aspiration with a 10 ml fruit juice bolus. So the advantage over here for the scintigraphic technique is we are much more sensitive in picking up aspiration in patients who have a normal VFS. The other advantage for scintigraphic techniques being a more natural food can be used. We can label anything from a liquid to a semi-solid to a solid. And the bolus volume and consistency can be optimized. And since it's also being performed in an upright position, different maneuvers can also be used. The challenges that we face during performing this scan is it's quite time consuming because many of these patients do not understand the maneuvers that are being explained to them, and also they actually have difficulty in swallowing, so we need to be patient with them. You need a deglutition expert, or the clinician or the person performing the scan himself or herself needs to know the different maneuvers, so we are able to tell whether the patient is doing it right or not. And also there's a potential for contamination of the scan room in case the patient regurgitates or coughs out the bolus. So what have we done? We have potentially identified a technique which can be routinely used in the rehabilitation of head and neck cancer patients to evaluate the presence of microaspiration. This technique could potentially become a preferred technique of choice for estimation of bolus size and consistency in such patients. And also another patient group who can benefit from this technique are during the ICU patients during rehabilitation after long-term intubation. And in the present COVID scenario, this is a growing population. Thank you so much.
Yeah, thank you, Dr. Vijay, for a nice presentation. And it is the simplest scan we can do, but it is also a complicated one. So I'll have a question, like just one question. After doing a G reflex study, can we do an pulmonary aspiration like from the stomach aspiration into the lung, can it be done in the same sitting?
Actually, we do delayed imaging also at around 2 hours after a reflux study. We try to evaluate if there's any reflux site in the lung by imaging the thorax, but it's not very common that we see. It's not that we don't see it; we have seen it, but very, very rare that we actually see tracer in the lungs in a delayed image. Yes.
Okay. Because the clinician, they ask mostly if the aspiration is either from the stomach or it is from the mouth. So we actually do the 2 hour delayed imaging in all the cases.
Yes.
Yeah.
Is
okay.
it necessary to do a salivagram for 60 minutes? Can't it be shorter?
No, sir. No, sir. It is definitely, sir. That's 60 minutes is the standard. That's what I've said, but it's definitely shorter. In fact, what we have seen is at least we did in almost a little more than 100 children. The salivagram, and we see that if beyond 20 minutes, if we don't see it, we actually don't see it in the rest of the scan. So I would say a 30-minute study is a good enough study. Because again, compliance, the child compliance is important there.
And when you see the activity in the lung, can you differentiate tracheoesophageal fistula from aspiration?
Sir, it's a tracheoesophageal fistula that most often, I mean, again, that's an anatomical thing. We have picked up a tracheoesophageal fistula, ironically, in a reflux study rather than in a salivagram. But unless you're suspecting a tracheoesophageal fistula, it wouldn't, sir, because we are only doing a posterior detector. Maybe if lateral can be done, we can. And SPECT CT we avoid in pediatric age group. So saying yes, it is because of a tracheoesophageal fistula would be difficult.
Dr. Harish, actually, tracheoesophageal fistula we can pick up from a barium swallow itself.
Yes, sir. But again, the radiation in a barium swallow in a pediatric age, even though that is routinely done, the amount of radiation the baby gets in a fluoroscopy is much higher than what we would be.
That's correct. I understand, but that is also a possibility.
Yes, sir.
So the theme of the conference was from infantry to precision strikes. Now the infantry with its commander has already come out to the war field. I thank all the 4 speakers for their excellent talks. And I thank both the chairpersons, Dr. Krishna Kumar sir and Dr. Kamlesh for sharing the session. So before we move on to the next session, we will have the question number 2 of quiz. So for those who have joined late, you see a button called quiz in the right hand lower corner of your conference portal. Remember the correct option, because only the option will be shown. The answer will not be shown in the options. So this is question number 2. You can see the images. This is obviously a PET scan. You know what PET scan it is. And these are the findings. This is the CT finding. This is the fused PET CT finding. So question is, what is the diagnosis? And you have the options in front of you. Option A is carcinoma of breast. Option B is Menn syndrome. Option C is Teat syndrome. And option D is Poland syndrome. So go to the quiz button in the right lower corner. Select the correct option. You have the options shown here. And I'm showing you the images once again. This is the image. You have the PET image. You have the CT and fused PET CT image. While you are answering, last question fetched 59 correct answer. The winner is Mr. Vigneshwaran. We will contact you for sending you the prize. So we will move on to the next session. The next session is on lymphoscintigraphy. For this session, I'd like to invite Dr. Shelly sir, senior consultant from Apollo Hospital, Chennai, a DNB teacher, for chairing the session. Joining Dr. Shelly sir will be Dr. Binita Beck ma'am. She's senior consultant plastic surgery from Meenakshi Mission Hospital, Madurai. Dr. Deepak Chandrasekharan sir, who is supposed to join us, is busy in OT, so he will probably not be joining or joining a little late. Now I hand over the session to the chairpersons. Sir, please take over.
Good morning. So we are now into the session of lymphoscintigraphy. Before that, I thank the organizing committee for having given this opportunity to chair this session along with Dr. Benita. And we have 3 talks in this session. One, what is the surgeon expect from the lymphatic imaging? Next one will be about the lymphatic leak, and the third one would be about the axillary reverse mapping. So to begin with, I invite Dr. Shyam Sundar, who is the head of the Department of Plastic Surgery, Kaveri Group of Hospitals at Trichy, who has many accolades on him. So I invite him now to deliver the talk.
In cases of lymphedema, once upon a time, lymphedema was something like this. Good morning to you all. Today I'm going to talk about how lymphatic imaging has changed the microsurgical perspective in cases of lymphedema. Once upon a time, lymphedema was something like this, predominantly filarial, and pretty much every lymphedema, either whatever be the cause, it can be lymphedema precox or whatever be the cause, would end up something like this. Earlier, lymphedema surgeries were something like this. This is a very destructive procedure. It's called Charles's procedure, where basically we would remove the entire skin and convert it to a skin graft later. And this is another procedure called Thompson's procedure, which took the subdermal lymphatics into account, and it was called a Swiss rolling operation. These are all not my pictures. We don't do these at all anymore. And this is one more called Homan's. All these procedures currently are of historical importance, though they do find a role in certain select situations. Now, in the super microsurgical era, so you can divide lymph surgery into two, super microsurgical and pre-super microsurgical era. In the pre-super microsurgical era, it was predominantly a diagnostic tool. We could differentiate other causes of lymphedema, and we could separate lymphedema from trauma, obesity, and so on. It did not influence the management much in the pre-super microsurgical era. It was more a documentary evidence and to show that there is some kind of lymphedema. But the one thing that lymph imaging did was that cases started getting picked up at earlier stages. So people started thinking beyond and what to do in such situations rather than give compression therapy and other conservative modes of management. Now, when we look at a lymphangiogram, this is what we look for as microsurgeons. What is the limit of stasis? What is the limit of obstruction? Is there a dermal backflow? I will talk about each, why it is important, because it will determine our surgical plan, whether there are any lymph vessels or trunks at all, and are there collaterals. So each of these points is going to determine the surgical management. I'll show you with a few different situations. The reference is this fantastic paper where everything is pretty much underlined in this. So I'll just skip this and I'll go to the first slide. Now, this is a patient who was probably referred as a lymphedema, but if you can see, the tracer uptake is pretty decent. So after about a couple of hours, there's complete drainage. So what was thought of as a lymphedema is actually not. Now, this is again a situation where there was a suspected lymphocele. Whereas when you see the lymphocytogram, you can see that the drainage is almost immediate and it has gone to the axillary nodes after about an hour or so, which is pretty much on par. So this was not a lymphocele at all. This is a case where there is a primary lymphedema. You can see that you can look at the left leg. This patient has had repeat attacks of cellulitis. There is a significant stasis on the left side. And in fact, on the left side, you're not able to see the nodes, inguinal nodes at all. And there is a total absence of any lymphatic channel. So this is typical of primary lymphedema, where there is a total absence of lymphatic channels. It is usually bilateral, but many cases it can be unilateral. Now, this is a bilateral lymphedema with left side, which is more severe than the right. On the imaging, you can see the severe stasis there. And on the right side, you can see that there are some slightly better formed channels on the right compared to the left. You also are able to make out that on the left side, there are slightly dilated channels, but they are very few, and there are maybe very, very few fine collaterals that are seen on this. This is something interesting. This is a case of Prader-Willi syndrome, and with probably something like a megalymph formation. You can see the lymphatic channels are, there is a large amount of stasis. In the first series of images, you can see the huge lymphatic channels, megalymphatic channels, almost as large as veins. And you can see the effect, what has happened after the intervention. See the first picture below, you can see is before intervention, and second picture is after intervention, which is a manual lymphatic drainage. You can see also that the tracer has gone up. So these are all large lymphatics, but dysfunctional lymphatics. The lymph valves don't work. So this is a case of suspected lymphedema for evaluation. The cause is unknown. You can see that there is a large lymph vessel on the right side. It's a lymphocyte formation, whereas on the left side there is some uptake, and you can see there are abnormal channels that have formed here. Just keep a note of all these pictures because I will be telling you how it influences our surgical management. Now, this is what looks like a lymphedema. Typically, if you see this lady, it looks like a post-CA cervix irradiated with or something with the nodes removed. But the tracer uptake study is absolutely normal. So this is not a lymphedema at all. So if at all there is some artifact because of obesity, but she does not have a lymph problem per se. This is again a lymphedema where you see some degree of collateral formation and abnormal lymphatic channels. So you get these varying pictures in these situations. And this is a case where a lymphocele excision was done. Now, she opposed lymphocele excision. This girl probably had a paradoxical increase in size of the limb. Now, when we've taken a lymph angiogram, you can see that there is a significant stasis and there is a delayed tracer on the left side. That is, there are definitely lower nodes on the left side compared to the right. So probably what has happened along with the lymphocele excision is that some of the nodes have also been removed. Now, earlier with the restricted number of surgical procedures, all this did not matter. However, super microsurgery, which we do, has changed a lot of concepts. So currently, I'm not going to complicate. I'm going to talk about 3 different concepts. One is a free vascularized lymph node transfer. Basically, you take lymph node from some other part of the body. So if the patient has got a lower limb lymphedema, we tend to take it from the chest. We take the interpectoral nodes after doing a sentinel node analysis. And you can take supraclavicular nodes, or you can take the submandibular nodes, submental nodes along with the facial artery for transfer. So this is the first most common concept. The next is lymphatico-venular anastomosis. The concept in this is that the pressure in the venules and the small lymph vessels is the same. So earlier there was a concept called nodovenous shunt, where basically people used to transfer the lymph node and anastomose it to the large vein. But the problem with that is, though results were initially dramatic, the pressure across the systems would equalize because of a higher venular pressure, venous pressure. But whereas in lymphatics and venules, this does not happen. The last, it's actually, this is my favorite concept, is what I use in our setup here, vascularized lymph vessel transfer. In essence, it is a transfer of a very thin skin flap with lymphatics and anastomose to the lymph vessels. Now I'll show you the same set of pictures. With the evolution of super microsurgery, lymphatic surgery is totally different. So what was deemed incurable and became a problem for everyone to manage is actually now very much treatable, and you get good results provided you choose the patient right and the procedure right. So now the concept of lymphoscintigraphy is not just a diagnostic tool, but a fantastic tool. It helps us to manage. I'll show you how. So the same scenarios, I'm going to play the same set of slides now. Let us see how it will influence the management. In this case, we can see that there's nothing needed at all. It is just some kind of lower limb edema. So it tells you that there is no surgical management. Nothing is required for this case. Now, a similar case, what was thought of as a lymphocele, lymphoscintigraphy has told you it is not. So there is nothing much needed. Probably some compression garments or something will be enough. Now, in this is a case of lymphedema precox, where you don't get any lymphatic channels at all. So basically, you do not have any lymph channel to do an anastomosis to. This is where you can take one of 2 options. You can take a vascularized lymph node transfer or a vascularized lymph vessel transfer, both of which will work. But again, in this case, if you do take a lymph node from the groin, it's not going to work because there is hardly anything from the groin. So you'll have to go a little more, and you have to go to the chest, or like I told you, submental or submandibular nodes. Or alternately, we take a vascularized lymph vessel transfer, as in we take a small thoracodorsal artery perforator flap with its lymphatics and anastomose at the ankle. So when that happens, the lymph starts draining through the venous system. Now the same thing, lymphedema, which I told you. Now in this case, since there are some lymph nodes somewhere, so either lymphatico-venular anastomosis may work, or your free lymph vessel transfer may also work, or a lymph node transfer from the chest will also work. This case is actually the perfect case for a lymphatico-venular anastomosis because you have large lymphatics. Probably you have such large lymphatic trunks, very easy, minimally invasive procedure. You'll have to do multi-site, multi-channel lymphatico-venular anastomosis. So because here the lymphatics are well formed, but they do not work because of some deficiency of the valves. So when you connect them to the venules, it will start draining and this patient will likely have a good result. Now, in these kind of cases, always there are multiple options. Our preferred option in such a scenario is free lymph vessel transfer because it is minimally invasive, very easy to do. And for example, the lymphatic vessels are about 0.5, 0.6 mm in diameter, maybe even less, sometimes even 0.3, 0.4. To know how small that is, imagine your ballpoint pen tip. That is 0.7 mm. So that is the size at which we have to do an anastomosis. So our preference is for a VLVT. I'll show you a few examples. Now this again, you know, the moment you see this is not a lymphedema, but this is obesity. This patient is likely to do well with just a liposuction. So whatever minimal lymphatic backflow is there may just get corrected with the liposuction itself. So you can see the collaterals that have formed in this particular case. There's a large lymphocyte, maybe such a large vessel and a large collection. You will still be able to do a lymphatico-venular anastomosis, but generally getting veins in these kind of scarred limbs is very difficult. So you can see post lymphocyte excision with the worsening of lymphedema. What do we do? So these again have multiple options. My preferred choice will probably be to, since the obstruction is higher up in the groin, it doesn't make sense doing a lymphatico-venular anastomosis below. So you will probably have to go for a vascularized lymph vessel transfer. Now let us see our cases. So some of our examples. This is a case of filarial lymphedema. You can see the you can see that he does have a few channels here and there, but what we did for him was just a liposuction. It just opened up all his dermal channels. He's done very, very well on a long-term follow-up. This is another case where this looks like an infective raw area, but it's not. The lymph scintigram tells a totally different picture. You can see even after 2 hours, 3 hours, there's a lot of stasis. The reason why she doesn't have any leg edema at all, and this is because she has been bedridden because of the raw area. Now let us see what has happened. This is a free lymph node transfer. You can see that we've transferred the nodes here. We put a graft on top of it. Now you can see what has happened to the unoperated leg, which is the right leg. The lymphedema has started manifesting, whereas the lymph node transfer has corrected beautifully the edema on the left foot. You can see nicely it is. You can see the difference in the ankle and foot size in both of these cases. Now this is a lymphedema precox. You can see the obvious difference between the 2 feet, and you can see the delayed uptake and hardly there is any lymphatic channel on the affected side, and hardly any lymph node. Now this is a vascularized lymph vessel transfer. This is my preferred procedure in most of these cases. So basically we take tissue with some lymphatics. In this side, we have taken it from the opposite groin, and we have anastomosed it to the posterior tibial system. So what happens is this lymph gets sucked up like in a pool and goes right through the venous system and gets drained. You can instantly see how this is an on-table result. You can see how beautifully it has decompressed even on table. And this is the long-term result. Though there is a minimal ankle edema, you can see how the difference from the first picture and the last. So in summary, lymphedema has become closer curable with super microsurgery. Of course, still we need to do a lot more work. It is still in an evolutionary stage. Imaging does not just help us diagnose, but it helps us prognosticate. It plans the appropriate procedure as well. And imaging gives you a very, very good objective assessment of long-term surgical outcome. And it's also very nice to show the patients that they have done well, because sometimes the differences may not be very obvious on vision, but a good imaging study which shows that the patient is recovering can help them improve psychologically as well. Now, this is a huge filarial scrotum. I sincerely hope with the emergence of good imaging and with wonderful nuclear medicine specialists like Hari, I have to thank him for a lot of these, because any imaging I send to only Hari and discuss with him. Thank you, Hari, and the entire team for the honor and the opportunity. We hope that someday comes where we do not see such cases and we are able to solve all these problems. Thanks a lot.
Thank you, Dr. Shyamsundar. It was a very nice to hear like how lymphoscintigraphy has helped the surgeons to look forward in the management. And I have one small question. Like,
yes, sir.
it's a lymphoscintigraphy usually picks up some abnormal findings in the form of prominent channels or delayed to flow, like in very early findings in a clinically normal lower limb or upper limb. Usually clinically they are not considered to be a lymphedema, but then lymphoscintigraphy wise we see such patients. So with these findings, like how do you decide on the management?
It is very simple, sir. We always in lymphedema, the symptomatology always gives priority. Like as we always say, we treat the patient, not the image. So I personally would see if the patient has got a significant ankle edema. More importantly, I would probably assess after about 2 hours, making them stand in one place. That will easily mask out any latent edema. So with lymphoscintigraphy, this is exactly what I said, because a lot of the lymphedema precoc, you see, our experiences are with very blown out filarial limbs. Whereas if you talk to experts like Chen and such, who are the authorities in the West, they don't see cases like us because they pick up grade 1, grade 2 lymphedema. I have hardly seen a grade 1 or grade 2 lymphedema. So symptomatology is most important. If the patient is symptomatic, I will definitely evaluate further. And always the first line of therapy is compression therapy and not surgical. So surgical starts coming in when compression therapy and such becomes unmanageable. So that is when I would offer surgery in such a patient.
So do you advise any preventive measures on these limbs so that you can prevent lymphedema in the future?
Simple, sir. Just compression therapy, just compression garments. Sometimes it may just be a transient thing. It may not be a permanent issue at all. So we just advise compression therapy and we reevaluate. If their limb edema starts becoming worse, or they become, again, even for any lymphatic surgery, patient compliance is a must. So I do not offer lymphatic super microsurgery in patients who do not even maintain compression therapy and other things properly, because it's an integral form. Only if they maintain compression therapy for 6 to 7 months, the super microsurgical procedure takes over much later. So what we do is we do what is called a hybrid procedure. Even in such cases, we do a liposuction, reduce the limb. We use about 6 to 7 months to train them to maintain. Only then we go for the second procedure. So like you said, the prevention is always with compression therapy only, with compression garments. That's more than enough in most cases.
Thank you, sir.
Thank you so much, sir. Thank you, Hari and team, for the opportunity.
So we shall move on to the second talk. And Dr. Benita, do you have anything to ask for, please?
No, sir, it was very nice presentation, sir. It is very fantastic result, and thank you very much for the presentation.
Thank you so much.
So now I invite Dr. Madhusudanan Ponnusamy, who is an additional professor and head of the nuclear medicine at JIPMER, to deliver the talk on lymphatic leaks.
Good morning, everyone. When we hear the word leak in nuclear medicine, the first thing that comes to our mind is biliary leak. Say a leak from the common bile duct is usually seen downstream along the direction of flow of bile. In the case of lymphatic leaks, does it happen the same way? Let us see. I'm Madhusudanan from JIPMER. At the end of the session, the participants will be able to list the sites of lymphatic leaks and their causes, explain the principle of lymphoscintigraphy in imaging leaks, plan an imaging procedure to identify the site of lymphatic leaks. I'll show you a few illustrative cases. What are the sites of lymphatic leaks? If there is a lymphatic leak into the pleural cavity, it is called chylothorax. Whereas if it occurs at the mucosal surface of the pulmonary acini or bronchioles, it will manifest as chylotisis. Leak into the pericardial cavity is called chylopericardium, and that into the peritoneal cavity is called chylocystis. If there is an abnormality of lymph vessels on the mucosal surface of gastrointestinal tract, the patient suffers from what is called protein-losing enteropathy. There are other causes, but this is one of the most common causes. Leak from the mucosal surface of urinary bladder results in chyluria. Chyluria of genitalia and perineum are also noted. Leak into synovial spaces of joints is called chylarthrosis. Leaks can occur in the extremities as well, but for the sake of this discussion, we are limiting to leaks that happen in thoracic and abdominal cavities. What are the causes of lymphatic leaks? Primary causes are usually rare and include congenital dysplasia such as lymphangiectasia or cysts. Secondary causes are more common, and they are due to the disruption of lymphatic tracts as a result of neoplasia, trauma, inflammation, or abdominal surgery. Lymphoscintigraphy of the extremities is a commonly performed study for the evaluation of lymphedema in most of the departments. How do we do it? Radiculoid particles are injected either subcutaneously, intradermally, subdermally, or intramuscularly in feet or hands if it is for the upper limbs, and the movement of the trace is tracked over time. How do we evaluate the abnormalities of in the viscera, where the flow of lymph is from the organs towards the core? That is, can we use the same technique as used for abnormality in the extremities? Suppose if you want to look for abnormalities in the extremities, yes, we do see, because it is on the way. The lymph flows. The tracer basically labels the lymph and we see the movement of lymph. Can we use the same technique here? Yes. Let us see how. When there is a leak from abnormal lymph vessels, say on the serosal or the mucosal surface of gastrointestinal tract or in intestine, or in the mucosal surface of urinary bladder, what happens? There is a reversal of flow. This is because there is a difference in pressure gradient, that is a reverse pressure gradient due to leak, and lymph from major lymphatic channels start flowing backwards towards the leak in the organs. And therefore, what we see is lymphatic backflow, like I said, as a result of reversed pressure gradient. So injection of radiculoids into the lower limbs labels the lymph flowing in the major lymphatic channels. And thereby we can see the reversed backflow into these organs wherever leak is there. Let us see a few examples. Case 1, chylous. An 8-year-old female with a history of severe abdominal distension and malnutrition since 2 years presented to a tertiary care hospital. Actually, this happened in SGPGA. The patient had undergone ascitic fluid analysis elsewhere and it showed chylous fluid and had undergone multiple ascitic tabs. Every time a tab was done, she came back with abdominal distension within a few months, and then it became a few weeks, and then became a few days. So the child was in distress. So we were asked to find out the site of leak. After palliative ascitic tab, 300 microcurie of technetium-99m antimony sulfate colloid was injected subcutaneously in the first web spaces of bilateral feet. Static planar images of the abdominal pelvis were acquired every 15 to 20 minutes. So the first image was acquired at 30 minutes. We can see there is intense tracer distribution in the inguinal as well as bilateral inguinal and external iliac lymph nodes. And we can also see common iliac lymphatic tracts. If you look carefully, there is a faint tracer distribution originating from a common, this is a posterior image, so it's a right common iliac tract and extending outwardly. And it's seen better in 1R image, and it is visualized even better when the image is acquired at 1.5 hours. We had asked the referring physicians to tap the fluid before the one day before doing the scan, because that would have released some of the pressure in the abdominal cavity, allowing the leak to happen. And that is why probably we were able to visualize it. In the current era, we would have done a SPECT CT to see where it is located, where the exact location of the leak is. But in those days, SPECT CT was not there. This was done way back in 2008. So what we did, we injected a very small amount of, I think around 200 microcurie of technetium-99 ethylene dicysteine intravenously, and you can see the contours of the kidneys here. And this is the site of leak. So we could localize it arising from the lymphatic tracts adjacent to the lower pole of the right kidney. So in this way, we could ascertain the site of leak and also the anatomical relation to the kidney. However, the patient couldn't afford further treatment and left against medical advice. Coming to the second case, it's a case of chyluria. A 56-year-old female, known diabetic and hypertensive, had complaints of whitish discoloration of urine associated with frothing, foul smell, and passage of thick white clots for the past 4 months. She had undergone cystoscopy twice. Both the times chylous urine was drained, but they couldn't find the source of leak. Urine analysis showed light turbid urine and presence of triglycerides, glucose, proteins, and plenty of RBCs. 24-hour urinary protein was high, and the urine protein to creatinine ratio was also elevated. Filareal antigen test of this patient was negative. The patient had undergone one vesicle betadine installation elsewhere before reporting to our institute. So this patient had documented chyluria, and our task was to identify the site of leak. So we injected 0.5 millicurie of technetium-99m sulfur colloid subcutaneously in the first 12 spaces of bilateral feet, and planar images were acquired at 15 to 30-minute intervals initially and hourly later on. You also perform a SPECT CT. So if you look at the 5 minutes image, it's like extending from the extremities to the thoracic region. You can see there is a faint flow of tracer along bilateral lower limbs in the lymphatic channels, and you can see lingual lymph nodes as well. At 20 minutes after a brief period of exercise, you can see that a lot of tracer has flown along the lymphatic channels, more so in the right lower limb than on the left side. Also seen is a faint tracking of tracer from near the external iliac lymph nodes and extending towards the midline, somewhere near the region of the bladder. So we did a SPECT CT immediately after this image. You can see this is a capture of the cine loop images. You can see that the number of lymph nodes on the right side is more than on the left side, and there is a track of tracer arising from the level of the external iliac group of lymph nodes and extending towards the midline. So the three-dimensional images show the track of tracer going towards the midline and culminating in the anterior wall of the urinary bladder. We continued imaging. So 1.5 hours image shows somewhat more diffuse distribution of tracer. Probably the tracer has started mixing in the urinary bladder. And subsequent image occurred at 3 and 4 hours did not show anything because the patient had voided. Also, the flow of tracer along the lymphatic channels has ceased. We acquired another SPECT CT after 1.5 hours of this image. Similar picture, we can see the tracking of tracer from the right external iliac lymph nodes region. And the track is more intense now and culminating in the anterior wall of the urinary bladder. So this way, we could ascertain confirm the leak as well as the track as well as the origin of the leak. We also collected urine after the 1.5 hour image, and 1 ml was counted in a well counter. It showed 5,000 counts per minute. It could be radiocolloid. It could also be free pertectinate. That we cannot find out unless we centrifuge and throw out the supernatant and measure only the residual part. We didn't do that, but it is to emphasize that it's very important that radiopharmaceutical purity is more than 99%. Ours was 99.8%. The patient has undergone a vesicle betadine installation and is currently under observation. What are the treatment options for such patients? It can be broadly divided into non-surgical and surgical. Low-fat diet tends to reduce the production of lymph and therefore may reduce the leak over time. And sometimes ascitic fluid drainage or pleural drainage has to be done. That may be a temporary solution, and maybe over time it may resolve. If it doesn't, then definitive intervention is required in the form of surgical procedures such as ligation of leaking lymphatic channel, excision or sclerosis of chylosis and lymphangiectatic or lymphangiomatous tissues, or sometimes performing a chylolymphovenous shunt. Okay, if we get a patient like where we have to identify the site of leak, what factors should we consider? One of the most important things is the choice of the radiopharmaceutical itself. Size of the colloid influences how the flow of tracer or the flow of lymph is going to be, or the flow of tracer into the lymph. So the size is smaller, more colloid particles or radiocolloid particles are expected to enter into lymph, so better labeling. It is preferable to use filtered sulfur colloid, antimony sulfate colloid, or dextran. I wouldn't recommend dextran because of the higher background. If filtered sulfur colloid is not possible, the radiopharmaceutical preparation can be modified such that the heating duration ensures smaller colloid particles. I had mentioned before that radiochemical purity is very important, and the mode of injection is also important. Intradermal or subdermal injections may result in faster flow of radiopharmaceutical. Imaging is more or less similar, except that we don't need images of extremities as such. What is needed is more frequent images of the region of interest, that is thorax or abdomen. And it is better to use an all-purpose collimator rather than a high-resolution collimator. Meticulous planning and execution is important. It is very important we keep looking for a leak. It shouldn't be like routinely we acquire every 1 hour, every half an hour. No, it's not like that. You have to keep looking for this leak. Only then we can catch it. Another factor is leak dynamics. If the volume and rate of leak is high, higher are the chances of detection. Pressure gradient also plays an important role. How we can facilitate or improve the chances of finding out a leak is before scan, we can ask for tapping of ascitic or pleuritic fluid, and we can ask the patient to void before starting the scan in case of chyluria. After injection, it is better to avoid tapping of ascitic or pleuritic fluid. In case of chyluria, we should try to take an image before patient has the urge to void. Summarizing, primary lymphatic leaks are rare, secondary causes are more common. Lymphatic backflow occurs due to reversed pressure gradient, and therefore we can label the lymph with radiocolloid by injecting in the feet. Identifying the site of leak can help in planning intervention. Thank you.
Yeah, thank you, Dr. Madhusudana. It was a very useful and nice talk. And so, can you tell something about the chylothorax? Like, what is any experience or whatever you have done, and anything you have to say about chylothorax? Like I mentioned about what had happened in the pelvic region.
So far, I have no experience in chylothorax per se, but I presume that the mechanism must be similar, so the imaging protocol also must be similar. We should focus more on thorax. If we do it carefully, I think we should be able to find out the site of origin of leak.
Thank you. And then Dr. Pushpalata has a question like, what are the time intervals that you take static images?
Yes, sir. So it depends upon the flow of tracer. If the flow of tracer is fast, we have to take frequent images, more frequent images. So the earlier we catch the site of leak, it is better, because if we leave it, it will mix with the either ascitic fluid or the chyluria, and we'll not be able to find out the origin. Okay. So I think 15 to 20-minute duration is essential in the initial period. We should be able to find out the leak maybe within the first hour of the injection.
Okay. So suppose if we see tracer activity in the urinary bladder in the delayed images, say for example after 2 hours or something like that, will that alter the specificity of our studies?
Sir, if the study is to confirm that it is chyluria, it is fine. That should be sufficient. But if the question is to find out where exactly it is leaking from, then it will be a problem.
Okay, it was nice. Thank you, doctor.
Thank you, sir.
So we would now move on to the third talk, which is about sentinel node imaging and axillary reverse mapping by Dr. Padma. Dr. Padma is well known to everybody, so there is no need for any introduction. However, she is from Amrita, a professor of nuclear medicine with a lot of publications to her credit. I invite Dr. Padma to deliver that.
Thank you very much. Good morning, everyone. At the outset, I wish to thank Dr. Harishankar and the organizing team for giving me an opportunity to be discussing sentinel node imaging and axillary reverse mapping to this August audience. Sentinel lymph node biopsy has become a standard imaging tool in the surgical management of many of the early cancers. Its major advantages lies in the accurate staging, less morbid surgeries, better clinical outcomes, and a higher quality of life. We shall be discussing sentinel lymph node biopsy under the following headings. What are the most common indications? General considerations like what is the ideal radiopharmaceutical acquisition parameters, gamma probe techniques, few practical tips, and last but not the least, the recent advances in imaging. So sentinel lymph node imaging are routinely performed in many centers across India. So we are going to briefly discuss what is the sentinel lymph node imaging before we go into the practical indications. So sentinel lymph node imaging is the imaging of the first draining lymph node from the tumor site. It facilitates better nodal sampling. Ultrastaging is possible by the histological examination. And once the sentinel lymph node has been found to be negative, it can obviate the need for further extensive surgical dissections and nodal clearance. So early cases of CA breast with clinical node negativity, head and neck malignancies like CA tongue, floor of the mouth, early gynae malignancies like CA cervix, vulva, and endometrium, skin malignancies like melanoma, squamous cell, and basal cell carcinomas, or are extremely benefited by a sentinel lymph node imaging and biopsy. Rarely, we also encounter patients with CA penis, colorectal, and anal carcinomas for sentinel lymph node staging. So coming to the practical tips, how to choose the protocols, what is the radiopharmaceutical and the route of injection. We need to decide, are we going to go ahead with a single day procedure or a 2-day protocol? Usually the oral malignancies, skin malignancies do very well with a single day procedure because the nodal transit is very fast and we can visualize the node very early. The 2-day procedures may be requested by the surgical oncologist in patients with CA breast and gynae malignancies. So for a successful identification of a sentinel lymph node, the size of the particle is utmost importance because the radiopharmaceutical transit determines how soon the node is going to be visualized. So we must take care of the dosage, can keep the ALARA principle in mind, and based on a single or a 12-day protocol, the 2-day protocol, slightly we can hike up the radioactivity which is being injected so that we can promptly visualize the sentinel lymph node the next day also. So what is the optimal route of injection that we are going to take? Is it a superficial injection or a deep injection? This will basically depend on the site of the tumor and how deeply it is placed. Sometimes the CA breast injections are done deep, and also the centers use a slightly larger volume in them so that there is a better and prompt distribution of the radiotracer for the optimal visualization of the sentinel lymph node. Studies have also shown that interventions have been used after the injection by applying a massage over the breast injection sites to facilitate faster transit of the radiopharmaceutical and an early visualization of the sentinel lymph node. Some centers have also used hot packs around the tumor site, and patients where the melanoma or the squamous cell carcinoma of the heel is there, walking can be brisk walking helps us to find out or to determine the site of sentinel lymph node faster. Is it the popliteal node or the inguinal node? Controversies do exist on the use of local anesthetic agent prior to the injection of the radiocolloid. So this is one trial which has been published in Lancet Oncology 2009, which details about these controversial topic. Normally, the centers do not advocate the usage of local anesthetic because it is thought to impede the transit of radiocolloids and the delayed visualization of the sentinel lymph node. So the ideal selection of the radiopharmaceutical is broadly dependent on the local availability and the choice with the nuclear medicine physician. So a brief tabular column showing the different size of the particles of the radiocolloids which we are being used in nuclear medicine departments. Obviously, the unfiltered sulfur colloid cannot be used because this large particle size will clump and remain only at the site of the web space injection, and there will be absolutely no transit of radiocolloids, and lymph node visualization will be completely negative. So filtration of the sulfur colloid is ideal to get a 100 to 200 nanometer size. Centers also use nanocolloids. Now, the new kid on the block is the 19nm technetium tilmanocept, which is marketed as a lymphocyte. It is not available in India, but it is a novel tracer which is FDA approved. It is nothing but a DTPA mannosol dextran molecule. The mechanism of action is slightly different from the other radiocolloids. Here, it is found to attach to the CD206 receptor, which is found in abundance in macrophages and the dendritic cells in the lymph nodes. So the small size of the tilmanocept allows rapid lymphatic uptake, and the targeted receptor binding capacity limits its migration into the distal nodes. So coming to the acquisition parameters, so we need to decide, are we going to acquire a dynamic sequence study, or is it going to be sequential static images? And are we going to do a planar or a SPECT or a SPECT-CT imaging? So usually the dynamic imaging is best exemplified in head and neck cancers and in the squamous or the basal cell carcinoma skin malignancies, where we can miss the lymph node if we do not take a dynamic study, the sentinel lymph node. While for patients with gynae malignancies and breast, static images are more than enough for us to visualize the sentinel lymph nodes. Patients with head and neck malignancies, we need to give special attention for certain specific views, like apart from the right lateral or the left lateral view which is to be taken, anterior image of the skull is also required so that we do not miss out the contralateral lymph node because of the crosstalk. In the era of absence of SPECT-CT, marker images were very essential to pinpoint on the skin where is the site of the sentinel lymph node. Usually, prior to starting a sentinel program in any institute, there is a learning curve which is usually undertaken by at least 25 patients imaging and biopsy with a very high success rate of more than 96% and less than 5% false negativity rate. So we are going to limit our discussion today on the breast sentinel lymph node imaging and biopsy. As we discussed just now, dynamic images are really not necessary. Multiple sequential static images of the anterior projection is more than enough for us to identify the sentinel lymph node. And based on the size of the tumor, of the breast and the tumor, the sentinel lymph nodes are usually visualized. Various injection techniques have been put forth in literature. So the most commonly used injection techniques are the peritumoral, especially if the tumor lies deep within the breast. Then the periareolar intradermal. So this is usually undertaken if the tumor lies close to the axilla or when the surgeon wishes to document the presence of metastasis in the internal mammary chain of nodes, or if the breast tumor is non-palpable. So usually many of the centers undertake periareolar because it has a high yield and the detection rate of sentinel lymph node is the maximum. So another injection technique of importance is the lympho boost injection, which is nothing but a intradermal high volume injection where the injection is given at the areolo-cutaneous junction and around 8 to 10 ml of the radiotracers is injected. So here studies have shown that the identification of sentinel lymph node is the highest. So once the sentinel lymph node injection is done and the sentinel lymph node is identified, patient is gamma probed inside the operation theater. So here either a handheld or the other the probes are wired probes are available. It has to be sterile draped while using the surgery, and the sentinel lymph node shows a count statistics of 8 to 10 times higher than the background, which needs to be accurately located and removed for sampling. So we shall talk about some interesting instruments which are available these days, which are intraoperative gamma cameras, which are used for identifying the sentinel lymph node. Imaging is done per-operatively along with the biopsy. So this can be either a handheld type or a mounted type. So these are all very easy to handle, and the mounted variants also have a laser marker which helps us in accurate localization of the sentinel node. The next is very interesting, where high resolution 3D SPECT images is possible inside the theater by this nice cute looking instrument which is fused with the ultrasound, and thereby an ultrasound guided needle biopsy is possible. So this is very exciting because it reduces the intra-op time, the complication rate is very less, plus it's an accurate site from where the biopsy can be undertaken. So next is the 3D imaging and navigation. Here, this is another new instrument which is available. Here, there is a fusion of the SPECT with the 3D navigation system. It has got a direct correlation with anatomy, so it produces accurate orientation, localization, and identification of the sentinel lymph node. It also offers depth measurement, at which depth the sentinel lymph node actually lies. Thereby, it provides a minimally invasive access. So the operating time, everything is significantly reduced. And not the less, it also ensures completeness of the surgery with accurate precision. So this is the 3D imaging and navigation system. So you can see a handheld gamma camera is placed along with the navigation system. It has a CZT crystal. It has a display monitor where the sentinel lymph node is C, plus the processing unit. So it not only identifies the precise location of the sentinel lymph node, but it also provides the count statistics and at which distance and depth the sentinel lymph node lies. So let us move on to the next section of the discussion. This is axillary reverse mapping, ARM technique. So this is a very novel technique which we can offer to the surgeon. So this is there is no imaging involved in it. It is only a per operative mapping. So what is this axillary reverse mapping? It is the complete opposite of the sentinel lymph node imaging, where we are trying to save the arm lymphatics. So the principle behind this ARM technique is both the arm and the breast lymphatic drainage can be separated. So by identifying the ARM node or the arm draining node, we can safely remove the breast draining node during a sentinel lymph node biopsy or an axillary node, the axillary dissection, nodal dissection. So thereby, by preserving the ARM node, one can protect the lymphatics draining the upper limb so that there is the minimum risk for lymphedema to progress in patients later on in life. So our aim of performing an ARM is to map and preserve the arm lymphatic drainage during the axillary surgery. Normally, it is done in the same method of the sentinel lymph node, where 0.1 ml of the radiotracer, less than 1 millicurie of either filtered sulfur colloid or nanocolloid is injected into the web space after the induction of the patient. And the gamma probe is used to trace this count statistics through the entire forearm and upper arm to reach the axilla. So usually the ARM nodes lies within this area. So before we go into that study per se, let us briefly discuss the arm draining lymphatic supply. So the arm is having a superficial and a deep lymphatic drainage. So the cutaneous lymphatic plexus in the palmar aspect crossover to the dorsal aspect, dorsal lymphatics, and they travel along the major superficial veins like the basilic and the cephalic vein and empty into the lateral group. into the lateral group of nodes and superficial dentopectoral groups. This finally drains into the infraclavicular group of nodes. The deep lymphatics follow the radial and the ulnar and the brachial veins and thereby draining into the humeral group of lymph nodes. So the ARM nodes are fairly constant in their location and they usually lie within this area. So the ARM procedure relies on the existence of a lateral or a brachial group and not the axillary group, which is the sentinel node. So the identification of the sentinel lymph node draining the arm is either based only on a radionuclide method or by combining a radionuclide on a blue dye method. So this is a graphical representation of the location of the ARM nodes. And as I told, it is fairly constantly located 94 to 96% of the patients. So there are studies in literature, and one of the studies was done in our institute where we found that 90% of the ARM nodes were located above the second intercostobrachial nerve at this location. The other position is just below the axillary vein, location 2. And the third location is just lateral to the subscapular artipedic. So these are the three constant sites of the ARM node location, and there is a very less than 10% of these ARM nodes usually harbor malignancies. So if we can preserve the ARM node, the risk of lymphedema is drastically reduced. So let us conclude this discussion by the sentinel lymph node biopsy and ARM go hand in hand. We know that sentinel lymph node biopsy is a well-established indication in early malignancies and helps us in ultrastaging of nodes. Similarly, the constant position of the ARM node and less than 10% metastatic nodal involvement encourages us to recommend ARM procedure in the routine clinical practice so that patients who are undergoing axillary nodal dissection do not have the problem of having lymphedema later on in life. So thereby, this procedure offers a better quality of life and reduces the occurrence of lymphedema in these patients. Thank you very much for patience here.
Thank you very much, Dr. Padma. It was a very informative talk. Doctor, do you have any experience on this high volume injection that you were given for sentinel node with like lidocaine or any local anesthetics?
No, actually, we have not used high volume because I personally feel it may be very painful for the patient to be injecting at the areolocutaneous junction. So, and we never had any problem by undertaking the normal periareolar 0.4 ml volume injections in identifying the sentinel lymph node. So that is the first thing. Second is we've never used anesthetics because patient compliance, and if you counsel the patient, it is more than enough. That's what I feel. And that is another injection which which the patient has to endure. So when we can get something by the normal recommended procedure, why go ahead and do something which is not really useful to the patient?
Thank you very much, Doctor.
Thank you very much.
I'd like to thank the chairpersons, Dr. Shelly sir and Dr. Benita ma'am, for chairing the session, and congratulations to all the speakers who did an extremely wonderful job. Now we are moving on to the most important and exciting part of the conference, that is the inaugural ceremony. So this is the 26th annual conference of Society of Nuclear Medicine India's Southern Chapter. I am Dr. Hari Shankar. I am the organizing secretary and I am a senior consultant and head in the Department of Nuclear Medicine at Meenakshi Mission Hospital, Madurai. So I'll be introducing the dignitaries for the inaugural function. We have a very special person, Dr. S. Guru Shankar sir, who is the chairman of our hospital, joining for the inaugural session. We have Dr. B. Kannan sir, who is the medical administrator of Meenakshi Mission Hospital. And we have Dr. Ramesh Ardhanari sir, who is the medical director of Meenakshi Mission Hospital. We have the president of Southern Chapter, Dr. G. Rijju, who is joining from Trivandrum. And we have Dr. Krishna Kumar Ratnam sir, who is joining as president of IMA Madurai Meenakshi branch, and he is senior consultant and head of medical oncology, Meenakshi Mission Hospital. We have Dr. Harkirat Singh sir, who is the president of the National Society of Nuclear Medicine. He is joining from Bangalore. And Dr. Anshu Rajneesh Sharma, sir, who needs no introduction, who is ICNM Dean. He is joining us from Mumbai. And Dr. S. Karthikeyan, who is the secretary of IMA Madurai Meenakshi branch. So Madurai is synonymous with the word Meenakshi. We have around 700 people here from all over India and many from outside of the country also. So to just 1 minute, I'm explaining what is the significance of Meenakshi. Meenakshi means mean plus Achi. Mean means fish in Tamil and Achi means eye. The person with the fish-shaped eye, which is a beautiful trait to have in a person. So Lord Meenakshi was a warrior princess. She was the daughter of the ruler of Madurai. When she was born with 3 breasts. And it was told that when she meets the soulmate of her life, love of her life, her 3rd breast will disappear. She was a warrior princess. She conquered all over India and she reached Kailash, where she met Lord Shiva at his heavenly abode of Kailash mountain. At that time, she realized she has met her match in the sense not as a fighter, but as a soulmate. So her 3rd breast disappeared at that time. They both came back to Madurai. They were happily married and they have been ruling Madurai for thousands of years now. And she is bestowing us with all the benevolence that we ask for. So nothing could start the program without invoking the divine blessings of our protective mother, goddess Meenakshi. Let us start with a prayer song. May I kindly request our medical administrator, Dr. B. Kannan sir, to give the welcome address.
Yes. Good afternoon, respected dignitaries, delegates, and dear colleagues. On behalf of the organizing team, Meenakshi Mission Hospital, it's my great pleasure to welcome you all to the 26th annual conference of Society of Nuclear Medicine. Once upon a time, we used to have live conferences, live workshops, and face-to-face meetings, random interactions with people who we meet on conferences, banquet dinners. This may be our statement in future. And due to this pandemic, we started virtual conferences, hybrid conferences, which saved more time and energy. But let's hope to get back to normal old days, old conferences meetings, so that we can meet up. And Meenakshi Mission is very much happy to host this conference. Apart from the academics, we thought we could provide delicious, mouth-watering feast to your taste buds. No problem. We can have a feast of knowledge here at present. And once again, I welcome all the delegates, dignitaries, nuclear physicians, technologists, and other practicing doctors to this virtual platform. Hope you all have a good academic feast. Good luck.
Thank you, sir. May I now invite Dr. Ramesh Ardhanari sir to give a few words.
Can you unmute?
Unmute yourself, sir.
Thank you, Harishankar. Harishankar is one of the pride of our faculty. He is an outstanding academician, a Johnson medalist, high-ranking NEET PG student who took nuclear medicine out of choice and who is very dedicated to his art and who has really built up our nuclear facilities, including the PET scan, which is to a level that is unrecognizable from the time he joined. I congratulate him for that wonderful achievement. I would also like to just conclude by saying that the first Nobel Prize given in medicine was to Röntgen for his discovery of X-rays. And in a way that is somehow related to the conference that we are having today. So it's a matter of pride for radiologists and nuclear medicine people that the first Nobel Prize ever awarded was to the man who discovered the X-ray. I welcome all of you to this conference and hope you will have a good academic feast, and that the next time it may be a physical meeting where you will be able to see your old friends. Many of us have not met them for many years because we have not been going for conferences. I hope the pandemic will end. I feel it will end, and then we will be back to normal. Thank you very much.
Thank you, sir. Thank you for your kind words. May I now invite Dr. G. Riju, the President of Society of Nuclear Medicine India Southern Chapter, to give his President's address.
Good afternoon, everybody. On behalf of Society of Nuclear Medicine India Southern Chapter, it is my privilege and pleasure to invite you all for this wonderful meeting, which has been hosted by Madurai Meenakshi Mission Hospital. So it is a wonderful meeting, even though it is in the virtual platform. The sessions are so interesting and attractive that is reflected in the number of registrations which we received, which is an all-time record of almost 600 registrations before the conference started. So that's a good start. And so that we are also happy so that Dr. Harishankar has taken the challenge of taking up this, organizing this conference in the virtual platform. So even though we are all a little bit disappointed at the initial phase that we couldn't have a direct meeting, so that we can able to meet our colleagues, which we are missing for last more than two years. So even though that is in the virtual platform, so we are all come together, so that we are all associated, we are all supported, and then we are having a good academic feast, like as Dr. Kanan said. So even though we are missing our taste bud, but the brain buds are still active, so then enough and more, than this, that the feeds we are giving, which we are getting since morning. So then it's my duty and responsibility to acknowledge the people behind this conference. First, let me thank Dr. N. Seduraman, who's the founder. So I'm just remembering him as the founder, chairman of this wonderful institution. So then that's the first tribute to him. And then Dr. Gurushankar, so the young dynamic person, so he is in the chairmanship and running the hospital. So then I congratulate him for this giving us an opportunity to host this conference at your prestigious institution. And none other than Dr. Ramesh Arthanari. So he's a wonderful person. So then highly skillful person. So in your hospital. So we would all like to listen to you in this coming minutes of your experience in your surgical field. And Dr. Kanan, so then he has given a wonderful startup in the morning, and I mean in the afternoon. So that it is, thank you so much for giving us a platform to host this conference. And Dr. Karthikeyan and Dr. Krishnamar, thank you so for joining with us, and Dr. Ramesh, and thank you. And none other than Dr. Anshu, so he is representing Indian College of Nuclear Medicine. So I hope that he will join soon. And so then thank you very much, Dr. Anshu, Dinesh, for all be here and supported us for this annual meeting. So this, so I'm not going to have an extended talk here because that is when we have to finish, the program on time. So then, as rightly mentioned in this title of the program, that is the nuclear medicine from infantry to the precision strikes. So then it is covered almost all the basic fundamental nuclear medicine to the updated technology and then science in molecular imaging. So that is covering almost every area in touched upon every areas from basics to advancement. So it is a wonderful program, and 2 days I hope that everybody will enjoy. And all the delegates, that participating from India, and interestingly, so we have registration which has come from overseas. So then it's a good thing. So it's just quite surprising for us. Generally, in the chapter meeting, the international registration still happens, but with thanks to the virtual platform, so that we could have international participation. So thank you all these international delegates who are joined for this conference. Welcome you into India. In future also, then we wish that you will there will be more then attendees from overseas, so that we can share our ideas and experience that will be much be mutually beneficial. So then, with this, I would like to then conclude my inaugural speech by saying a big hi to all of you who have joined for the conference, who have registered for the conference, and thank you so much, Dr. Harishankar, for the enthusiastically taking up this challenge on difficult time and doing a wonderful job. Thank you, and best wishes for all of you. Thank you.
Thank you, Mr. President. It is no surprise to know that people of Madurai are highly spiritual, but the other fact is people of Madurai are also highly self-righteous. There is a famous Tamil saying, Tamil thing that everybody is taught even from the LKG. Aram Seyya Virumbu. Aram Seyya Virumbu literally translates to try to do charity. So that was completely changed. In Madurai, nobody remembers Aram Seyya Virumbu. It was completely changed to Aram Seidu Palagu. Aram Seidu Palagu literally means do charity. Don't just think of doing charity, do charity. It was changed by none other than our beloved and energetic, enthusiastic entrepreneur, Dr. Guru Shankar, who is the chairman of our hospital. Now I kindly welcome our chairman to give his chief guest address. Over to you, sir.
Thanks, Dr. Harishankar, for your kind words. Doctors, colleagues, and my friends, a warm good morning to all of you. Friends, 35 years back, when my father bought this land to build Meenakshi Mission Hospital, he borrowed money from the bank, then called as Bank of Majura. Now it is called as ICICI Bank. And with that borrowed money, he first initially built this hospital. It's just a small block, which we call as annex block. It is probably 10% of what Meenakshi Mission Hospital is today. It was started with that small building. At that point of time, it was a big borrowing for him, and he struggled in the initial days. Meenakshi Mission Hospital struggled to repay this loan back. So for 6 years, the hospital was not able to repay the equated monthly installments, EMIs. So in financial language, we call it break-even period. So for 6 years, the hospital was not breaking even, so which means they were not financing the banks properly as they have to. With Meenakshi, God's blessings, at the end of 6th year, the hospital break even, which means financially we came out of that trouble. And that was a landmark year for Meenakshi Mission Hospital. Fortunately, and with God's blessing, it was that year, in the year 1996, that is 6 years after the hospital was inaugurated. In the year 1990, hospital was inaugurated, and 1996, the Department of Nuclear Medicine was formed in Meenakshi Mission Hospital for the first time. And it was a historic year because it was not just for Meenakshi Mission Hospital. It was the first time a Department of Nuclear Medicine was brought to South Tamil Nadu. The whole of this region, the southern part of Tamil Nadu, was getting the Department of Nuclear Medicine for the first time. And from that year, the growth of this hospital has been phenomenally, it has been exponentially, we've been growing. And with God's blessing, with our doctors, with our teams, the success and the growth of this hospital has been, in larger credits, this can be explained. I don't want to go into it because it will be more of a talk about the hospital. So if someone was to ask me today to look back at this journey and ask me a question, give me 2 reasons or 2 most important reasons why this hospital was able to grow this much into a more than 1,000-bedded hospital in Madurai. We also have other hospitals. And how are we able to grow this much? Give me 2 reasons. I will say the first one to be is that we have invested in technology, which means we have continuously innovated. We got a PET CT here, PET scan here, top-notch equipments, not just in one department, but in all departments. In some cases, we have been the first one to bring equipments in the whole of India. Like we recently brought telemedicine, robotic telemedicine called Teladoc, which is the first time in India we have got it. So we have been the first to invest in innovative equipments. And that's the first reason, invest in technology. But the second reason is more important than the first one, because anyone can buy technologies. But to invest in people, which is my second reason, has made the big difference for our hospital. Having these conferences, having these events are ways in which we invest in people. Investing in our doctors, investing in our team, investing in our people in India, not just in our hospital, but across all other hospitals, and learning from each other has been a significant reason why we were able to grow and contribute in this journey. In that context, I thank everyone who was a part of the annual conference, Society of Nuclear Medicine in India. And a special thanks and congratulations to our doctor and the organizing secretary, Dr. Hari Shankar. Congratulations, sir, and thank you so much for doing such a wonderful job and being a part of our team. And to all the organizers and stakeholders of Society of Nuclear Medicine in India. Happy to see this conference and happy to see all my colleagues in this event. Congratulations and my best wishes. Thank you.
Thank you, sir. Invest in technology, invest in people. So I like to inform my colleagues of Nuclear Medicine Society that several of our doctors have been working in the hospital for more than 20 years. Their entire career has been in Meenakshi Mission Hospital. So thank you, Chairman, for your kind words. Now I request Dr. Harkirat Singh, sir, the President of Society of Nuclear Medicine India, to share his views.
Thank you, Dr. Hari Shankar. Good morning, Dr. Guru Shankar, Dr. Ardhanari, Dr. Riju, Dr. Anshu Rajneesh Sharma, Dr. Hari Shankar, other dignitaries on the dais, dear colleagues and friends. It's a great privilege and an honor for me to be part of this inaugural ceremony of the 26th Annual Conference of Southern Chapter of SNMI. Meenakshi Mission Hospital and Research Center is a premier institute of the country, and I'm told it's one of the largest hospitals in the southern state of Tamil Nadu. As I went through the brochure, I was mightily impressed by the number of awards of excellence which the institute has received. Congratulations, sir, to the great service to mankind and to the people of the country which your hospital is rendering. Nuclear Medicine Department, of which Dr. Hari Shankar is head now at MMHRC, is a well-established and old department, and they're doing a commendable job. And it's very heartening to know that MMHRC is hosting the conference this year for the Southern Chapter. Dr. Riju, who is a dynamic leader and president of the Southern Society of Nuclear Medicine, is a great visionary, and I'm sure with his guidance, the society is doing a great job and putting together a great scientific program. I wish the organizers all the success, my best wishes for a great academic feast. And as I see from the program includes something for everyone. There is a session for technologists. There are sessions for the young budding doctors. That's the ZUA session. And I see that there are a wide variety of speakers, learned speakers who are pioneers and well learned in their own specialist field. And I'm very sure that all the delegates will benefit from the deliberations and this high quality conference which is being organized at Madura. Thank you so much. Greetings once again. Jai Hind.
Thank you, sir. Now I invite Dr. Anshu Rajni Sharma, sir, who is the Dean of Indian College of Nuclear Medicine, to talk a few words. Sir has been encouraging young nuclear medicine physicians and bringing them into limelight by the banner of Indian College of Nuclear Medicine. Over to you, sir.
Thank you. Dear faculty and delegates of the conference, honorable guest of honor, Chairperson Dr. Guru Shankar sir, Dr. Ramesh, Medical Director, Dr. Kanan, Medical Administrator, my dearest friend, Dr. Riju, President of Society of Nuclear Medicine Southern Chapter, President SNMI, Dr. Harkirat Singh, Dr. Krishna Kumar, President IMA Meenakshi Branch, Dr. Karthikeyan, Secretary IMA Meenakshi Branch, and our dynamic, energetic organizing secretary, Dr. Hari Shankar. On behalf of ICNM, Indian College of Nuclear Medicine, it is my pleasant duty to congratulate and compliment the committed organizing team of Meenakshi Mission Hospital and Research Center Madurai to organize and host this 26th annual conference of SNMI Southern Chapter, a festival, a feast of exchange of scientific knowledge in the field of ever-evolving nuclear medicine. On the very auspicious day of Basant Panchami, or we can call it as Shri Panchami, the day is celebrated with Saraswati Puja, the goddess of knowledge. Very auspicious day for the conference inauguration. Meenakshi Mission Hospital, Madurai has been on forefront in providing state-of-art nuclear medicine services in the region since 1990, more than 30 years. Dr. Hari Shankar, the head nuclear medicine, has impressed all of us, being the dynamic ambassador of nuclear medicine and torchbearer of academics. At this occasion, I have no hesitation in saying that SNM India Southern Chapter has a long tradition, long history of performance, and is one of the most, I can say, the best active chapter in Society of Nuclear Medicine India. I wish good luck to nuclear medicine team at Madurai Meenakshi Hospital, the management, and the leadership of SNM Southern Chapter for grand success of 26th Annual Conference of SNM India. Thank you very much for giving me opportunity. Thank you, Hari Shankar. All the best.
Thank you, sir. May I invite Dr. Krishna Kumar Ratnam, sir, who is the President of Indian Medical Association, Madurai Meenakshi Mission Branch. When we brought in the infantry from nuclear medicine, the IMA branch brought in all the weaponry. So let us hear from you, sir.
Very warm good morning to one and all here, all dignitaries. It's indeed a privilege and rather pride to be a part of this wonderful occasion. I am Dr. Krishna Kumar Ratnam. I am addressing this not just as President of Meenakshi Branch IMA, but as the head of the Department of Medical Oncology and a person who interacts almost every day 3 to 4 times with Hari Shankar for all my patients. So I have taken this as a duty to be here for this inauguration. From infantry to the precision strikes, I think this very motto tells what has been in our institution. Seriously, from infantry to what Hari is doing today is commendable, and to have this kind of an academic feast, it is our privilege. And congratulations to Hari Shankar and this huge mammoth team. We've had more than 500, 600 registrations, I hear, and that too from overseas. That's another success story. And some of the interesting things which have been very innovatively done, like the session called Yuva, where you have the young people given an opportunity to voice out and then speak about their experiences and their expectations. We have a wonderful oration by none other than our mentor and medical director, Dr. Ramesh. And I am very, very sure that this meeting is has already rolled out in a very successful way, and it is going to continue to provide excellent academic fees to everyone who is attending. I wish the meeting a very, very great success. And once again, a very big thanks to the Society of Nuclear Medicine India for having given us an opportunity from Meenakshi Mission Hospital and also the IMA Meenakshi branch for collaborating in this wonderful event. All the best. Thank you.
Thank you, sir. Now we come to the concluding part of the inaugural session. That will be the vote of thanks. I like to thank my colleagues, my friends from PGI Chandigarh, my alma mater, who initially encouraged me to take up this responsibility of first conducting the conference. This is the first conference I am conducting and organizing. So I like to thank my colleagues from PGI for encouraging me to conduct this conference. And no words can be expressed for the amount of gratitude I have towards our management, our chairman, our medical director, our medical administrator, and senior managers, Mr. Dilip Adel, our entire designing and marketing team. They've been working with me every day to make this a successful event. And I like to thank the Department of Nuclear Medicine, my colleagues, staff members, without whom this would not have been possible. A special thanks to Dr. Kumaresan sir, Dr. Shanmo Sundaram sir, Dr. Kalawat sir, Dr. Kavita ma'am for giving me inputs regarding how to conduct the conference and giving us valuable insights. I thank the governing body of Southern Chapter for helping me out in organizing this conference. I thank the IMA Madurai Meenakshi branch for giving us the much needed help for conducting the conference. Special thanks to Mr. Sundarajan sir, who helped us in getting CME creditors through Tamil Nadu Medical Council. I like to thank our sponsors, GSK, Abbott, SNT, Curium, HCG, ITG, Cyfin, GE, Siemens, Molecular Cyclotron for providing us with sponsorship. And special thanks to Chairman Dr. Guru Shankar sir for giving us the seed money, without which this would not have been possible. I like to thank all the speakers, the guest faculty, and the chairpersons for attending and making this a successful meeting. And I like to thank all the attendees, and I like to thank all my friends for supporting me through this. And special thanks to the video technologies team from Hyderabad, Mr. Sheikh Basharuddin, Mr. Gautam, Madan, Kiran, Uday, Abdul Karim, who have been working day and night to make this not just a successful event, but really colorful event. If you see the designs, they made it really catchy designs. And I like to thank my family for helping me. And I like to remember my dad, who is not with me now, but I'm sure he is watching me from above, and he should be very proud to see me doing this. Thank you, one and all. We can conclude the inaugural session. Thank you. So with that, we will move to the next and the most important part of the conference, which is Professor Ramadas Memorial Oration. May I request Dr. Riju, the President, and Dr. K. Kumaresan sir to chair the oration. And Dr. Riju, can please take over.
So then I would like to share the screen, and this permission has to be given.
Bashir, can you please help Dr. Riju out?
Okay, sir. Share screen. It is. Please give the permission to share.
Sir, once you try now.
No. Is it visible now?
No, sir. No, sir.
Not yet. No.
Sir, in the background, please open the PPT. After that, you click that Zoom.
Yeah, the share screen, it is not showing the multiple participants can share simultaneously. That option I have taken.
No, just you select the only screen. After clicking that share screen button, there is some option will be displayed like screen, whiteboard, like that. Just you click that screen and
one participant can share or multiple participants can share.
only one, sir, only one. So please unmute Ramesh, sir.
You have to first open the PowerPoint and then go to Zoom, share screen. There you will then see the PowerPoint on which you click.
Yes, sir, that is correct. Otherwise, send to me, no, sir, then I will show from here.
Dr. Richu, sir, you can just close what all you see on the screen first, then open the PPT first, then just click on share, then select the PPT. Only PPT should be there on the background. You don't open anything else. I mean, there should be only PPT.
So please unmute.
Yeah. Is it visible now?
No, sir.
No, sir, no, sir.
Sir, please share it to us, sir. We'll.
Hari, do you have a copy of that with you?
Yes, sir. Then I will open otherwise in the other laptop. Oh.
So do you want me to show that slide?
Yes, sir. If you have, please show, sir.
After sharing, please give the access to Riju, sir. Remote access.
Okay. So I think in the meantime, I can just tell you a few words about Professor Ramdas. So Professor Ramdas was one of the most senior nuclear medicine physicians in our country. And, he was a professor with the Bernard Institute of Radiology with the Madras Medical College, as well as he was the first person, the first entrepreneur to have a Madras isotope laboratory he had in his private practice. He had a thyroid uptake probe and retinal scanner, and he was giving radioiodine therapy in his own private practice. I remember patients from many parts of South India, especially patients from us, from Visakhapatnam, Srikakulam, they used to come down to Chennai to have these studies, and they used to have this old images. Even I used to see patients in my practice coming with those reports from Dr. Ramdas. When I used to see them on follow-up, it was a very excellent work he has been doing. And he was the one instrumental in promoting the practice and the field of nuclear medicine in Tamil Nadu. And I remember him, he was a very fine gentleman. He was the president of SNM India. And in his period, he tried so hard to get a gamma camera. And today, of course, we have Dr. Prabhu is heading the Omandura hospital. He has a very good laboratory. And we all remember Dr. Vanita Prabhu, everybody were his colleagues. And he was also closely associated with Professor Arkat Gajaraj, who was the director of the Barnard Institute. And then he has contributed so much. In fact, on his name, Dr. Ramdas established a award for best paper on thyroidology in the Society of Nuclear Medicine as well. And today we have Ram Kumar. His son is also a nuclear medicine physician. So the oration was established as per the wishes of Professor Ramdas. And this oration is supposed to be delivered by a clinician who has a interest and knowledge about nuclear medicine to share his views to the nuclear medicine field. Over to Dr. Raju.
So, Dr. Riju, do you still have issue sharing your screen? Can I introduce the speaker? Dr. Riju?
My screen is visible now?
Yes, sir. Yes, sir. Only presentation need to open.
Yes.
Open your PowerPoint. Your PowerPoint. Another half an hour. Yeah.
Perfect, sir.
Dr. Riju, sir, we can see your screen. You can proceed.
Yes. I'm really sorry for the technical lapse. And just I have to quickly go through this Professor Ramdas biography. So he is born in Kaniyam Akkam village near Trichy. Just 1 second, I will. On 10th of May 1938, born to Mrs. Anuradha and Mr. And he underwent pre-university from St. Joseph's College, Trichy, and he did his MBBS graduation from Madurai Meenakshi College. And further, subsequently, he did post-graduation in radiotherapy in Madras Medical College. And he's a wonderful person who has a diverse interest. And he did from this MDRT, he has shifted his focus to nuclear medicine. He landed up in Radiation Medicine Center, the premium institute in training nuclear medicine courses in India at that point of time in 1970s. And he did nuclear medicine post-graduation from RMC. And subsequently, interestingly, so he did he diversified his area of interest because he's a pure academician. So he has taken interest into then radiological aspects, and he did post-graduation in radio diagnosis. And more interestingly, so he diverted from imaging into this children's pediatric disease. He did a post-graduation in pediatrics as well.
So he is basically is a very dynamic academician and is a learner, and he obtained post-graduation in radiology, pediatrics, and is a nuclear medicine physician, one of the first nuclear medicine physicians series in the country. So he worked in Madras Medical College and the Government General Hospital in Chennai, and become this subsequently over a period of time. So he developed the department in length and breadth. And finally, he retired as head of the department in Bernard Institute of Oncology and Cancer and in Madras Medical College. And he was the pioneer in setting up, the nuclear medicine services to this part of the country. He not only he limited his experience in confined to the one medical college, he started up a private lab, that is Madras Isotope Lab, in 1975. Remember that time, so nuclear medicine was just a very primitive specialty, hardly known to anyone. So very few takers, and it is difficult to make people to understand the importance of nuclear medicine. He has taken up that challenge. That was one of the first of the first series of private nuclear medicine in the country. That was the first in Chennai, and more probably the first in the South India to have a private nuclear medicine center way back in 1975. So his prime interest is on basically on thyroid work. At that time, nuclear medicine much more confined to thyroidology, and so he has extensive research and interest in RAA and in a thyroidal uptake and the thyroid scan using iodine 131 in those days. And the technology was limited, and he was utilizing rectilinear scanner. And many of the new generation, practitioners may not be so much then aware about the difficulties of handling rectilinear scanner, but the information was so unique. That's the reason this nuclear medicine especially has grown significantly. So the contribution like Dr. N. Ramdos is unprecedented, and it is one of the initial the stalwarts to start up this specialty in this part of the country. So if this contribution has been recognized by the Indian government as by giving a BC Roy award, that is the highest of the honor which anybody can think about getting in the country in terms of medical specialty, the science, and the contribution, entrepreneurship. So then it is put together. So he was given the BC Roy award in back in 1970 and 75. And so this man of great honor, enthusiasm, then accomplishment. So he has given immense stimulation for developing this nuclear medicine specialty in this part of the country. And he has had a very fruitful life, and he left us in October 2000 at the age of 62. So he left with the family, his wife, Mrs. Anuradha Ramdas, and Dr. Rekna Devi. She follows her father's footsteps and she's the head of leading the radiation oncology department in Apollo Specialties Hospital. And Dr. Ramdas Ramkumar, he truly followed the true interest of his father, that is in thyroidology. So he is a practicing endocrinologist as well as practicing nuclear medicine physician. So this the Professor N. Ramdas with his family and this young age group. He is a family man. And so we have with us today then Dr. Anuradha. So given a speech to hear what she feels about her father, and a message to all of us sitting here.
Riju sir, you need to increase the volume. It is not audible.
Very close by heart with the nuclear medicine Dr. Riju. All the very best. And I pray Almighty for the confidence to get grand success. Thank you. And Dr. Raju, senior consultant.
So then we are entering into a new era of science, and we are following the legends and the great the inputs which we are given, or the stimulation which has given to several people in that age and in that period, which has then exponentially increased over a period of time of what we are seeing today. So then on respecting a great contributor out to the nuclear medicine science, so then we traditionally we used to give honor somebody who has given a significant contribution in their respective field of medical science on behalf of Professor Ramdas. So we have this year, so we have a fully deserving, completely a dynamic person who has given immense contribution in his area of interest. It is my pleasure and privilege to introduce Dr. Ramesh Arthanari, who is the medical director of Madre Meenakshi Mission Hospital, and he is a senior consultant and head of the Department of Surgical Gastroenterology and GI Oncology. So this, it's my pleasure to introduce Dr. Ramesh. So he is Dr. Ramesh Arthanari was born in 26th of August 1958 at Salem, Tamil Nadu, and he did his MBBS graduation from the prestigious CMC Vellore in December 1980. And subsequently, he did the MS in General Surgery from All India Institute of Medical Science, New Delhi, way back in 1985. And later on, his interest was, passion was focused towards the surgical gastroenterology. So he did MCS from Madras Medical College, Chennai, in way back in 1990. And he was bestowed FRCS from Edinburgh, Glasgow universities in way back in 2008, considering his contribution in the field of minimally invasive surgery in gastroenterology. So then the professional space, so he from 1990 onwards, he was working as a senior consultant and head of the Department of Surgical Gastroenterology in Madre Meenakshi Mission Hospital, and he's a consistent contributor in the field of science in every area which he touch upon. He has been awarded with the various recognitions and honors, and he was, as the list is huge, I've just taken some of them. And then one is that the lifetime achievement, which is achievement as the best doctor award received from Indian Medical Association Madre Meenakshi branch in the year of 2008, and a much younger age. And Association of Surgeons of India and Tamil Nadu and Pondicherry chapter, he has bestowed upon an interest in recognition that the best teacher award. So then everybody would like to have that award to get a teacher, because the teacher that translates the knowledge into several the prodigies, and he has done that wonderfully. And he was awarded Dr. B.S. Sundarabardhanam Award, Best Teacher Award in the year of 2016. And subsequently, so he was acknowledged as the Tamil Nadu Medical Council as the Best Doctor Award in the year of 2016, among a lot more doctors working in this area across the state. And he was an inspiring teacher. So he was an inspiring colleague to all the people working around him, and he is a great leader. And he started the teaching program in GI surgery in Madre Meenakshi Mission Hospital way back in 2000, and he was performing advanced laparoscopic surgeries for the last 28 years, and he stayed in Madre Meenakshi Mission Hospital and from 2013 onwards, and serving hundreds and thousands of patients coming to him on a daily basis. he is a true leader, and he was past president of Association of Minimally Invasive Surgery of India. So then he was also adorned the position as a president of Indian Association of Surgical Gastroenterology in 2018. He is also a DNP examiner, and then he constantly interact with the newer generation and to spread his knowledge and experience to the youngsters and make them empowered into the newer areas of science in the field of surgical gastroenterology. So he has attended hundreds of conferences as a faculty and chair all across the globe, all across India and overseas. He is a renowned speaker and has delivered numerous invited lectures, both nationally and internationally. He has published widely. The list is huge. I cannot enlist on the number of the publications which he had, then in his professional career. So then he is blessed with family, Dr. Savitri Ramesh. So he has taken an interesting specialty, that is a fashion technology. She did doctorate in fashion. And Divya, a daughter doing PhD in robotics at John Hopkins University in Baltimore, and another daughter, Rachita, working in Dallas as a hardware chip designer. So then that is something which I noted. So then the children are in completely different field of science. But anyway, it is science is science, whether it is medicine or engineering. So ultimately the excellence persists, and it will percolate in the newer generation. So to conclude, Dr. Ramesh Arthanari is well-known all over India as an expert in laparoscopic and endoscopic procedures, and he got an exquisite skill for performing highly complicated procedures. And he is a true leader, whether it is in the hospital or it is in his peers and colleagues. And his teaching skills are excellent, and it has been acknowledged in the whichever position which is held locally and then nationally. So welcome, Dr. Ramesh Arthanari, for this prestigious Professor N. Ramdas oration for the 26th annual meeting of Society of Nuclear Medicine Southern Chapter. Welcome you, sir, then for the meeting. Over to you, sir.
Thank you. Can I share my screen now?
So Dr. Riju, you'll have to stop your screen share. Yeah.
So can you see my slides now?
Yes, sir, we can see it.
Yes, sir. Yeah.
Full screen mode, please. Yeah.
At the very outset, I would first like to thank the Southern Chapter of the Society of Nuclear Medicine of India for having asked me to give this prestigious oration. I must confess that this is the first time I'm giving an oration outside my core specialties of gastroenterology, endoscopy, and laparoscopy, where, of course, I have been given many orations, but so that I consider it as a singular honor to have been asked to do this. So I am going to speak to you on radionuclides in GI practice. And I would like to tell that my association with nuclear medicine started way back in 1982 when I joined as a postgraduate at the All India Institute of Medical Sciences. And we started a project for, because our unit with Dr. T.K. Chattopadhyay was interested in doing esophageal surgery. So we wanted to do post-operative motility studies on the pulled up stomach and see how well the motility was compared to, say, normal esophagus. And for that, we used to use the patients, give the patients meals with either chicken or vegetarian, injected with radionuclides, and then follow them and see how much time, gastric transit time was there. And we, and Dr. Chattopadhyay published quite a few papers on that. I will just give some basic introduction. I will talk of nuclear medicine studies relevant for the GI surgeon. I will not talk of PET or PET scans because that will make it too vast a topic to cover. And anyway, most of the lot of discussion during the conference will be on PET scan, so I thought I will skip that. So nuclear medicine is a branch of medicine that uses open source radioactivity. So why the name nuclear medicine? It is to differentiate it from radiology. Now, the fundamental difference between radiology and nuclear medicine is seen in this simple diagram. In radiography, there is an X-ray unit that produces the X-rays, which pass through the human body. And then there is a film or a detector, which then nowadays with a CT scan, it does a software integration to form an image, which is nowadays is so highly accurate that you can see on a CT scan the middle hepatic vein, the right hepatic vein, and plan for major resections or donor transplantation and other things. On the other hand, nuclear medicine uses the X-rays in exactly the opposite way. The medicine is given to the patient and the patient swallows it, or it is injected into the patient, and then it goes to the organ of interest, and then from there it gives its gamma rays, which come out, and then they are detected by the gamma detectors, and then an analysis is made. So this is the fundamental difference between the two specialties and why we had this thing. So you have this gamma camera, you have an image monitor, and then you give the radiopharmaceutical, and then you get an image, which is again computer-wise, software-wise, it is collated and gives a composite image. So here in nuclear medicine, the machines don't emit radiation, not the PET scan. I'm talking of the nucleotides. The patient becomes a source of radiation after ingestion of the radioactive material. The machines detect the radiation emitted, and then a functional imaging can be done. So when we look at nuclear medicine studies relevant to the GI surgeon, I thought of putting together a number of things. And what we have is the hepatobiliary scan, though it is popularly known as HIDA scan. Of course, nowadays we use the dimebrophenin, which is even better than HIDA because even at high jaundice, it can be excreted. We can do it for GI bleeds, for Meckel's. We can do denatured RBC studies to see for splenomegaly or for remnants after splenectomy if the ITP again comes back. You can do it for neuroendocrine tumors. It's a very big, very important use of nuclear medicine is in neuroendocrine tumors today, and also of course in GI motility, because you can follow the radiation and see how the motility occurs. And then there are other things like lymphoscintigraphy, infection imaging, which I'm not going to concentrate because they're not core GI things. So the first thing in which we as GI surgeons are so interested in nuclear medicine is hepatobiliary scintigraphy, often called by people as HIDA scan. Of course, nowadays we don't use HIDA. From HIDA, we went to Bolida, then to other Decida, then to now mebrophenin most of the time. And we use it in the evaluation of cholecystitis, in transplant evaluation. A very important use, which sometimes we use, is for bile leaks following surgery and for extrahepatic biliary atresia. So this is a normal HIDA scan, and in 15 to 20 minutes, when the dye has been given, you can see the right and left hepatic ducts, the common bile duct, and the gallbladder. So within 5 minutes after giving the tracer, the clearance is seen, and the excretion is noted in the biliary tract within 10 minutes. So it's a rapid way of doing the imaging. In 90 minutes, CBD and gallbladder will be imaged in normal individuals. In 30 minutes, in 90% of people. Most normal individuals will visualize that gallbladder before the dye enters the gut. The normal diagnosis of gallstones is made by ultrasound. Sometimes in acute abdomen, it will be complemented by either a CT scan or an MRI scan. And we find evidence of inflammation, evidence of gallstone. Then the treatment is fairly simple. But there is a percentage of patients who have the typical symptoms of a biliary colic. They say that they eat outside in a party or a heavy fatty, heavy protein meal. they get pain in the hypochondrium, but ultrasound shows no stones, no thickening of the gallbladder. A CT doesn't show any calcification. And in such patients, one of the weapons that we have to make a diagnosis is whether they have cholecystitis is to use a hepatobiliary scan. So we keep them fasting, and if the patient is not fasted, then sometimes you can't see the GB. So we like to keep them fasting at least for 4 hours so that the gallbladder can distend. And sometimes we don't give them long fasting, because then again lithogenic bile can collect in the gallbladder and the visualization can fall down. So we take images after giving the dye. If the gallbladder is not seen in 60 minutes, morphine can be given. The reason is that morphine causes contraction of the sphincter of Oddi, and then the bile duct sort of closes down, and the bile can then fill the gallbladder as the pressure rises. So in 60% of the patient, the gallbladder is seen in 60 minutes. So if you don't see the gallbladder after some time, and even after morphine injection, it suggests acute cholecystitis, even though you may not see a stone. And that gives sufficient indication for us to advise these patients. There could be cases of biliary dyskinesia, but they will benefit from cholecystectomy. Good hepatocyte function and non-visualization of the biliary structures is suggestive of a bile duct obstruction. These times only are good with the normal time. So this is a patient whom we had the same type of problems, and so we did a scan, and then we give them a fatty meal to see what is the ejection fraction of the gallbladder. So like the heart, the gallbladder also has an ejection fraction. When you give them a meal with sufficient fat and protein, the gallbladder contracts, and then you can see. Now, if the gallbladder doesn't contract at all or contract less than 50%, then that means that that is probably a diseased gallbladder. And normal should be more than 35% contraction in 60 minutes. So here the patient had a good response to the fatty meal. The liver was normal, the gallbladder filled fast, and it emptied fast. So this suggests to us that this patient doesn't have a biliary problem, a gallbladder problem. So we need not do an unnecessary cholecystectomy. There can be increased false negatives if there's an acalculous cholecystitis, the patent cystic duct, but poor contractility is definitely a clear indication of cholecystitis. Acalculous cholecystitis is a very rare condition, occurs in ICU patients, and we usually don't do much for these patients, and because they are very sick. And the only time when this is not an is that it is not really not an acalculous cholecystitis. It may be a 2 millimeter stone blocking a cystic duct, and then the patient gets acute cholecystitis, all the features. But the ultrasonologist is not able to image the stone. The CT scan is not able to image the stone. And then when you operate, you remove the specimen, you'll find the small stone stuck in the cystic duct. So the negative predictive value of cholecystitis by HIDA scan is 98%. So it's a very good thing to rule out a gallbladder disease. Another very useful, before MRCP came up, is the bile leak, especially after cholecystectomy. When there is a bile leak after cholecystectomy, if there's a large leak and there's a large amount of ascites, interpretation of the MRCP is complicated because the fluid in the ascites and the biliary fluid will be overlapping with the images, and you will not be sometimes be able to make out the biliary anatomy. There, the scan will be very useful to tell us what we can find out. And what all we can find out is the liver functioning? Is it taking up the dye? If it is taking up the dye, how fast does the dye come into the biliary system? And is there a leak from the biliary system? So this is a patient which we had maybe about 6 months ago. 45-year-old female, lab cholecystectomy done 1 month back, complaining of dull abdominal pain, MRCP 1 week prior, CHD CVD visualized, no filling defect, marker to fluid in the abdomen with a subhepatic drain in situ. And you can see here the biliary scan, and here you can see the very dark collections, probably outlining a dilated bile duct. And in the bigger images taken later, you can see very clearly that the bile duct is hugely dilated. This is a right hepatic duct, this is a left hepatic duct, and you can see that there's a complete cutoff of the bile duct, and that this patient has evidence of a bile duct injury, the complete cutoff. And when you have a complete cutoff, but there is no leak of bile, then we operate early. So there are two things. You have a complete cutoff, but bile is leaking. When bile is leaking, then the system is decompressed. Infection is unusual. So you drain the collection and you wait till everything settles down. But when there is no leak, then it's a closed system, and the tiniest infection will suddenly become a suppurative cholangitis, and that can immediately kill the patient within 24 to 48 hours. This is another study. Again, you can see the gallbladder, and you can see the bile duct is partially is cut off at the level of the head of the pancreas. Another case of 44-year-old man who underwent a difficult lab chole. On post-op day 1, bile leak from subhepatic drain. On post-op 3, subjected to mebrofin and hepatoscintigraphy. So why this and why not an MRCP? Because in an MRCP, the patient has to lie still in the machine for about 30 minutes. Patients who have undergone operation, who have got biliary collections, usually they are a little septic, so they have tachypnea, and they cannot lie still, and the MRCP acquisition is not as good because they are breathing so fast. So we can't, so we relied at that time, because this is not affected by those disadvantages. So this patient was found to have a cystic duct leak, but the bilioenteric communication was continuous. So immediately all we had to do was do an ERCP, place a stent, and you see here, the drain is there. This is a drain, and you can see that it is draining. So bile is leaking out, but within 1 hour, the bile has reached the bowel. So that means that bilioenteric continuity is there, and all we had to do was do an ERCP, put a stent, and then it just settled down. Another area of interest for surgeons in nuclear medicine is the GI bleed scan. Arteriography can be very precise, and it can be used as a therapeutic tool. The problem is the amount of contrast that is used, and some of these patients will develop contrast nephropathy, and if their creatinines are already high, there are some people who radiologists would refuse to do arteriography. Although our nephrologists say, the creatinine is high, the kidney has failed, go ahead and use it, we will dialyze it out along with the normal dialysis. Anyway, the patient will need dialysis. So there is a difference between what the radiologists think and what the nephrologists think, but many radiologists are now doing it even if the creatinine is high. Angiography is less sensitive compared to radionuclide studies. This is something that you must remember, that radionuclide sites have a higher sensitivity for diagnosing the bleed. It may not precisely pinpoint the location of the bleed, but it will tell you that there's a bleed. And once you know there's a bleed, then you can take some definitive action. Of course, today with the advent of the capsule, that has become an important addendum, but then the cost of the capsule and doing it comes to around 30 to 40,000 rupees. So many patients refuse to have it done. So you can see here that the amount of bleeding that you need for nuclear scan is a tenth of what you need for the arteriography. Angiography, which is, it has to be bleeding at the time of angiography, otherwise the vessel is in spasm usually, and so it is not seen. So what is the information we get? Is there an active bleed? If it is seen very early and it is seen in large amounts, it's a severe bleed. And we can make out generally whether the small bowel, which is in the center of the abdomen, or the large bowel, which is in the periphery. It is easy to perform, well tolerated, and even intermittent bleeding can be, because you can give the dye, and even if it bleeds after half an hour when the dye is there, it will again show you that there's a bleeding. So whereas in an arteriography it is done at that time, and if there's no bleeding at that time, you won't find it. You will have to again go by clinical things. And we can do the complete GI tract. And so the small bowel bleeding is centrally located, and the extravasate blood goes rapidly through to the ileum. Large bowel, the bleeding is usually in the periphery of the abdomen, because the large bowel lies in the periphery. So this is a patient for GI bleed, and after some time you can follow that this is a bleed from the colon. You can see this collection of blood at 18 hours in the left colon, suggesting that there is a bleeding. And actually this patient had a polyp in the colon which was bleeding, which was missed on colonoscopy because there was so much blood that the preparation was not good. This is another case of GI bleeding, and here the bleed is in somewhere in the right hypochondrial area, most probably from the hepatic flexure. But then when we followed it up, the nuclear medicine people, Hari told us that no, it is coming from somewhere in the right area fossa, and this was actually a polyp in the terminal ileum, ileocecal junction, which was bleeding, and then a simple resection, and the patient did very well. And this patient shows that there is mucosal hyperemia in the stomach, and you can see here that there is a collection of blood, and this was a polyp in the small intestine, which was bleeding, and which we very simply managed with thing. Extrahepatic biliary atresia is still the first investigation of choice is nuclear scan, because no other scan can tell you whether there's excretion or not, and whether the ducts are seen or not. So of course you can confuse it with neonatal giant cell hepatitis, but then that if you give Phenytoin or UDCA, it will improve. And this is a typical feature of extrahepatic biliary atresia. You see the hepatocytes are seen, but nothing of the extrahepatic biliary apparatus, even after 24 hours, is seen. There is no intestinal drainage. So this is a classical extrahepatic biliary atresia. And the earlier we diagnose it, unfortunately, that is not in the hands of the surgeon or the nuclear specialist. It's in the hands of the pediatrician. They must suspect. The prognosis depends on when we suspect it. In some countries, no matter what date, they will do a liver transplant today as the first line of treatment, because the long-term prognosis when you do a liver transplant is excellent with modern medicines. But in many countries like India and Japan, we will first do what is called the Kasai procedure, or a modified Kasai procedure, where we will do a anastomosis to the poured out hilum, where the small ducts will drain, and it is quite an effective procedure. And it done early, within 50 days, the results are excellent. The patients will do well, and some of them will develop portal hypertension and liver failure at the age of 15 or 16. But by that time they have grown, they can withstand a transplant. The family has had time to make money for a transplant, save it for a transplant, and then get the transplant done. And the results of transplantation today are excellent. So this is another picture just to show you that. Now for a Meckel's diverticulum, sometimes patient has repeated abdominal pain or repeated episodes of bleeding, and sometimes they diagnose it as appendicitis and they go in and remove the appendix. Now generally the rule is that every surgeon who removes the appendix should see the last 2 feet of the small intestine to see if there's a Meckel's diverticulum around. But most people don't do that. They just remove the appendix and come out. They want to show how fast they can do an appendicectomy. So that is not ideal. But when the ultrasound or CT does not show the appendicitis, you may suspect that there is a Meckel's diverticulum, and this is a classical appearance of a Meckel's diverticulum. You see the stomach is outlined by the nuclear radionuclei, and you can see here in the right fossa dense accumulation, which is probably the heterotrophic graphic mucosa in a Meckel's diverticulum. So this patient, if the patient is bleeding or has pain, has probably got a Meckel's diverticulum and requires proper treatment for that. In neuroendocrine tumors, there's a tremendous role for nuclear medicine. This is one of the premier areas of nuclear medicine today. And it is used for diagnosis, it is used for treatment, and it's also used for targeted therapies. So the targets could be the various receptors, metabolic properties, or the antigens expressed. These are the various treatment. We have been recently doing quite a few Totonacs because in our unit we get a lot of referrals and we see quite a few neuroendocrine tumors, both functioning and non-functioning, and we tend to rely on the nuclear scans to help us to do whatever is required. You have a number of agents you can use. So it can be used for initial staging, for restaging, for prognostication, selecting patients for PRRT, or other procedures that can be done. So this patient has a duodenal carcinoid with liver. This is not our patient, it is taken from a textbook. This patient has a duodenal carcinoid with liver metastasis and cholangiolytic abscesses. So that is the duodenal NET, which is highlighted in the CT scan and which shows the uptake in the nuclear scan. And these are the secondaries in the liver, which are, again, you can see the secondaries here and they are lit up. So this tells you that this is not a gastric cancer, but it's a carcinoid with liver metastasis. So it can be used in a primary NET stomach for initial staging, and you can see that you have multiple liver mets already present in this patient on staging. So your treatment is essentially going to be palliative. Some people will do gastrectomy, remove as much metastasis as possible, give cold octreotide therapy, and follow up after. And these patients can live for many years with a diagnosis of thing. So another patient who had upper GI, there's a mass at the pylorus, which was a gastric carcinoid, and you can see the DOTA PET scan showing the area of the carcinoid being picked up, and there is probably multiple liver secondaries in this patient, which lights up on a FDG PET CT scan, and also seen on the DOTA neck. So this is a way of prognosticating and treating patients with NET. In NET, the most important thing is differentiation of the tumor. Whether it's a well-differentiated tumor or a poorly differentiated tumor. Poorly differentiated tumors have an aggressive course. They're FDG PET positive, and even if giving chemotherapy and doing liver transplant, they don't do well. And the most famous survivor of NET for a long time was Steve Jobs, chairman of Apple, and he had 2 liver transplants for the secondaries which had developed. And when he developed it a 3rd time, the doctors advised him not to have, and he also decided that no point in getting it done. He has suffered so much, and he let go of it. You can also do therapeutic treatment for NET, for metastatic or inoperable PHEOs, paragangliomas, neuroblastoma, and in NET, the new kid on the block, not really new. I attended a seminar in London in 2012, which was only a 1-day full consensus meeting on NETs, what is to be done, where all of us voted into what is to be done. And there were some premier speakers, including Andrea, I forget her second name, who's a world famous researcher in PRRT. And they use it for metastatic and inoperable NET. And the patient should have a life expectancy of at least 6 months. and they should have a low Ki-67 mitotic index, and they don't like to do it for poorly differentiated because it doesn't respond and it doesn't do that well. And they have been doing this for quite some time, and there are various types of treatments that are available. And this is the algorithm that is being told for the treatment. This was based on the complete consensus at that meeting of all the experts who sat there, and they gave a final opinion on what to do. It's a busy slide, so I'm not going to go through the slide, but it just indicates that in modern management of NET, nuclear medicine stands at the very top. A surgery, only if it is localized or it can be completely resected. If you can't completely resect it, then you do a partial resection, and then you have to use nuclear medicine to take care of the remaining tumor. It's very important. So in NET today, nuclear medicine is the prime, I would say, way of dealing. One last slide, I'm not going to go through everything in this, and that is for gastrointestinal motility. As I said, I first became interested in it in 1982 when we did this thesis study for gastric motility in patients who had undergone a esophageal replacement with a pulled up stomach. And we used meals with chicken injected with the radionuclide, and then it swallowed, and then we followed it down the stomach to see how long it takes to pass, and whether adding a pyloromyotomy to gastric pull-up was essential. So we had two groups of patients. One we didn't do pyloromyotomy, one we did pyloromyotomy. We looked at the follow-up, and we did find that there was slow transit in patients who had pyloromyotomy, but within the normal clearance of the stomach, it would clear itself. So in many centers, then they stopped doing pyloromyotomy for gastric motility. So you can look at motility from various esophageal motility. You can look for enterogastric reflex and all these, which I'm not going to go into all the details because I think we were already running a little late. But I just want to leave you with so this patient was a patient who had, for bariatric surgery, a mini gastric bypass. And the patient was complaining of reflux. So we want to know whether there was any reflux. And because of the altered anatomy, we found it difficult to use a 24-hour pH monitor to do this. So we used a biliary scan. And what we saw was that the liver was normal with good parenchymal function. And the biliary activity in the gastric pouch, there was no reflux till 4 hours. So this told us that reflux is not a significant problem, and the patient's symptoms are not due to any significant reflux. So we could just reassure the patient and send the patient home. So I would like to conclude by saying that radionuclide medicine has come a long way. Some of the indications which are very important earlier on are not so important today. But some of them which were not there in the past are very, very important today. NET being the prime example where almost the entirety of the treatment is in the hands of the nuclear physician. And apart from that, of course, you already heard lectures on scintigraphy to map lymph nodes, and even in stomach it has been used. But nowadays, since we have found indocyanine green and the cameras that can recognize indocyanine green, it's very easy to inject the indocyanine green and look for the nodes in the stomach or in the esophagus. So we have started to follow that protocol because it is built into the scope, into the system, and it doesn't require any special gamma counters or anything. And we can just proceed with just changing the light and seeing the indocyanine green. But it has got a terrific role in many other areas. And the nuclear scan with the PET also coming in has made it not only a very important part of the management, but to any hospital, it becomes one of the highest profit earning departments in the hospital. And I am proud to say that our hospital, when we bought this machine, we had some doubts whether we'd be able to break even, because we didn't expect to get many referrals from outside. We had to contribute most of the patients from our side. But we're happy to say that we get a lot of referrals from outside, because Hari's reports are so good that, and people recognize that, and they are sending him patients from all over South India for a PET CT. And credit totally goes to Dr. Hari, and the machine has broken even. It has created enormous profits for us. Thank you very much for your patient hearing. Thank you for this opportunity to deliver the Professor Ramdas oration at your annual conference.
Thank you, sir. May I request Dr. Kumaresan sir and Dr. Riju to take over the proceedings?
So it's a very proud moment for us to have Professor Ramesh Ardhanari to deliver the oration in the name of Professor Ramdas. You have been given a full vista of how radionuclides has been used in the field of gastroenterology. I know some tests, as you said, fades away and some rebound and come back when you find the real need. You know, this is happening in imaging, and every time when, of course, there will be always a competing modalities for every field, and then whenever a competing modality tries to do, I mean, you can try to do everything what nuclear medicine can do, but you can never have the same efficacy in some areas, and then it still holds true. And then, of course, it depends on the local expertise, as you said, like you are lucky to have Hari Shankar, and then you, depending upon the requirement of each institutions across the country. And I know there are many colleagues here, you know, we have the Asian Institute of Gastroenterology in Hyderabad. They have a very big department now. I mean, you can imagine that how they are using for every year. And then it's only up to you to find out how to stretch the limits, and there's no end how you can use this modality. Thank you, sir, for the excellent oration in honor of Dr. Ramdas. Dr. Raju.
Thank you, sir. Thank you, Dr. Ramesh Ardhanari. So that's a wonderful oration, and you have done a great journey of experiences, and you have done a wonderful experiments with specialties like nuclear medicine. And we have a lot of expectations so that, you know, the people like you and, you know, then this the various other specialties will have much more fruitful collaboration with our specialty, so that, you know, then it will be mutually beneficial for the specialties, and ultimately it will benefit for the patient. So it is my duty to then bestow the order on behalf of Society of Nuclear Medicine India Southern Chapter. So then we are ordering with you this prestigious Professor and Ramdas oration for the year of 2022 on this date of 5th of February 2022. And so we have a citation to hand over you, but unfortunately on a virtual meeting, so that we can't hand over you directly. So, but it will definitely reach you on within just a couple of days. So this, I would like to then elaborate on this citation's content. Just let me read the citation, the content of the citation. Society of Nuclear Medicine India Southern Chapter is honored to bestow Professor N. Ramdas Memorial Oration upon Dr. Ramesh Ardhanari, MBBS, MS, MCH, FRCS, during the 26th annual conference conducted at Meenakshi Mission Hospital and Research Center, Madurai, Tamil Nadu, on 5th of February 2022. Signed by President and Secretary, Society of Nuclear Medicine India, Southern Chapter. Thank you, sir, Southern, for being here and accepting our invitation to accept this great honor on behalf of Professor N. Ramdas. And so we are expecting much more collaboration in future with our specialty, and Dr. Hari Shankar is there to help you out whatever the need from our specialty. and in our future, then we'll see in much more nuclear medicine platform in various occasions. Thank you, sir.
Thank you.
Over to Harisinger.
Thank you, sir. We now proceed to our next session, which is the cardiology session. For the session, I'd like to invite Dr. Jayapandian, who is a senior consultant cardiology at Meenakshi Mission Hospital, and is not just a cardiologist, he's also an electrophysiologist. So we have topics relevant to him for today. And joining him will be Dr. Vijay Raghavan, who is nuclear medicine physician, who is also joining Dr. Jayapandian. Before we move on to the session, let us have one quiz question now. Arun?
Yeah. So we have had a great inauguration and a scintillating oration. So it's almost lunchtime, although we don't have an official lunch break. So we will take this quiz question something like an appetizer. Okay. So quickly, for anybody who has just joined now, so this is how you answer for the quiz. On the right-hand corner, lower down, you see the quiz button. Once the questions are shown, you can answer. Remember the choices, because only option 1, 2, 3, 4 will be shown once you are going to answer. So right after the question, you can see the options and you can click an answer. Whoever gives the answer first, gives the correct answer first, will win. Okay. And the winner for the previous question number 2 is Dr. Madhur. So Dr. Madhur, the organizers would be contacting you soon to give you the gift check. Okay. So we'll move on to the question. So you can carefully have a watch at the images. Okay. So once you've seen the images, this is your question. Now the coronary vessel or the vessels that are involved. Option A is LAD, B is RCA, C is LCX, and D is triple vessel disease. I'll show you the images again. Once again. So these are the options. And this is how you answer. Okay. I think time is up. So we will move with the rest of the session. Thank you.
Over to Dr. Jayapandian, sir, and Dr. Vijay Raghavan. Would you please unmute yourself?
Hari, can you?
Yes, sir. Yes, sir.
Can you hear my video? Can you see my video?
No, we are unable to see your video.
Okay. Is there any issue or no?
No, we are unable to see your videos.
My side is not a big issue.
Okay.
Your side, anything? You cannot start your video because your host is disabled my video.
Okay. Yeah. Now we are able to see you.
Okay. Hi, Hari. Yeah. Can you hear me?
Yes, sir. Yes, sir.
Okay. Thank you for giving the opportunity. This is an important session for us, and in cardiology and nuclear medicine is a add-on thing. For example, in ischemic heart disease and knowing about viability. The main thing for me associated with Harishankar for last 1 or 2 years, we are concentrating on the inflammatory cardiomyopathy like sarcoidosis. Our diagnosis will be very much helpful after the getting nuclear studies to find out the inflammatory cardiomyopathy for further treatment also. This is my brief introduction. We'll discuss one by one. Thank you.
Dr. Vijay Raghavan, would you like to introduce Dr. Satish Nath, sir?
Yes. Thank you, Dr. Hari, first of all, for giving this opportunity. So we have some interesting topics for today. So the first of the topic for discussion is, where is the block? MPI guiding precision identification of involved vessel. We would like to invite Dr. Satish Nath, who doesn't require much of elaboration. He's head of the department and senior consultant at Mayot Hospital, Chennai. Sir, over to you for the topic.
I thank Dr. Harishankar and the organizing committee to have chosen to give me this lecture and share my experiences. Where is the block? And can myocardial perfusion images guided perfusion precision identification of the involved vessel? Let's talk about the coronary artery territories. Now, if you slice an apple from the apex to the mid base, we have 4 segments in the apex: the anteroseptal wall and the anterior wall, which generally is supplied by the left anterior descending. The inferior wall is supplied by the right coronary artery, and the lateral wall supplied by the left circumflex. In the base and the mid ventricular walls, we have the same, but here the LAD territory supplying anterior wall and the anteroseptal wall, the right coronary artery, the infroseptal and the inferior, and the left circumflex, the anterolateral and the ipsilateral wall. The vertical long axis, segment 17, is the apex, which can be supplied by the LAD or the RCA. Left main is a large territory. Left main takes its origin and gives rise to left anterior descending and the left circumflex. So you have the involvement of the apex, the LAD territory, which is basically the anterior and the anteroseptal wall, and the left circumflex territory, the anterolateral and the infralateral walls. Proximal LAD, when the stenosis is before the diagram, so it is known as the proximal LAD lesions. So here what is involved is the apex, the distal and the basal anterior walls, and the distal and the basal anteroseptal wall. Mid and distal, it is between D1 and D2 is the mid LAD, and if there is a stenosis, we can see only the distal, anterior and anteroseptal wall and the involvement of the apex. What is the left circumflex territory? It is the whole of the lateral wall. Left circumflex takes its origin from the left main. It gives rise to 3 branches: the obtuse marginal 1, obtuse marginal 2, and obtuse marginal 3. We have the ramus vessel, which takes its origin from the left main. It is a variant. It's seen in approximately 37% of the patient. It is between the LAD and the left circumflex. So if you get a lesion somewhere involving the LAD and the LCX territories, that is the anterior wall and the anterolateral wall, it is the involvement of the ramus vessel. The inferior wall is supplied by the right coronary arteries. It is proximal, mid, and distal RCAs and gives rise to 2 branches, the right posterolateral and the posterior descending artery. This generally supplies the inferior and the infroseptal walls. Now you can have a left dominant and a right dominant system. We're going to see the right dominant system. In the right dominant system, you have the posterior descending artery arising from the right coronary artery. So besides having the infroseptal and inferior wall, you may have the apex and the infralateral wall involvement. You can have a left dominant when PDA arises from the left circumflex. So left circumflex is basically the anterolateral and the infralateral. If you see involvement of the inferior walls besides the infralateral and the anterior walls, you can think it could be a left dominant system. We need to identify branch arteries. In branch arteries, we know the involvement of diagonal. You have the sparing of the apex and sparing of the base. And if you have And mid-ventricular defect, it basically sparing the apex, sparing the base, it's a diagonal trajectory. Similarly, PDA, in which you may have an isolated infroseptal wall involvement, sparing the apex, sparing the base. Visual analysis. First, we have to look at the size. We can tell whether the defect is small, medium, or large. When do you call a defect to be small? When it is less than 10%. We call a defect to be medium when it is 10 to 20%, and more than 20% is a large defect. What is a mild defect? When there is a decrease in count compared to the adjacent wall with preserved thickness. So this is very important. You see the normal wall, you see the involved wall, and if the count is less and there is preserved thickness, then it is a mild defect. What's a moderate defect? When there is thinning of the myocardium, and a severe defect when there is absolutely no uptake and the uptake is equivalent to that background. Now, this is a small defect. This involves approximately less than 10%. Obviously, it is 1 or 2 segments. So if you see 1 or 2 segments defect, it is a small, mild defect. It's a medium size. Defects is approximately less than 3 segments. So you have the septum that is preserved. You have the apex. So around 3 segments defects is a medium size. This is less than 20%. So this is a medium size defect. And large defect when there is a greater than 4 segments, that is, you have a large infralateral defect in this patient. Now, what is the amount of ischemia? Now, the medical management versus revascularization depends on the amount of ischemic myocardium or jeopardized myocardium. It has been found that if the amount of ischemic myocardium is less than 10%, both medical therapies as well as the revascularization are almost have equal outcomes. If the ischemic myocardium is more than 10%, then revascularization proves better. So we have to mention the amount of ischemic myocardium. Now, what is this patient? This patient, what you're able to see, this is the short axis slices, this is the apex, and this is the base. Now, what you're able to see? We're able to see an anteroseptal defect in the stress, which shows approximately partial reversibility. So you have a severe defect in the anteroseptal. It's a medium-sized defect, which is showing partial reversibility. So what you're going to say, extent and severity of defects. So it is approximately 3 segments. It is involving the apex. It is involving the anteroseptal wall and mid-ventricular anteroseptal wall. So it is apex and mid-ventricular anteroseptal slices. So it is a small, medium, or large. It's involving 3 segments. So it's generally a medium-sized defect. Location of the block, we should say it's LAD, LCX, RC, or a branch vessel. It is involving only the anteroseptal and anterior territories. So it is basically a proximal LAD block. Does it need revascularization? Is the ischemia greater than 10%? Definitely. You have at least 2 or 3 segments which are reversing. So it would need. So it is a medium size, moderate, severe stress-induced ischemia in the distal anteroseptal wall. So what does the angiograph say? It's a single vessel disease in which there's 100% occlusion to the proximal LAD. So proximal LAD has moderate calcium and is occluded totally. Let's see this patient in which you have a large defect in the infralateral wall. And you see the apical slices are reversing, but the basal slices remain fixed. So you can see the basal inferior wall is fixed. So that's partially reversible. This is the area in the infralateral wall which is reversing. So what is the extent, severity, and size? It's a large defects or two medium-sized defects. That is some almost involving 6 segments. And location of the block is, it involves 2 territories, the anterolateral and the infralateral. Does it need revascularization? It's partially fixed and partially reversible. So you have the LCX territory, which is fixed, which is reversible, and RCA territory, the inferior wall, which is reversible. So that's what we see. It's a medium-sized, moderate to severe stress-induced ischemia in the infralateral wall. And you have a fixed defect in the inferior wall. So angiographic diagnosis is a 2-vessel disease with a critical instant restenosis of the LCX occluded SVG to RCA. So things are not quite simple. Always as black and white, there are gray, and definitely the coronary anatomy is not equivalent to coronary physiology. So it's difficult to predict the variance in the coronary anatomy by physiology. Thank you.
Sir, your comments?
Yeah. Thank you. And it's a brief discussion. Only one question, and we will want of time. We will just basic question we will ask. Can you differentiate from the chronic hibernation from the stunning by our MPA method?
Chronic hibernation and stunning, I think you need to do a PET scan, sir, an FDG PET. And hibernating myocardium, they will take up glucose. Whereas in a myocardial perfusion scan, it will show severe ischemia. So severe ischemia can be only differentiated as viable if that myocardium is taking up glucose. Because generally the myocardium generally takes the free fatty acids. But in extreme circumstances, when it's occluded, it switches from the fatty acids to the glucose. So that would be the way to differentiate, I suppose, the hibernating from a stunned myocardium. Stunned myocardium generally will have almost normal myocardial uptake in a systemic beat, but the wall motion will be absolutely abnormal. You will say that that area doesn't move at all.
Okay. So we will move on that. Before that, there is a limitation in thing is if patient get collateralized or chronic hibernation. So we cannot localize which vessel is involved. So the only thing, the area where we wanted that one, it's a viable or non-viable only. If already collateralized vessel, we cannot predict which vessel is involved here. That is a issue. Okay, we will move on to the next session.
Dr. Vijayaragam? Okay. Okay, let me introduce the speaker. Yeah, Dr. Vijayaragam, please take over.
Yes. The next speaker is Dr. Mohan Roop Jayanti, Senior Consultant from AIG Hospital, Hyderabad. He is going to speak on non-ischemic cardiac disorders, exciting photons. Over to you, sir.
Good afternoon, everyone. I thank the organizers for giving me this opportunity. So today's topic is role of nuclear medicine in non-ischemic cardiac disorders. So basically cardiac disorders are divided into ischemic and non-ischemic causes. Coming to non-ischemic cardiac disorder, the most important one being the myocarditis or the inflammatory cardiomyopathy. So its causes can be divided into three categories, coming to which are infectious causes, immune mediated causes, and the toxic mediated causes. So the today's topic of discussion is the cardiac sarcoidosis, which falls under autoantigen immune mediated myocarditis or the inflammatory cardiomyopathy. Along with it, I'll be discussing about the various protocols which we follow in our institute based on the FDG PET-CT findings. So this table showing the various organs which are commonly involved in sarcoidosis. Coming to cardiac sarcoidosis, it is in around 5 to 10% of the patients. So it can lead to various adverse outcomes because of cardiac involvement, such as advanced heart blocks, arrhythmias, cardiomyopathies, or can even lead to sudden cardiac deaths. So we know that the sarcoidosis is a systemic granulomatous disease, and where the cardiac involvement is frequently underdiagnosed, the gold standard being the endomyocardial biopsy, which has very low diagnostic yield, and the other traditional diagnostic techniques such as ECG and echocardiography have poor sensitivity in diagnosing the cardiac sarcoidosis. And in some cases, sudden death may be the first sign. So the early diagnosis and therapy is very important, as this condition is a potentially preventable condition, and early therapy in these patients may improve the prognosis. Coming to gold standard for the diagnosis, which is endomyocardial biopsy, which faces multiple challenges such as high sampling error, it being an invasive technique, and where the single organ or the right ventricle is targeted, the quantification is not possible, and the response to treatment cannot be assessed, as doing repeated endomyocardial biopsies is risky for the patient. And as we know that the structural changes may lag functional changes, so the advanced cardiac imaging have the advantage of early diagnosis as compared to the gold standard endomyocardial biopsy. And as we know, in cardiac sarcoidosis, the involvement of myocardium is patchy, and it typically involves subepicardial or the mid wall, and sparing the subendocardial part, thereby reducing the sensitivity of blind myocardial biopsy. So in these cases, image guided procedures may help in increasing the sensitivity of endomyocardial biopsy, but further validation of these approaches is needed. In this image, we can see the common sites of myocardial involvement in cardiac sarcoidosis, the common being the interventricular septum and the free wall of the LV myocardium, followed by free wall of the RV myocardium and bilateral atria. Now let's start with a case. So we have a 47-year-old male patient with history of lymph node biopsy proven sarcoidosis. He presented with recurrent episodes of ventricular tachycardia and ejection fraction of 45%. So now the important question is whether this patient is having cardiac sarcoidosis. To say that, we need further information. So what does the recommendation say? The Heart Rhythm Society consensus recommendations for the diagnosis of cardiac sarcoidosis say that the histological diagnosis of non-caseating granulomas on endomyocardial biopsy, or the histological diagnosis of extracardiac biopsy along with one or more of the following features is required. Steroid or immunosuppressant response to cardiomyopathy, unexplained LVEF reduction, unexplained sustained ventricular tachycardia, heart blocks, or the presence of typical findings on PET, MRI, or on an gallium study. And the other causes for the cardiac manifestations are, of course, ruled out. So now, where does our patient falls? the recommendations suggested by Society of Nuclear Medicine and ASNEC recommendations say various clinical scenarios in which advanced cardiac imaging is useful in suspected or known cardiac sarcoidosis. Coming to the scenario of patients with histological evidence of extracardiac sarcoidosis with abnormal symptoms or abnormal findings, our patient falls under this scenario. There is lymph node biopsy proven sarcoidosis along with findings of sustained or non-sustained ventricular tachycardia. So our patient fits our patient is ideal candidate for advising advanced cardiac imaging. Even the same is suggested by the Heart Rhythm Society consensus recommendations on the role of FDG PET-CT in diagnosing cardiac sarcoidosis. It says that biopsy-proven extracardiac sarcoidosis along with symptoms or abnormal ECG, echocardiogram, or one or more of presence of one or more of these findings is indicated for advanced cardiac imaging. Now, the important question is out of cardiac MR and FDG PET-CT, which is preferred. So this is taken from EANM ASNEC guidelines, which says that patients with suspected cardiac sarcoidosis with extracardiac sarcoidosis and presence of symptoms or abnormal findings, cardiac MR is preferred over FDG PET-CT. We follow the same protocol in our institute. We do cardiac MR with gadolinium, and if it is absolutely normal, the patient is done for a clinical follow. And if the cardiac MR is abnormal, unavailable, or contraindicated, patient is advised for FDG PET-CT, of course, along with perfusion imaging. However, there are few scenarios where even if cardiac MR is normal, but presence of very high clinical suspicion suggests for advising FDG PET-CT. So the patients with FDG PET-CT and myocardial perfusion imaging, if the PET-CT findings are positive, these patients are advised for immunosuppressive therapy. And if there is no uptake on FDG and there is defect on perfusion imaging and there is late gadolinium enhancement, these patients are potential candidates for ICD implantation. So in our case, the patient is having
I didn't catch that. Could you try again?
The patient is underwent coronary angiogram, which showed absolutely normal coronaries, thereby ruling out the ischemic causes of patient symptoms. And he underwent cardiac MR, which showed no evidence of late gadolinium enhancement, normal left ventricular function, and the edema imaging showed no evidence of edema. So the question is whether this patient is having cardiac sarcoidosis. So the clinical team discussed with us, and in this patient, in view of presence of biopsy-proven extracardiac sarcoidosis and presence of VT, suggesting very high clinical suspicion for cardiac sarcoidosis, this patient is referred for FDG PET-CT. So this is the typical imaging protocol that we follow for FDG PET-CT in sarcoidosis. So it is a 2-day protocol where the day 1 is dietary preparation and day 2 is for the imaging. So our diet is a high fat, low carbohydrate diet along with prolonged fasting, which is overnight fasting, no less than 12 hours before the imaging. Now the emerging literature is saying that even prolonged dietary preparation for around 72 hours gives very good results and suppresses the physiological myocardial glucose utilization as compared to the routine 24-hour dietary protocol. So when the patient presents to our department on day 2, he will be undergoing perfusion imaging followed by FDG injection of around 5 to 10 millicurie, and after a waiting period of around 90 minutes, cardiac spot scan along with whole body images are acquired. So this is a table showing various methods to suppress glucose utilization of normal myocardium, such as prolonged fasting, high fat, low carbohydrate diet, or intravenous administration of unfractionated heparin. So the method which gives best results is combined method, where minimum of 2 of these methods are combined together and utilized for patient preparation. In our patient, patient has not underwent perfusion imaging, as coronary angiogram showed normal coronaries, thereby ruling out ischemic causes, and cardiac MR were absolutely normal, ruling out the presence of scar tissue. So the FDG PET-CT findings showed multifocal patchy FDG uptake along the basal interventricular septum and apical and infralateral wall of LV myocardium. Now, how confident are we that these findings are due to cardiac inflammation, and whether ICD is indicated in this patient or not? So coming to indications for ICD implantation, class 1, here the ICD implantation is recommended in patients with cardiac sarcoidosis and with one or more of the following findings of spontaneous sustained VT with episode of cardiac arrest and low ejection fraction of around less than or equal to 35%. Our patient falls under the class 2A, where ICD implantation can be useful in patients with CS and with one or more of the following findings. And here our patient is having this inducible sustained ventricular tachycardia. So he was advised for ICD implantation and underwent single chamber ICD implantation. Along with this, he received steroid therapy and immunosuppressive therapy for a duration of 3 months. The repeat PET scan was done at the end of 3 months, which showed no evidence of abnormal FDG uptake in the entire myocardium, so suggesting complete radiological resolution of disease. Even there is complete clinical resolution of disease as well. So this patient is on follow-up, and now he is completely arrhythmia free since the last 7 years, and his ejection fraction became normal, and it is in the normal level till now. And the electrophysiological study was negative for VT inducibility, and there is complete clinical response to advanced therapy. Coming to our institutional protocol for immunosuppressive therapy. So here the patients with diagnosed cardiac sarcoidosis and with PET positive findings and biopsy positive findings. So these patients received prednisolone as well as methotrexate. And the steroid is tapered and stopped over a period of 12 weeks, and repeat FDG PET-CT was done at the end of 3 to 6 months of therapy. And based on the PET-CT findings and the clinical response, the patients are divided into 3 categories. The patients with clinical response and no myocardial FDG uptake on the repeat PET scan. So these patients continued immunosuppressive therapy for 2 years, and the patients with equivocal clinical response and presence of residual FDG uptake. So these patients are advised for intensification of immunosuppressive therapy, and those patients with no clinical response and no myocardial FDG uptake at the end of study, they are advised for advanced treatment strategies. And how important is FDG PET-CT in assessing response to immunosuppression? So usually in our institute, response is assessed at the end of 3 to 6 months after starting immunosuppressive therapy. And there are various response criteria such as clinical response, echocardiographic response, and radiological response. So clinical response means that there is reduction in NIHA functional class, and there is freedom from ventricular arrhythmia, or there is no episode of heart failure hospitalization. Echocardiographic response is improvement in LVEF by more than 10% after the starting of immunosuppressive therapy as compared to the baseline study. So based on these response criteria and FDG PET-CT findings, patients are divided into complete responders, partial responders, and non-responders. Complete responders are those showing good CR, ER, and no residual FDG uptake. And partial responders are those patients with either echocardiographic response or the clinical response or presence of residual FDG uptake. And non-responders are the patients who have neither ER or CR. So this study is done in our institute by our colleagues in cardiology department under the guidance of Dr. Narasimhan sir. Here the patients with proven cardiac sarcoidosis are treated with standard immunosuppressive regimen, and repeat PET-CT was done at the end of 3 to 6 months after starting the treatment. And based on the PET-CT findings and other response criteria, so the results showed that complete response is seen in around 55% of the patient, and partial response is seen in around 21% of the patient, and non-responders are around 24%. So coming to the scenario of steroid-resistant cardiac sarcoidosis, so this is a very important condition because early recognition of this condition helps in improving the prognosis of the patient. So the reasons for steroid resistance can be due to differential concentration of steroids in the myocardium as compared to lymph node, and presence of lower inflammatory burden at the baseline or at the time of starting steroid therapy. So the first column are the baseline images, and the second column are the repeat PET images at the end of 3 months of therapy. So where we can see there is increased in LV myocardial uptake and differential reduced uptake in the paratracheal lymph nodes. So recognizing this condition at an early stage is important so that patients can be advised for alternative second line or third line immunosuppressive therapy or advanced therapy, and thereby preventing the development of myocardial fibrosis. So these patients with refractory cardiac sarcoidosis, based on the PET-CT findings, can be divided into two categories so that the treatment options are different based on the PET findings in these patients. So the patients who are non-responders and presence of residual myocardial uptake, which is suggesting that there is residual inflammatory activity. So these patients are advised for second or third line steroid sparing agents or the biological agents, and the refractory cardiac sarcoidosis patients or the non-responders with no myocardial uptake in the repeat PET-CT, suggesting the scar or the burnt out phase. So these patients are advised for left ventricular assist device or the heart transplantation. And the patients of cardiac sarcoidosis with VT. So in these patients, the type of therapy is dependent on the stage of disease. So to identify the stage of disease, again, PET-CT is very helpful. So based on the PET-CT and presence of VT, and the presence of VT. So these patients are again categorized into three categories. So those patients with positive PET findings and VT during the active inflammatory phase, these patients are controlled with ICDs, AADs such as lidocaine, beta blockers or amiodarone, and immunosuppression. And those patients with no FDG uptake and presence of VT, suggesting the VT during the scar phase. These patients are refractory to anti-arrhythmic drugs. So these patients can be suggested for radiofrequency ablation. And presence of VT during the reactivation of cardiac sarcoidosis based on recurrence of FDG uptake. So these patients are advised for intensified immunosuppression. So this is a study published by our colleague Dr. Muttaya under the guidance of Dr. Narasimhan sir, states that Pre-treatment myocardial FDG uptake predicts response to immunosuppression in patients with cardiac sarcoidosis, thereby stating the indirect findings of PET-CT usefulness in prognostication of response to therapy. So the basic result of this study is that the patients with lower baseline inflammatory burden who have low FDG uptake index in the baseline study were less likely to respond to immunosuppressive therapy as compared to patients with high uptake index in the baseline study. Coming to the conclusion, so basically PET-CT is helpful in diagnosis, which provides virtual histology of the entire LV myocardium as well as the entire image segment of the body. It helps in early diagnosis, and the biopsy can be guided with the help of FDG PET-CT, thereby increasing the sensitivity of the EMB. And whole body images can be helpful in identifying the presence of extracardiac disease. So it is useful in prognosticating patients with cardiac sarcoidosis. As I have already said, that patients with low inflammatory burden in the baseline study are less likely to respond to immunosuppressive therapy, and there is high risk of ventricular arrhythmias and deaths in patients with positive findings on PET. So it is helpful in therapeutic response monitoring, and particularly FDG PET quantification is vital to guide immunosuppressive therapy. Thank you.
Dr. Mohan Roop, it was an excellent presentation. I just have one question. Dr. Hari, can I continue?
Yes, please, please.
Yes. See, when we are talking about response assessment, why not make the evaluation comprehensive with myocardial perfusion imaging, particularly gated myocardial perfusion imaging? See, relying only on hotspot imaging, reduction of FDG, what if ejection fraction also falls along with FDG uptake? Does that mean improvement, or that it's a deteriorating case?
No, we can't say if EF is absolutely normal, or as you said, like there is reduction in uptake, but there is no fall in EF. So these patients can be non-responders as well. So we have to be cautious in following the.
Yes. Should we make it comprehensive with gated myocardial perfusion imaging plus FDG PET?
Yeah, most of the time we do that, yeah, as protocol. But sometimes, as in this case, I have said that the patient has already underwent angiogram and MR. So the consultants were like little bit of confident that everything is normal. Why to go ahead again with the perfusion rather than directly go for it?
No, I understood. The point is that we have the modality and we can make use of the resources.
Yeah, definitely.
Thank you.
Thank you.
With the permission of chair, I would like to ask one question. Mohan, thank you very much for participating with with all your difficulties with the virus and last moment notice. My question is very, very simple and very practical one. What do you do when the patient comes with hyperglycemia on the day of the scan?
With the hyperglycemia, sir?
Yeah. Because you can't give insulin. Insulin will stimulate myocardial uptake. So this is something that I have been facing in my practice. Patient comes for a cardiac sarcoidosis scan. We give all the preparation. The patient comes following all the preparation, but on the day of the scan, the blood sugar is 250. So what do we do?
Exactly what we facing. Last case, I sent to Hari, but patient on high fat diet from home, but patient is hyperglycemia. Then I asked him, and what is the role of gallium here?
So, I mean, how do you do, Mohan? Do you send the patient back, or you have not encountered this?
I have not encountered, but maybe I think we can use intravenous heparin spot. Maybe it might improve. And as the sir told, maybe we can even try for the gallium in such cases. Definitely.
Okay.
I have not encountered such case. Yes.
There is a problem for us, for you people not there. When we are patient asking to do that PET scan, need admission and doing high fat diet, those things and all. But patient not willing at this COVID era that we have a very difficult. Last patient, I told them to come with a high fat diet, but the patient on hyperglycemia. I just discussed with Hari. Then Hari did a kalium, I think.
Sir, in our cases also, like most of the times patient, once if he's a OP patient, we are a little bit of sure that patient might not have followed the diet properly. So in all those patients, we were giving intravenous heparin. So because of that, I think image quality is maintained. And those inpatients, so we are a little bit confident that patient has followed the diet. So in that cases, only fasting and dietary protocol was enough to take the patient. So
my observation was it is better to follow both high fat diet and also give intravenous heparin.
Okay. Yes.
Okay. So thank you, Mohan. I'd like to just steal 30 seconds of our time for the next quiz. So coming to the quiz question number 4. So for those who have joined now, you have the quiz link in the right lower corner of the conference portal. The answer will not be mentioned. Only the options are displayed in the quiz in the portal. So remember your options correctly when you answer. So coming to the history, this is a 45-year-old female, recent onset right breast lump, clinically node negative axilla. PET was done for metastatic workup. This is the FDG PET scan. You can see the fused PET CT, the CT images. I'm not describing the findings. This is the coronal images. What is the next logical course of management? Option A is lumpectomy. Option B is lumpectomy with axillary clearance. Option C is lumpectomy axillary dissection based on sentinel lymph node and gamma probing. Option D is neoadjuvant chemotherapy followed by lumpectomy. I'm showing you the images again. And you can have a look at the options again. Well, thank you.
Okay, actually, I want to discuss a lot in the topic because I also discussed. But okay, so one top time we'll do later and continue the next session.
So the next speaker is Dr. Jaykant, who is a consultant nuclear medicine physician at Apollo Proton Cancer Center, Chennai. He is going to speak on Ricky the infiltrators, cardiac amyloidosis imaging. Over to you, Dr. Jaykant.
Hi everyone, I'm Dr. Jaykant, consultant nuclear medicine, Apollo Proton Cancer Center, Chennai. Welcome to the talk on role of nuclear medicine in cardiac amyloidosis by technetium pyrophosphate scintigraphy. So there are many types of amyloidosis, but majority of the cardiac amyloidosis are either light chain amyloidosis or transthyretin related amyloidosis, which has very diverging etiology, treatment option, and prognosis. So to give a brief introduction about AL and ATTR amyloidosis, AL amyloidosis is a plasma cell dyscrasia. The source of amyloid is the bone marrow, which has very poor prognosis. Hence, it is considered a medical emergency. The patient has to be immediately treated with chemotherapy by a hematologist. Whereas ATTR amyloidosis, the source of abnormal protein is the liver, which forms the protein called transthyretin, which is a transport protein, carries retinol and thyroxine. These are tetramer proteins which undergo dissociation into monomers. These monomers, they misfold and form beta-pleated fibril proteins called amyloid fibrils. These are resistant to proteolysis and they get deposited in various organs, especially the myocardium, causing ATTR amyloidosis. So, of late, the newer drugs and late-phase clinical trials, especially with transthyretin silencers and stabilizers such as tafamidis, has led to significant improvement in the management and outcome of patients with cardiac ATTR amyloidosis. So it is very imperative for the treating physicians to categorize and accurately diagnose the type of amyloidosis. So you need a non-invasive, precise and early diagnosis of ATTR amyloidosis for the proper management. So coming to the diagnostic modalities available, Echo, which shows features such as LV hypertrophy, diastolic dysfunction. They are all non-specific and which can be seen in other forms of restrictive cardiomyopathies. Whereas MRI, the diffuse subendocardial, non-territorial, heterogeneous late gadolinium enhancement on keyword weighted images is considered a characteristic feature of amyloidosis. But the thing is, it cannot differentiate between ATTR and AL amyloidosis. So here comes the impact of bone scintigraphy with technetium pyrophosphate, which when AL amyloidosis is ruled out with the help of free light chain assay, gamma and kappa light chain assay, serum and urine immunofixation, then scintigraphy can accurately point out to the diagnosis of ATTR amyloidosis. So let's start with the process of technetium pyrophosphate scintigraphy. It's a very simple scan, no preparation is required. The patient walks in, gets injected with technetium pyrophosphate 15 to 20 millicurie, which is very easy to prepare. And then the patient undergoes a whole body sweep, planar image, chest static image, and SPECT CT images at 1 hour, and if required, a 3-hour image 3 hours delayed. So these are the examples of normal and abnormal technetium pyrophosphate scintigraphy. Here you can see a whole body planar image showing normal physiological distribution of tracer in the skeletal system, and apart from that, there is an abnormal tracer accumulation in the myocardium. This is a static image showing abnormal accumulation in the myocardium. That is, this is a normal negative whole body planar image showing normal physiological distribution in the skeletal system and no abnormal uptake in the region of myocardium. The same chest static view that clearly shows no significant uptake in the region of myocardium. Normally, you don't see uptake of pyrophosphate in the myocardium. So when you get an answer in the planar image, why do you need a SPECT CT image? What is the advantage of SPECT CT image? The main thing is to avoid overlap of the bone uptake, especially the sternum, to distinguish blood pool activity from myocardial activity. So these two are the main advantages of doing a SPECT CT. Also, you can assess the distribution of myocardium pyrophosphate uptake in various segments, whether it is LV, RV, or atrium, and it also helps in quantifying the degree of myocardial uptake by comparison to the rib uptake. So coming to patient selection, patients old more than 60 years with features of unexplained heart failure, those with suspected familial amyloidosis, those with the features of restrictive cardiomyopathy in echo, such as abnormal LV thickness and diastolic dysfunction, those with features of heart failure with preserved ejection fraction, those with unexplained atrial arrhythmias, are the patients who are ideal to undergo technetium pyrophosphate scintigraphy to rule out a cardiac amyloid. However, there are no contraindications to do pyrophosphate scintigraphy, unlike cardiac MR, where renal insufficiency or an intracardiac defibrillator is a contraindication to do cardiac MR. So coming to interpretation criteria, these are clearly established from the guidelines of American Society of Nuclear Cardiology. We do a visual and quantitative analysis. Visual analysis is by comparison with the adjacent rib uptake. So we have the 4 grades. Grade 0 is when we don't see any uptake in the myocardium with the normal bone uptake. As a grade 1, you see faint uptake in the myocardium, which is less than the adjacent rib uptake. Here you can see a faint uptake, but less than the adjacent rib uptake. In grade 2, you see significant uptake in the myocardium, which is equal to the adjacent rib uptake. And in grade 3, you have significant abnormally increased uptake in the myocardium, which is greater than the adjacent rib uptake. As you can clearly see here, which is greater than the rib uptake. Grades 2 and 3 are considered positive for ATTR amyloidosis. An important point to note here is that before you document ATTR amyloidosis in your report, AL amyloidosis has to be excluded by serum-free light chain assay and serum and urine immunofixation. And other advantage of whole body imaging is that you see uptake of pyrophosphate in the shoulder girdles and hip joints, which is considered a specific sign of systemic ATTR amyloidosis. So this also has to be reported in the final report. So coming to quantitative analysis, which is done by calculating the heart to contralateral lung ratio, you draw an ROI over the region of myocardium, and the same sized ROI is drawn on the contralateral lung, and you calculate the ratio. When the ratio is 1.5 and above, it is considered positive for ATTR amyloidosis. When it is less than 1, it is negative, and between 1 and 1.4 is considered equivocal. However, the size of the ROI and placement, the correct placement of the ROI is very vital to properly interpret the images. So here you see the ROI is placed over the myocardium here, and the ROI is placed on the contralateral side. But here you can see the ratio is 1.1, which is considered equivocal. But if you see carefully, you can see the ROI is placed wrongly overlapping the liver uptake. Actually, it has to be over the contralateral lung, excluding any bone or liver uptake. Not necessarily the ROI should be at the same level of the myocardium on the contralateral side. So when the same image is reprocessed, the size of the ROI over the heart is reduced, and the ROI placed correctly over the contralateral lung, avoiding the bone and the liver uptake, you see the ratio is coming to 1.5. Now the scan is considered positive for ATTR amyloidosis. So placing the proper processing with correct placement of the ROI is vital for the interpretation. So let me show you some examples, few cases. The first case is a 56-year-old lady with presenting with chest pain and ECG suggestive of atrial fibrillation, echo showing normal EF. She was suspected to have amyloidosis and sent for pyrophosphate scintigraphy. Here you can see a planar image showing abnormal pyrophosphate uptake in the region of myocardium. This is the 1 hour and 3 hour static image where you can clearly see abnormal uptake persisting in the region of myocardium. So grading, if you see, it is the uptake is equal to the adjacent rib uptake, hence it is grade 2, and heart to contralateral lung ratio was 1.5. So this is a classic case of cardiac ATTR amyloidosis diagnosed with confirmed pyrophosphate scintigraphy. So this is a SPECT image of the same patient. It shows abnormal tracer concentration in the walls of LV myocardium, where the septum and the infralateral wall is involved by the amyloidosis. So this is the advantage of SPECT, where you clearly localize the uptake in the myocardium and exclude a blood pool activity. The second case is a 65-year-old lady with features in echo suggestive of infiltrative cardiomyopathy with the right atrial involvement and diastolic dysfunction. So technician pyrophosphate scintigraphy in this patient revealed an abnormal pyrophosphate uptake on the right parasternal region, whereas the left parasternal region doesn't show any abnormal uptake. Here you can see the static views clearly showing abnormal uptake on the right parasternal region and not on the left parasternal region. The heart to contralateral lung ratio here was 1.5. So SPECT-CT in this case showed abnormal tracer concentration in right parasternal region corresponding to right atrial myocardium. Here you can see clearly the uptake localizing on the right atrial myocardium, which is enlarged, and the grading is more than the rib uptake, which is grade 3. So this is the case of classic isolated atrial amyloidosis diagnosed with pyrophosphate scintigraphy. So we retrospectively got the MR images of this patient done a few months, 4 to 5 months back, where it shows bilateral atrial enlargement and LV hypertrophy. And there's subtle thickening of the right atrial wall, which could be interpreted retrospectively. However, this was not reported in the MR that point of time. So we searched for some literature which also has published, there are papers available documenting isolated atrial amyloidosis involvement. So the next case is a 60-year-old gentleman with echo features of cardiomyopathy and preserved EF, presenting with palpitations and dyspnea. This is a whole body pyrophosphate scintigraphy where you couldn't make out any significant uptake in the myocardial region. However, the SPECT-CT picked up faint tracer concentration in the left parasternal region, in the region of basal septum, And the grading, when you compare the grading with the uptake, it is equal to the rib uptake since it is grade 1. However, the hard to contralateral lung ratio in this case was only 1.1. So in this case of this is an equivocal case where it can represent an early ATTR amyloidosis or an AL amyloidosis. And the last case is a 62-year-old gentleman with the palpitations, echo showing preserved EF and septal hypertrophy. He was referred for parafocal scintigraphy, which showed no abnormal uptake in the myocardium. You can see there is no abnormal uptake in the myocardium. The hard to contralateral lung ratio was also less than 1, hence it is negative for ATTR amyloidosis. So when you search the literature, there are papers which clearly show the superior sensitivity and specificity of scintigraphy for diagnosing ATTR from AL, differentiating ATTR from AL amyloidosis. The sensitivity and specificity are very high, as you can see, 90 and 88%. Whereas cardiac MR was unable to reliably differentiate ATTR from AL amyloidosis with much less sensitivity and specificity. So coming to the PET traces, of late traces such as F18 fluor beta band and F18 fluor beta pred have been successfully tested for diagnosing cardiac amyloidosis in pilot studies, and which are very promising with high sensitivity and specificity. And surprisingly, these traces show high uptake for AL amyloidosis than ATTR amyloidosis. So possibly we might have such PET traces with high sensitivity very soon in our clinical practice to diagnose AL amyloidosis too. So the take-home points are technetium ferrophosphate scintigraphy is very easy to perform with high sensitivity and specificity for cardiac ATTR amyloidosis once you rule out an AL amyloid. And it's a reliable imaging modality. It can alleviate the need for invasive endomyocardial biopsy, which has its own complications, benefits the clinician by steering the management properly, correctly towards ATTR amyloidosis. However, equivocal cases can represent early ATTR or AL amyloidosis. And as I already explained, exclusion of AL amyloidosis is a must for correctly diagnosing ATTR amyloidosis. So technetium ferrophosphate scintigraphy is a very age-old test which has emerged with a new purpose because of the newer treatment options for ATTR amyloidosis, and it has its own impact in the cardiology space. So thank you.
Thank you, Dr. Jaykant. It was an excellent presentation. Just a small question.
Yes.
Do you think sodium fluoride would help? And the next one is, we don't have the tracer, but any role of MIBG 523? Would it make it more comprehensive?
Yeah, first of all, sodium, when we have a cheaper option and more commonly available gamma camera, no one would go for an costly and PET tracer. And personally, I don't have an experience with F18, so I don't think literature also has shown any evidence for amyloid imaging with F18. But based on the pathophysiology and tracer uptake mechanism, hopefully it should also show uptake. So that is with F18 and MABG. I don't think, to my knowledge, there is no role for MABG in cardiac amyloidosis imaging.
The reason is that once amyloid starts depositing, it's an infiltrative disorder, it starts affecting the neuronal integrity, and there are a few papers on that. Maybe we can discuss some of that.
But again, the feasibility and the
yes, it's not available. Yeah. Yes, true. Yes.
Jaykant, I have one question. Yeah. I might look like I am totally ignorant. I mean, I understand that amyloidosis, they will have something like a very poor LV function.
Yeah.
So how do you differentiate blood pool activity from the myocardial activity, if not for SPECT?
If not for SPECT, yeah, it is very difficult. That's why that's when the 3-hour images come into play. You actually 3-hour images are not required if you are very confident with 1-hour image and the SPECT CT rules out a blood pool image. 3 hours is not mandatory. But if you don't have a SPECT CT, then you need to take a 3 hours image and see what difference it makes with the 1 hour image and confirm that. Otherwise, the blood pool is a very common cause of false positive interpretation of amyloid.
Yeah,
At least a plain check, if not a CT, is definitely it's to be done.
I think not all patients with cardiac amyloidosis will have very poor unless they are later stages. I think it is preserved ejection fraction with LV
Yeah, heart failure with preserved ejection fraction
is a common one. That's where we need to pick it.
Yes.
Yes, and the next speaker is Dr. Santosh Sampath, who is the clinical lead in the Department of Nuclear Medicine, Dr. Rela Institute and Medical Center. He is going to speak on nuclear imaging in cardiac viability evaluation. Over to Dr. Santosh.
Hi, good afternoon, everyone. I thank the organizers for giving me this opportunity to speak on cardiac applications in nuclear medicine. So my topic is cardiac viability, nuclear perfusion imaging-based decision making for revascularization. Instead of going to the concepts, I want to just straightly start with the cases. And in parallel, I request the students to interpret on their own the images which I show. So coming to the first case, this is a 44 years old male who was recently diagnosed with myocardial infarction, and the angiogram showed 100% stenosis in LAD, 90% stenosis in RCA, and 50% stenosis in LCX. So basically, two vessels are involved. Corresponding to it, we can see that the LAD has a scarred myocardium, whereas LCX has a normal myocardium. The RCA shows somewhat reduced perfusion, whereas with attenuation correction, it's improving. So there is attenuation corrected images. Still, we can see that large area of distal LAD territory is scarred. So the final interpretation will be almost 40% of the LAD territory is infarcted, whereas the rest of the territories were having viable myocardium with resting ischemia in RCA and normal viable myocardium in LCX. Second case is another elderly male with a history of myocardial infarction in the inferior wall 2 years back. And correspondingly, the RCA had 80% stenosis, whereas the LAD and LCX were normal. So this is the images occurred 1 hour after injecting SNMI. You can see that there is some difficulty interpreting the inferior wall because of some probable activity from the liver, whereas the anterior wall, lateral wall are perfectly fine. So after the 10 minutes of delayed time, another image was occurred, which shows a clear perfusion in the inferior wall. However, it is reduced compared to the rest of the myocardium. So here we can conclude that the LAD and LCX territories are normal, whereas the RCA territory has viable myocardium as well as viable myocardium with resting ischemia. How we can make the difference? So you can see that the inferior septum is appearing perfectly normal with preserved thickness corresponding to adjacent walls, whereas the inferior wall has reduced thickness. So the inferior wall is definitely having some resting ischemia, whereas the inferior septum is relatively preserved. And the EF is 52% in this patient with some contractile dysfunction in the inferior wall. The other case, this is another patient, male patient with a recent myocardial infarction with angiographically significant stenosis in all the vessels. More of them, RCA was involved the most. As you can see here, the RCA is showing significantly reduced perfusion, almost infarct. The LCX shows a moderate grade of reduced perfusion. The LAD is almost fine. So this is a final image. Here also you can see that there is, even after delayed image, the inferior wall still has some kind of suspicious interpretation. And hence, to clarify this, we can see the gated images to see if there is any systolic thickening in the inferior wall. The septum, lateral wall, they show adequate systolic thickening, whereas the inferior wall doesn't. So this means that the inferior wall definitely has an infarction. So obviously in this case, almost 40% of the RCA territory is infarcted, whereas the LAD and LCX territories have viable myocardium. And ultimately, this patient has a ejection fraction of 32%. So how we do simple approaches to improve the interpretation of this resting viability-based evaluation. In the first instance, we took the help of attenuation correction to see the anterior anteroseptal segments.
In the second case, we just did a delayed imaging to clear the liver activity, and we are very comfortable reporting the RCA territory. Whereas in the last case, even after doing a delayed scan, still we had some doubt, and systolic thickening of the absent systolic thickening in the inferior wall was useful in evaluating infarction in these territories. Now coming to what is the basic concept of nuclear viability and how that is different from other imaging-based evaluation. The only factor which differentiates nuclear viability from other factors is the intracellular perfusion of the agent and the mitochondrial integrity. So without mitochondrial integrity, you will have a scarred myocardium in this imaging, whereas there is a CT, echo, or MRI-based assessment, they take advantage of the scarred myocardium interpretation only, where there is delayed enhancement of the contrast in the extracellular matrix. They don't see the intracellular substance. So this is one example of how MRI, this is an image known to many people. Here there is a transmural lead gadolinium enhancement, whereas this is subendocardial. So how we interpret this nuclear perfusion based on the intensity of the reduction in tracer compared to the normal myocardium. It could be mild reduction, moderate reduction, or it could be very severe and negligible. So when mild moderate reduction is there, we can call that as having a viable myocardium. It is almost 50% of the normal cutoff. Whereas the other two are interpreted as infarctor myocardium. And we use a 17 segmented model, and each segment, like apical anterior, each contributes 6% of the total mass, so corresponding to 100% of the total LV mass. And how these 17 segments contribute proportionately to the total LV myocardium by means of coronary vasculature. So LAD supplies almost 7 segments, so it contributes 40% of the myocardium. RCA and LCX each contribute 5 segments. So this is the basic way how we interpret, which is a reiteration of the previous slide. Homogeneous perfusion, preserved thickening, it's viable, and there's a full chance of recovery in a dysfunctional myocardium. That means whichever areas of myocardium which don't show any adequate contraction, echocardiogram, only we have to evaluate those areas. The myocardium which is having a normal angiographic coronary anatomy and normal contraction need not be evaluated with any other viability estimation. So there's a perfusion in myocardial imaging with perfusion, nuclear tracers could be normal. That could be mild reduction in tracer intensity, or that could be moderate reduction in tracer intensity. All these will be taken as signs of viable myocardium. This is equivalent to the MRI estimation of less than 25% transmural lead gadolinium enhancement. The other next way of evaluation is thickening. So if there is a 50% reduction in thickening, still it could contribute as moderately or moderate defect, and still this would give a probable chance of recovery. You should see the difference. There is high chance of recovery in this group of patients, whereas this probable recovery in this group of patients, and this contributes 25 to 75% of a scarred myocardium in MRI evaluation. The third is severe defect, whereas no resting perfusion. This is non-viable, and this is equivalent to more than 75% defect in MRI. So here in nuclear imaging, we see the myocardium improper, which takes a tracer we inject. Whereas in MRI, we don't see the myocardium improper. We see the scarred myocardium where there is a delayed enhancement of the injected contrast, that too in the extracellular matrix. So most of the studies say that there should be at least 25% viable myocardium in the dysfunctional segment to expect some improvement in LVF, which is the actual target which we want to achieve. To achieve this, in another way, we can say that 4 dysfunctional myocardial segments should have preserved viability. And it's not the simply 4 segments, and they should be located consecutively. And they can be taken as consecutive in adjacent territories, like if there is a LCX territory or RCA territory combination, the infralateral inferior segments should be having a viable myocardium, which had been dysfunctional. Similarly, it can be a LAD or RCA territory continuity, or LAD or LCX territory continuity. We can say consider a situation where there are 2 viable segments in say anteroseptum and 2 viable segments in infralateral segments. They cannot contribute to a significant improvement in EF because they may not contribute to a unified synchronous contraction after revascularization. So this is the basic concept we see, that whenever there is severely reduced perfusion, not in cases of mild or moderate reduced perfusion, only in case of severely reduced perfusion, we take the use of FDG PET. And by seeing the preserved metabolism in those areas, we call them as mismatch. What are the perfusion traces? Ammonia, rubidium, and PET, SNMI, thallium, and gamma camera. All these four traces, they require mitochondrial integrity to be shown adequately in perfusion-based imaging. Whereas in FDG, there is no requirement of any significant mitochondrial integrity in the myocardial segments which have experienced some ischemia or transmural or non-transmural infarction. FDG metabolism, which takes place in the cytoplasm, is called as anaerobic respiration, which we know, and this generates roughly 2 molecules of ATP, and this could satisfy the needs of the hibernating myocardium. Whereas why it happens in this situation is the mitochondria is disturbed a lot, and this is shown in a lot of studies. There are a lot of changes which happens in the mitochondria, which leads to very improper production of ATP, and that is the reason why the ischemic myocardium doesn't make use of fatty acid-based metabolism. So this is a slide which depicts the same. In glycolysis, anaerobic glycolysis, ATP is generated within the cytoplasm. There is no need of mitochondrial support to generate ATP. Whereas in fatty acid metabolism, without mitochondrial support, ATP cannot be produced. So why I again tell that mitochondria is essential for the perfusion tracers interrupment. We know that both the perfusion tracer and the metabolism tracer, both are supplied by the blood vessel and reaches the myocardium. But why FDG is taken up and why these perfusion tracers are not taken up? If you consider both rubidium and potassium, both of them require an active ATP pump, and it requires a continuous supply of ATP, which is very much disturbed or impaired in the ischemic myocardium. The same way, SNMI as well as ammonia require a good functioning mitochondria. We know that SNMI is the cationic tracer, and it binds to the negative resting membrane potential, and again mitochondrial support is required for it to be trapped, whereas ammonia can be trapped within the myocardium by 2 ways, like getting converted to glutamate or getting converted to glutamine. Both these processes require supply of ATP in 2 sequential time points. That means here 2 times ATP is required, and here again 2 proton molecules are required. So that means there is higher requirement of ATP or proton molecules for ammonium to get trapped. Whereas in case of FDG, only 1 molecule of ATP is more than sufficient, and other reasons like upregulation of glucose receptors, which promotes more uptake of glucose, other reasons. But this is the most important reason, that is the integrity of mitochondria. And we know that water is a freely diffusible tracer, and hence the typical cross-sectional images will not be available with water, whereas ammonia and rubidium can give cross-sectional images. So with with the water-based imaging, O15 water-based imaging, we can have only this kind of images where the software will just show that there is some uptake or not, but we cannot have a cross-sectional imaging like short axis, long axis images. So coming to interpretation proper. So consider this example where they have showed mismatch between the perfusion and FDG. So obviously this is a very captivating image, and we can say that this will very much improve. But you should accept the fact that this is correspond to a category of moderately reduced perfusion, and still this itself is more than enough to call that there is a probable chance of recovery after revasculation. Coming to other example. So here there is completely absent uptake of perfusion tracer in the inferior wall as well as the septum. That means this region of myocardium has lost its mitochondrial integrity, whereas FDG is being taken up by the myocardium. The question is how far these kind of myocardium fare after revasculation. That is the question. So just coming to a graphical representation and explaining what we have discussed till now. So here this graph shows that, or this bar diagram shows that in MRI, if there is less than 50% of scar, there is a probably progressively increasing chance of improvement after revasculation. If there is more than 50% scar, then there is very less chance of improvement after revasculation. As you can see here, even 52 or 55% of scar, that means almost 50% of myocardial scar, there is no significant improvement. Coming to rest-free distribution, simply thallium-based imaging or simple perfusion-based imaging. So you can see here that the 50% cutoff, that is still moderate category of reduction, there is a progressive chance of improvement after revascularization, whereas less than 50% is very less likely. Coming to the another form of example here, they use ischemia-based assessment. That is, they do stress as well as rest. If you see here, if there is adequate reversible ischemia, then there is a very good chance of improvement. This we know. In normal myocardium, this will completely improve. Even in partial viable myocardium, there will be some improvement. Whereas irreversible changes, that is fixed defects, mild to moderate form of fixed defect, still there is 30% chance of improvement. Where there is a severe defect, that means a fixed perfusion defect, there is no significant improvement after revascularization. But with mismatch evaluation, we are actually targeting this kind of population where this graph shows that in those kind of people, the chance of improvement is very, very meager. Why this happens? There are 4 different stages before which the myocardium goes to scar. First is the repeatedly stunned myocardium, where the perfusion will be still maintained. Here, perfusion-based imaging is more than sufficient to call improvement of revascularization. The other is hibernating myocardium by means of function, where the perfusion is decreased. This will correspond to mild or moderate grade reduction perfusion. And again, this will have an early recovery after revascularization. Coming to structural hibernation, this is a region where the myocardium goes into severe form of perfusion defect, where we see that the FDG is showing some mismatch. In these cases, you can see that there is very partial or even delayed form of recovery, and it is mostly partial, which may not be very beneficial to the patient. In infarction, obviously, we understand that there is no doubt. So when there is a severe form of perfusion reduction, the expected benefit is very, very less compared to the morbid procedure, which is in the revascularization, mostly in the form of CABG, is still doubtful. There is a lot of structural changes which happens in this kind of myocardium, and which is still under research, and there are multiple factors like mitochondrial transferrin pores, many other things which are being explored, and they don't reverse significantly after revascularization. So to demonstrate this, we did as analysis in a group of 45 patients, and what we found out, and this is the same concept which I just explained, that giving an example like this, a patient having a triple vessel disease, this is the polar part of patient. You can see that LAD is relatively better perfused. The RCA as having a severe defect, whereas the LCX is having a very significantly reduced perfusion or negligible defect or negligible perfusion. The FDG shows a significant mismatch, and this, based on this, conventional interpretation would say that there's a high chance of improvement after revascularization. But what we observed is after following this patient for 6 months, we did the perfusion study again to see how perfusion has increased in these areas. This is a baseline scan similar to this. This is a scan done 6 months after revascularization in the form of CABG. In this patient, revascularization was done for the LAD, obtuse marginal as well as RCA territory. We don't see any significant improvement in perfusion, and actually what happened was the EF dropped from 32% pre-revascularization to 30% post-revascularization. That means there was no significant improvement in benefit in this patient. So based on this evidence, we can say that intracellular myocardial perfusion-based evaluation has a very high sensitivity to detect the myocardium that will show improvement after revascularization, which is the definition of viability or somewhere hibernation. And there is no significant necessity to do FDG in most of the cases. Why I insist this point is there may not be many centers who have PET scans. They'll be having simple gamma scans, and it is even time consuming to do a FDG PET scan. So in centers where FDG is not available, or even in centers where FDG is available, a simple viability-based, perfusion-based viability assessment is more than sufficient to call viable myocardium, and this targets the actual myocardium which is going to improve, and we are not targeting the extracellular matrix which is actually done in the MRI. So this is a short form of, or simpler form of evaluating myocardial viability with perfusion, and I thank you for your patient listening. Thank you.
Vijay, your comments?
Thank you, Dr. Santosh. It was an excellent presentation. You have described in detail about hibernation, ischemic evaluation as well, and the role of simple systemic imaging and no need for inappropriate FTG. That's excellent. Thank you very much. And it was a highly educational.
Thank you. Santosh, I have no words to express how excited I am to listen to your lecture. It is like going back some 12 years and sitting in our lecture hall listening to cardiac viability lecture. Students who have listened to your lecture, if they have followed all your slides, they would realize like how much information you have packed into each of the slides. They're all very relevant in day-to-day practice. You have done an exceptional job, Santosh.
Thanks for the compliment, Dr. Hari.
Okay, we'll close this session. And before we move on to the next session, which is musculoskeletal, I'd like to thank Dr. Vijay Raghavan, who is an enthusiastic nuclear cardiologist himself, and Dr. Jayapandian sir for chairing the session. I'd like to thank all the speakers for doing an exceptional job. Before we go to the next session, let's have one more quiz. So this is question number 5. So for those of you who are joining new, you will have the link to answer the question in the right lower corner of the conference portal page. The exact answer will not be displayed. You'll just need to select the correct option. So this might be slightly tricky. I'm not giving you any hints, but I am requesting you to go through this image very carefully, right from the top to the bottom. You obviously know what scan this is. So identify the findings. Option A, remnant cervical node and skull mets. Option B, remnant cervical node, skull and sacral mets. Option C, remnant cervical node, brain mets. Option D, remnant cervical node and brain and sacral mets. I'm showing you the images again. And you have the options again. Okay. Let's move on to the next session, which is the musculoskeletal session. For chairing this session, I'd like to invite Dr. Karthikeyan, who is a consultant rheumatologist of Meenakshi Mission Hospital, Madurai. He will be joined by Dr. Zakir Ali sir, who is from Hyderabad, who is a senior nuclear medicine physician. Now I hand over the session to the chairpersons.
Hello. Hello, Dr. Harish. Am I audible?
Yes, sir. You are audible.
Yeah.
You are clear.
Okay. Thank you. So at the outset, I would like to thank Dr. Harish and his team and the organizing people of this conference for inviting me to chair this session. It's a very important session and a very common session about bone scans. I think almost 70-80% of the work done in nuclear medicine is related to bone scan. And our speakers are none other than Dr. Kavita Reddy, Dr. Anuj Jain, and Dr. Shelvind, and Dr. Sibu. And I think Dr. Kavita Reddy doesn't need any introduction. I think she's very popular consultant among all of us. And she's also popular among the students because she's a DNB examiner as well. And personally, also, she's very close to me, like my elder sister. So as far as musculoskeletal imaging comes, I think it is one of the most favorite topics for Dr. Kavita Reddy, what I know of. So I request Dr. Kavita to go ahead with the talk.
Greetings from Hyderabad. I thank the organizers for giving me this opportunity to talk about our experience in rheumatology. More than 2 decades with bone scan, we offered rheumatologists the telltale images where the diagnosis used to be very evident with the images, especially in spondyloarthropathies and then early rheumatoid arthritis before the conventional imaging would pick up. But we are missing these indications of late in our departments because of the expertise in high resolution ultrasound in musculoskeletal imaging and also evolving role of MR sequences in MSK imaging. But still, we still stand there to offer our expertise in these conditions, and we are unmatched in providing these images on bone scan, especially for metabolic bone diseases. Again, we are there with our three-phase bone scan, especially in localizing radiologically occult lesions. This is a case of 25-year-old female, pain in the right hip, mid-thigh, and the low back ache. MRI pelvis showed edema in right intertrochanteric region, not very conclusive of anything. So they came for the bone scan, three-phase bone scan. Of course, the first two phases didn't offer much, whereas the delayed image, you can see the asymmetrically increased uptake in the greater trochanter right side and the mid femur, a focal uptake with a focal hotspot in dorsal vertebra. What else? We need something else. So what is it? So this is precision scintigraphic imaging, an important tool which we have. Just for your information, which I gathered from Google. You all know precision, that is precise, means very exact or very clear. And what does precision imaging means? It's an approach which is descriptive, predictive, and integrative, especially integrative. I found the perfect match is PET-CT. So here is the case. You'll be surprised to see these images of PET-CT of the previous bone scan. See that so many hotspots, so many areas of intense FDG uptake, and this you D9, you have a lytic area and then uptake there. And so with the lesions in lung, we gave she's a 25-year-old female, so we gave a diagnosis of tuberculosis. So this is how the precision imaging helps us in directing the clinicians. And well, when do rheumatologists send their patients for PET-CT? Yes, both in their known cases of many rheumatological disorders and even new cases, they do need PET-CT help, especially in these clinical scenarios like pyrexia of unknown origin, when there are known cases presenting with this pyrexia of unknown origin. And this is another entity, inflammation of unknown origin, which rheumatologists frequently encounter, where there will be poor response to the treatment, there will be unexplained raised markers, or patient may be presenting with loss of weight, unexplained loss of weight. And literature says almost more than 50% of these cases land up with large vessel vasculitis, followed by polymyalgia rheumatica, though we don't see it so often, but literature says it's almost 13 to 15%, and followed by IgG-RD and relapsing polychondritis. Sarcoidosis, of course, tuberculosis and sarcoidosis, we see them quite often. Sarcoidosis, especially cardiac sarcoid and inflammatory myocarditis, is our strength nowadays. And malignancy is down in the list, not rare, 2 to 3%. So when do they send these patients? When they have inconclusive presentation, when the serology is not very conclusive, and clinical patterns. One important thing in rheumatology, you all know, is they have a lot of overlaps. So PET-CT helps a lot in delineating some overlap syndromes and helping them the treatment options. Large vessel vasculitis, yes, genital arteritis and Takayasu's arteritis. PET-CT is sensitive in more than 90% and more than 80% respectively for the diagnosis, for assessing disease activity, and for assessing treatment response. Well, in small vessel diseases like temporal arteritis and all, we are helpless. You all know about that. And when the patient's on steroids, which happens with these vasculitis patients, the response assessment becomes very difficult, especially when you are giving a negative report. There is a lot of, it's questionable because steroids can mask it. And nothing new about the diagnosis of vasculitis. You all must be experts by this time working on PET-CT. And also the treatment response. This is a responder. But what's exciting here is this is a man with a known case of large vessel vasculitis, come in remission, comes back with pain, abdomen, fever. So a PET-CT showed aneurysmal dilatation of abdominal aorta with the uptake in the walls. So vasculitis again in action. Apart from that, he has a focal increase uptake in the kidney. Then the whole body reveals something else, intense uptake in the salivary glands. So we gave a diagnosis of IGRD with active vasculitis. So the IGRD and vasculitis, it's a new overlap syndrome. So this is found to be interstitial nephritis in this case. So like this, many of vasculitis are associated with some other important inflammations, like one is IgG4-RD, even PMR, even rheumatoid arthritis. There are many diseases which are enumerated with vasculitis to be overlapped. Coming to IgG4-RD, so you all know about this condition. PET-CT is very sensitive for detection of subclinical disease and demonstrate the sites, so which helps them to go ahead with biopsy. And also it's helpful in monitoring treatment response. This forms an important chunk in inflammation of unknown origin. So this is a case, a young female, unmarried female, post-COVID 4 months, markers are still high. You can see intense uptake in the salivary glands, in both the breasts, and also the alobular pancreas. So we suggested diagnosis of IgG-RD and had IgG4 levels recorded to be very high. This is another condition of inflammation of unknown origin, polymyalgia rheumatica, who present with pain, stiffness in shoulders, neck, pelvis. Characteristically, of course, they come with generalized pain also, elevated markers, and this is diagnosis by exclusion. PET-CT, very important in giving them the diagnosis and also in helps in treatment monitoring. Characteristic appearances, increase uptake around the shoulder joint and in the pelvis. Shoulder joint, you can see the uptake not as a round, it's only along the glenohumeral joint, and then ischial tuberosity. This is due to bursitis and bursitis around. Majority, all these things are due to bursitis around the major joints. You hardly see, I mean, if you see the small joint involvement in such a case, then it goes more in favor of rheumatoid arthritis rather than polymyalgia rheumatica. PET-CT plays an important role here. You see here, you see this, the involvement of shoulder joint as all around, and then you see the small joint involvement. This is elderly onset rheumatoid arthritis. Yet another condition of undiagnosed fever, you see increased uptake along the nasal cartilage, ear lobules, cutaneous nodules, subcutaneous nodules, and uptake in the bone marrow. This is relapsing polychondritis. Another rheumatological disorder, repeated episodes of inflammation involving various cartilages, more importantly, tracheobronchial tree. Patient come to the emergency room and you may have to accommodate that patient for PET-CT for the diagnosis if the clinician is strongly suspecting. And then this is a textbook picture of involvement of the tracheobronchial tree with inflammation. This is a life-threatening condition, but they respond very well to the treatment. Yet another case. This case is a young female coming with undiagnosed fever again, and whole body PET-CT. We see a lot of lytic lesions in the vertebrae, sternum, myelium, all picking up FDG and lung lesions. So first we thought it could be tuberculosis, but again some gut feeling because there is increased uptake. This is 27 years old female, uptake along the growth plates. And then you see the lucencies, metaphyseal lucencies. These are characteristic of leukemia or neuroblastoma metastasis or leukemic deposits. But her blood workup is absolutely normal except for elevated ESR. You don't see any, nothing is being seen even in peripheral smear to suggest leukemia. But that, to our surprise, biopsy came as acute ALL. And such surprises are not very rare in our practice when we are catering to the needs of rheumatologists. This is another case which I have discussed. The first case after bone scan, we did PET CT. Let's see what surprise in this. So looking at the pulmonary lesions, we gave a diagnosis of tuberculosis, but the biopsy showed it to be epithelioid angiosarcoma. So ladies and gentlemen, the precision scintigraphy in rheumatology, we have a definite role in detecting the abnormality precisely and giving solutions to the problems, and especially in overlap syndromes, and guide them in treatment response. Thank you very much.
Bashir, can you allow videos to be switched on?
Yes, we can do that, sir.
But I'm getting a message saying unable to start video. Okay.
Thank you, ma'am. Actually, a very nice talk. So, am I audible?
Yes, please go ahead.
Yeah. So, actually, ma'am, I have one doubt. Actually, what is the role of scintigraphy in CRMO, chronic recurrent multifocal osteomyelitis? We say it's a non-sterile osteomyelitis. Is yeah, of course, can be seen from pediatric age to even middle age group. Is there any role for a scintigraphy in a CRMO?
Yes, definitely, because most common this CRMO are multifocal lesions, right? And then all these scintigraphic procedures like bone scan or PET CT, you get a whole body survey, and then all the lesions would be definitely picked up. And how does it differ from multifocal osteomyelitis? It's just by the location. More of these lesions are diaphyseal, and then you see a lot of sclerosis on either CT or on radiographs. So correlating both the findings, I think you'll get pretty specific diagnosis of CRO, either with bone scan or on PET CT. PET CT, I don't think PET CT is required in these cases. Bone scan, three-phase bone scan should do.
Okay, no, actually, we do cases engage, especially they come with multiple side pain. When you do ESR, CRP or any inflammatory markers, it will be quite normal. It will be surprising for a girl or a boy to say by having a severe pain. And even, of course, they will respond very well to NSAID or sometimes even to steroids. But when we look at a diagnosis, we'll be having a doubt. Inflammatory markers are negative, and the child is keep on having a pain, and they're having good response to NSAID. Then we do a MRI. There will be a bone marrow edema. Or then after that, we have a doubt on looking at the different site, and especially looking at the diaphyseal site, and even involvement of SI joint over the sacral part of the bone, not over the joint. So we tend to pick up cases. So just that idea, like what is there in with the scintigraphy. Thank you.
Yes, definitely. This almost these scintigraphic imaging serves as one stop because we offer the whole body imaging, and then we have now combination like hybrid systems with CT and then functional images. So I think we can be more precise than any other conventional imaging modalities.
Thank you, ma'am. Yes,
ma'am, any new traces are there we are using besides FDG for in rheumatology? You feel besides FDG, because I don't think how good is FDG.
Yeah, there's one more indication like tumor-induced osteomalacia. There we can use gallium tracers. Literature says gallium-68 scores over FDG PET CT in localizing the tumors which induce osteomalacia, both mesenchymal and osteogenic tumors.
We are having a short presentation on that indication very shortly. Thank you, ma'am.
Thank you, ma'am.
Thank you.
So,
shall we move on to the next session, sir?
Yeah, I think now we'll move on to the next speaker. This is also very interesting because he's Dr. Anuj Jain. He's going to talk on very interesting cases in musculoskeletal imaging. He's from the Vijay Diagnostic Center from my city, from Hyderabad. He is a DRM and a FRCR. So over to you, Dr. Anuj.
Good afternoon, everyone. At the outset, I would like to thank Dr. Harishankar and other organizers for giving me the opportunity to talk here. So I will be sharing with you 5 interesting musculoskeletal cases. The case 1 is a young female, 28-year-old, presented with pain in the right leg. A bone scan was performed. It showed increased blood pooling in the distal right leg, as well as delayed uptake involving distal third of the tibia. She also had some X-ray and MRIs done. So X-ray, which was done recently, showed some patchy sclerosis in the medullary patchy sclerosis in the involving distal third of the tibia, with no obvious any cortical break or soft tissue or collection kind of appearance. Or MRI T1 sagittal showed the patchy T1 hypointense signals involving the distal diaphyseal region. In the axials also, you can see the same thing, and it looks more like cortical thickening with the narrowing of the medullary cavity. STIR images show some associated hyperintense signals suggestive of edema, associated edema. Forgot to mention that her blood profile was normal, especially for the inflammatory markers. They were not elevated. Since she had a pain since almost 1 year, I asked for any previous X-rays, which she had, which also showed almost similar finding, which was present in the recent X-ray. Some medullary sclerosis along the endosteal surface. No obvious periosteal reaction then also, and now as well. So the first differential which came to mind is chronic osteomyelitis, but since the blood profile was negative for inflammatory markers and there is no change over a period of 1 year, as well as no periosteal reaction, and MRI didn't show any collections and all. So I'll have to say alternate differential, which is ribbing disease, also called as hereditary multiple diaphyseal sclerosis. Relatively a rare disorder, but normally it presents in middle-aged females. It can be painful or asymptomatic. Predominantly involves diaphyseal region of the long tubular bones, commonly the tibia or sometimes femur. It can be unilateral or bilateral, and when bilateral, it can be asynchronous. It's one present at a time, and after due course of time, the other bone can get involved. Radiographs, as we saw in this case, shows intramedullary sclerosis with cortical thickening, predominantly along the endosteal surface. This is another related disease is called Camurati-Angelman disease, also called progressive diaphyseal dysplasia. This is some author considers the same spectrum of disorder, but the differences from the ribbing disease are it presents early in the life, like presents in childhood, and it involves multiple long bones here. As you can see, it involving the bones of the upper limbs as well as lower limbs, and in synchronous manner. Okay, this scan is not mine. I have taken it from IJNM, and it was published there by Dr. Harishankar et al. My second case is again a young female. She presents with the swelling of the whole of the left limb with some stiffness of elbow as well as wrist joints. These are the clinical pictures. You can see the whole left upper limb is swollen and some tense skin, and looks like inflamed the whole left upper limb. A bone scan was performed. It showed intensely increased uptake in almost whole of the left upper limb, involving from the lateral border of the scapula, then whole of the humerus, and forearm bones, as well as carpal, metacarpal, and phalanges. There was no increased blood pooling. Okay, we performed some X-ray and we saw this diffuse sclerosis involving cortex as well as medulla, involving almost involving phalanges, some metacarpals, carpals, then forearm bones as well as humerus, and also lateral aspect of the scapula. So this kind of sclerosis is called dripping candle wax pattern. It is suggestive of myelorhizostosis. This is again a bone dysplasia, sclerosing type of bone dysplasia, normally presents in adolescence and early adulthood. Most common presentation is joint contracture and pain, as in this case also. It can be monostotic or polyostotic. When polyostotic, it tends to be monomilic, means one of the bones of one of the limbs get involved. Radiographic appearance, as we just saw in this case, is dripping candle wax appearance, which is characteristic of this. My third case is a 23-year-old boy. He presented with diffuse body pains, joint pains, and all. And he also had typical facial skin thickening. A bone scan was performed, and it showed diffuse cortical uptake in the long bones, involving bones of upper limb as well as lower limb. Okay, something like PCM, hypertrophic osteoarthropathy. X-ray also showed some shaggy subperiosteal bone formation. It also showed incidental Maitland deformity of both the wrists. Yeah, this is clinical picture of the patient. It shows diffuse skin thickening of the face and clubbing of the fingers. So this is a case of pachydermoperiostosis, also called primary hypertrophic osteoarthropathy or Touraine-Solantin bone syndrome. Again, the age of presentation is presented in adolescent boys, and clinical picture and clinical feature of facial thickening as well as scalp skin thickening, which we just saw. The clinical picture is very characteristic of the disease. Bone scan, as we just saw, shows diffuse cortical uptake, and X-ray shows shaggy subperiosteal bone formation. Yeah, involvement of epiphyseal region, as we just say here, that it involves the diaphysis, metaphysis, as well as epiphyseal region, is a feature to differentiate it from the secondary form of osteoarthropathy. So case 4 is again a young boy presented with the pain in the right hip, for which he needed attention, but he also had few other features, like he was very thin built and his clavicular region was very prominent, and he also had a history of femoral neck fracture on left side, but now the pain was in the right side. So this was the X-ray for the evaluation. So this contour deformity and this thin radiolucency in the left is related to the old trauma. Right hip was absolutely normal on X-ray, but his sacroiliac, both sacroiliac joints show some subchondral sclerosis suggestive of sacroiliitis. MRI was performed, which showed changes of sacroiliitis, hyperintense signals in bilateral sacroiliac joints, but edema was disproportionate, means it was involving, like normally we see edema or changes of signal changes in just juxta-articular region, but here it was involving much beyond the joint, like almost half of the sacrum and much more of the iliac bone also. He also had an X-ray which was otherwise unremarkable, except that his clavicles, you can see some moth-eaten type of appearance with some dirty looking periosteal reaction, which was symmetrical on both sides. Okay. And on MRI, there was another lesion which was involving the spinous process of C6 vertebra. Hyperintense signals here. So further an bone scan was done, which again showed all these areas increase uptake, like spinous process of C6 vertebra, both clavicles, symmetrical involvement, and sacroiliac joint. On right side, the sacroiliac involvement of sacroiliac joint is much more disproportionate sort of thing for just to call it a simple sacroiliitis. But the appearance of this clavicular involvement, which is called a bull's head sign, is suggestive of Sappho syndrome. Sappho syndrome is a constellation of synovitis, acne, pustulosis, hyperostosis, and osteitis. Well, pustulosis and acne is a clinical feature of skin, while synovitis, hyperostosis, and osteitis you have to see on imaging. So it again present in middle age and more common in females. While on imaging, mainly the most common joint or area of involvement is sternoclavicular joint. Other than that, you will see sacroiliitis. Then features of osteitis you will see as osteosclerosis, which involves vertebral bodies and metaphyseal region of the long bones. Bull's head sign, which we just saw, is kind of characteristic for this disease. Now, case 5 is a 55-year-old female She presented with the pain in the left thigh with no other significant past history. This is the X-ray radiograph. You can see a relatively well-defined large lytic lesion in the diaphyseal region with narrow zone of transition. It is causing some cortical thinning, but with no obvious periosteal reaction or soft tissue component. Being given the age, aggressive lesions cannot be ruled out. So an FDG PET scan was asked for to rule out a metastatic or myeloma possibilities. So this is a MIP image. You can see that lesion in question of diaphyseal left femur is not showing any significant FDG uptake, but she had some other skeletal lesions, which is in the pelvic bones, few and scalp. And you can see the scalp lesion as well as the ramus of the right mandible is showing some variable pattern of FDG uptake. So what other thing I want to your notice is that diffuse cortical uptake of the FDG in the long bones. Okay, so which kind of suggests that there is some increased bone metabolism is going on. So yes, so diagnosis here is basically metabolic bone disease with these lytic lesions suggests the possibility of hyperparathyroidism. Right. Why I am showing this case is because this case came to me for a review, and firstly it was reported, they picked up the finding and gave multiple differentials which include Paget disease, hyperparathyroidism of course, and malignancy as well. So now I want to show certain imaging features of hyperparathyroidism, so that because in such cases we really need not to give the differentials. So to start from up, you can see the here calvarium of this patient. So normally we see a cortex, thick cortex, and then medullary marrow, and then again an outer table, which is kind of missed here. And this appearance is called, like whole cortex and marrow all look same, and this appearance is called salt and pepper appearance, homogeneous appearance of the calvarium. This is one of the features. Then in the spine, although in this case it's not that apparent, but sometimes you will see rugged jersey spine appearance. Here somewhat in some vertebra you can see subentral sclerosis, which is a rugged jersey spine feature. Then subperiosteal resorption, which is described in phalanges. Then you see other areas of erosion and hyperparathyroidism is lateral end of clavicles as well as sacroiliac joints. So in sacroiliac joint you can see some shaggy articular surfaces. Then except bone, you look for bilateral renal calculus, and sometimes you can find some features of pancreatitis as well. Not to forget, in neck, once you see all these features, you have to look for a parathyroid adenoma. So in this case, it was nicely located in the typical location of tracheoesophageal groove, which if you don't think of the diagnosis, it's very easy to miss this adenoma. Now, just a quick recap. So firstly, we saw the ribbing disease, which is a diaphyseal sclerosis disease. You will see on X-ray some sclerosis of the diaphysis, mainly of the tibia, and mainly along the endosteal surface. Well, again, another disease of this spectrum is called Angelman disease, where it presents in childhood, and you will see multiple involvement of the bones. And then second case was myeluriostosis, in which we saw the dripping candle-X appearance of the X-ray, and many times it will be monomelic. Third case was of pachydermoperiosteosis, where the skin thickening of the face and scalp of the patient is the clincher, and you will see the same imaging cortical uptake in the long bones. The same we see in the hypertrophic osteoarthropathy, with epiphyseal involvement differentiated from the secondary osteoarthropathy. The fourth case was the Safo syndrome, where we saw the bull's head sign, which is kind of diagnostic, and the other features, as I discussed, is synovitis, acne, pustulosis. Acne and pustulosis is the clinical, while synovitis, hyperostosis, and osteitis are the imaging findings. The last case of hyperparathyroidism, where I discussed about on the CT features or PET-CT features of the hyperparathyroidism, what all we can look for, and obviously not to forget to look for adenoma in the neck. Now, time for some questions. So the first question is not an imaging feature of hyperparathyroidism. Erosions of lateral end of clavicles, blade of grass sign, salt and paper appearance, and rugged jersey spine. Second question is both side sign on the bone scan is being described in which disease? Menorrhaeostosis, pachydermoperiosteosis, Sapho syndrome, or hyperparathyroidism. Thank you for your attention.
Thank you, Dr. Anuj. That was really very interesting cases, all of them. Dr. Karthikeyan, do you have any questions?
Yes, sir.
Doubts? Yeah.
Actually, see, I had a doubt like how to differentiate a primary and secondary hypertrophic osteoarthropathy. Actually, clinically, we differentiate by looking at the skin involvement. If the skin involvement is there, we say it's a primary. If it is not there, we put into secondary category. And the point was well mentioned that involvement of epiphyseal region will be the point to differentiate primary, secondary. So, yeah. So another one thing was the Sapho syndrome. Clinically, we suspect the Sapho syndrome in people, especially the typical picture of a spondyloarthropathy. They have acne or a form of psoriasiform or a specific skin lesion. We always have a doubt as Sapho in the differential and weak because both the spondyloarthropathy will respond to NSAID and DMARDs as well as Sapho, but Sapho over time the response to therapy will differ. Cutaneous involvement will make the patient to seek the medical care early compared to people who are not having. So yeah, the bullseye sign is a classic. Even clinically, we see the involvement of sternum. The flat bone involvement is a very striking thing to have a differential along with the skin involvement. Yes, thank you. It's a nice talk.
If the chairpersons allow, I'll show one quiz question.
Yeah, sure.
Yes, sir.
Yeah, this is the quiz number 6. For those who are joining late, the answer should be given from the link called quiz in the right lower corner. Remember the correct option because the answers will not be mentioned in the options. Okay, this is slightly tricky. This is a 42-year-old gentleman presented with B symptoms, weight loss and fever, evaluated and found to have generalized lymphadenopathy, and biopsy has come out as Hodgkin's lymphoma, stage 3B. He is complaining of worsening breathlessness during the course of treatment. And we have done an interim PET after 4 cycles of chemo. This is the interim PET scan. You can see the findings, and you can see the findings in the chest, the fused PET CT images. This is the video file of the lung findings. You can carefully look at the lung findings. I'll play the video once again. So we go to the options. What is the finding on PET CT? Option A, drug-induced lung injury. Option B is COVID pneumonia. Option C is PCP pneumonia. Option D is progression of lymphoma. So while you are giving your answers, the winner of the question number 4 is Dr. Mohan Roop. The winner of question number 5 is Dr. Pooja Bharati. Thank you, chairpersons.
Okay.
You can take over.
Okay, thank you, Dr. Harish. So now we move on to the next topic, which is I myself have not understood. Oh My Foot by Dr. Shelvin. Dr. Shelvin is a consultant and head at American Oncology Institute, Baby Memorial Hospital at Calicut, and he's done his MD from PGI, and he's a FA and MB also. Over to you, Dr. Shelvin.
Just before talk, just I want to give a word. It is in a clinical practice, it's very difficult to see some of the cases when they come with a foot pain. We have some common differential for a foot pain. Recently, I saw a young girl. She is a 17-year-old girl. She came with a foot pain, and her uric acid was very high. And some physician gave a hypouricemic therapy. And after seeing the patient, I gave steroid for the inflammation in the both foot and ankle involvement. I had doubt. It could be a case of gout, but interestingly, it's not very common to see a gout in a female, especially a young female. Then I was thinking, why not be this a spondyloarthropathy? She is responding very well to NSAIDs, and even with a single dose of NSAIDs, she is responding very well. And now I'm in a state where to keep the diagnosis, to keep it as a case of spondyloarthropathy, or to keep it as a gout, or to suspect some other disease. So sometimes the disease is not very straightforward to a clinician to make a diagnosis by even on first or second consultation. So that time really the imaging plays a major role to help us for the proper diagnosis. So yeah, so just we move on to the topic. Over to you, sir.
Welcome everyone. This is a small presentation about the nuclear medicine procedures done in one of the terminal part of our limb, that's our feet. We seldom remember about them unless they are in deep pain. So welcome to this presentation of my foot. So when we remember about feet in respect to nuclear medicine perspective, first thing comes to your mind is the diabetic foot. There are two villains here. One is the neuropathy, that is Charcot neuropathy associated with the diabetes. Other is the diabetic osteomyelitis and infective sequelae. Unfortunately, both these entities share more or less the same clinical features, and both these entities can coexist and complicate each other. So the clinical dilemma here is to differentiate between a coexisting infection in the setting of an acute Charcot neuropathy. So what about the standard procedure, gold standard procedure, biopsy? Why not we do a biopsy in that setting and differentiate between the two? Being a terminal part of the limb, biopsy is very much feasible, but still it is invasive. But the real problem here is the low diagnostic accuracy. So most of these patients may be in various sort of antibiotics, which can give rise to false negative biopsy report. Then there is concern regarding skin contamination, which can give false positive report when we are searching for osteomyelitis. The other concern is introduction of a superficial infection into a deeper site-like bone while attempting a biopsy. So because of all these things, we are dependent on imaging modalities to differentiate between the two different modalities. Now, before going to the imaging modalities, we can just see the anatomical classification of Charcot neuropathy. That is a Sanders and Freiberg classification. Pattern 1 is in that part of the feet which is pretty much straightforward. That is the metatarsals and metatarso-phalangeal joints. Pattern 2 is the most common finding, which is in the midfoot. That is in the tarso-metatarsal joints. And the second common is the pattern 3. That is this is the talus bone, navicular bone, talonavicular joint, calcaneal and cuboidal, calcaneo-cuboidal, and the navicular and cuneiform joints. Both these type 2 and type 3 constitute the bulk of the anatomical site where Charcot neuropathy can occur. And unfortunately, these are the site with the maximum complex bony architecture also, making it all the more difficult in imaging. Pattern 4 and 5 are very less common, the angle joint and posterior part of calcaneum respectively. Now, this staging is with respect to the clinical progression of Charcot neuropathy. Earlier in Eisenhower staging, it was stage 1, 2, 3. It was modified to incorporate a stage 0, which is an in situ stage. The finding is of a acute foot, that is in the erythematous, swollen, painful foot clinically, but the X-ray or CT at this stage is negative. MRI can pick up early changes like bone marrow edema signal changes, and some early stress fracture can be picked up. In stage 1, these bones start fragmenting and dislocation may be there. So in this stage, the inflammation is maximum. So X-ray and CT may be positive because bony changes starts appearing. Then it progresses to a coalescence stage in which the bony fragments starts fusing each other. Here the inflammation starts subsiding. So this is the stage 2 or coalescence. At the end stage is the stage 3 or the consolidative stage. The bone fuse each other. They falsely remodel and form deformities. So end stage result of Charcot neuropathy is a deformed foot. So typically in this stage, there will be no inflammatory signals. So CT or X-ray can find the progression or stage of Charcot neuropathy. But what they can not find is an infective focus from acute Charcot neuropathy findings. So as I already told, X-ray or CT, often the earlier imaging modalities, because they are inexpensive, available, they can detect other bony pathologies like fractures, but they may be picking up the bony changes late in the course of the disease. So in stage 0, they may be negative. And the other things like they may be non-specific because either whether it is osteomyelitis or whether it is Charcot neuropathy, findings are more or less the same in X-ray or CT. Now, what about MRI? MRI is very sensitive because it has high soft tissue contrast. It can lead to early detection of marrow changes, but still the marrow changes may be due to osteomyelitis also. It can also be due to acute Charcot neuropathy. So there is still a problem of non-specificity. Now, coming to the nuclear medicine procedures, the gatekeeper imaging modality is always 3-phase skeletal scintigraphy. So it has high sensitivity, whether it is infection or inflammation, it has pick up early. And the only positive thing about bone scan is if it is negative, then we can rule out either acute Charcot neuropathy also or infection also. So it has high negative predictive value. But in an acute Charcot neuropathy setup, it is almost always going to be positive. So still, like in this patient, 3 phases, flow, blood pool, delayed phase, all the 3 are positive. Still, we are clueless that if it is due to infection or due to neuropathy. So we need some more specific traces, like for finding out infection, label leukocyte studies are more specific, like technetium or indium 1 level label leukocyte studies. So they can enhance the specificity, but there is still a problem because in acute Charcot neuropathy, there may be complex neuropathic changes which may lead to marrow activation. This non-specific marrow activation can lead to WBC accumulation in them, and label leukocyte studies can still positive without any infection in acute Charcot neuropathy setup. So we need something to localize if it is due to non-specific marrow accumulation. So a separate dual imaging with technetium sulfur chloride to know about the marrow status is may be needed. So let me explain with this patient. That is, in this patient, all the 3 imaging modalities were done. This is the delayed phase in the bone scan, in which the posterior calcaneum there was an uptake and there was diffuse uptake in the mid-tarsal joints in the other foot. Label leukocyte study also showed the same findings. But in marrow imaging, you can see that there is no uptake in the posterior calcaneal aspect. So this is not due to marrow activation. While in the left foot, the mid-tarsal finding is due to the marrow activation and sulfur chloride is showing an uptake. So here we can say that the label leukocyte is positive in the posterior part of calcaneum and marrow is negative. That is non-congruent finding between label leukocyte and marrow imaging is an indication of infection. So that's one way to make it more specific. Now, of course, the addition of SPECT-CT is very much useful because mid and hind foot has complex anatomy. So more anatomic specificity is needed here, whether it is in the bone or soft tissue or in the joints. And it can still add to increased specificity also. Some studies show that it can result in reduction in hospital stay also if SPECT-CT is done along with this. Now, various other imaging modalities have been used, like FTG PET-CT, because it is still better than SPECT-CT for resolution. And compared to the label leukocyte studies, it is shorter duration. Still, the FTG used is a non-specific marker for infection or inflammation. So FTG can accumulate in osteomyelitis also, Charcot also. So there is still a problem of specificity. And PET MRI is one step ahead of PET-CT because MRI is still better than CT in finding out infection. It has superior soft tissue resolution and lower radiation is an advantage. Still, the FTG we are using in FTG PET-CT or PET MRI is the same FTG, and it is a non-specific marker for infection and inflammation. So the most specific imaging modality to find out infection in the setting of an acute Charcot neuropathy is F18 FTG label leukocyte PET imaging. Then also it comes with a longer cumbersome labeling techniques and manpower is also required. But still it has a reported specificity of close to 100%, especially when it can be combined with a very sensitive modality like a fluoride bond PET-CT imaging. Let me explain. This is the fluoride PET-CT imaging in a patient. The fluoride is showing increased uptake in the head of the metatarsophalangeal joints, while the lab and the leukocyte study is positive only in the head of the metatarsal. So the infective focus is only limited to the head of the metatarsal. The other background findings are the acute Charcot neuropathy findings. Now, another patient, the upper panel is the flow rate PET CT, the lower is the labeled FDG labeled leukocyte study. So there is intense flow rate uptake in the metatarsophalangeal joints, but the label leukocyte study, FDG label leukocyte study is negative in this, but it is showing a separate focus in the skin surface where there was a clinically evident ulcer was present. So this ulcer was only showing infective focus, while the deeper side, like bone, was negative, and it was proven by biopsy. So flow rate and FDG labeled PET CT can be combined, and both their sensitivity and specificity can be utilized to differentiate an infective focus from a complex acute Charcot neuropathy setting. So that was about diabetic foot, and the take-home message here is specificity is the villain, and specificity comes at a cost, especially in complex anatomical structure like a foot. So because other indications include, because they are diagnostic, they can be used for responsive evaluation. Like in this study in which flow rate PET CT was used to see the efficacy of teriparatide in Charcot neuropathy setting. The flow rate PET CT was used in between the use of teriparatide to find about the response. Now, there is some time left, so we will quickly revise through some straightforward cases. These are three-phase bone scan studies done in when there is a setting of acute pain in a runner or an athlete. So these are pretty straightforward cases. So this is the three-phase skeletal scintigraphy in a patient where the blood pool image and then the delayed phase image. This is the SPECT CT fused images. There is an uptake in the inferior aspect of the calcaneum and another in the posterior aspect of the calcaneum where the Achilles tendon is inserted. So this is coexistence of plantar fasciitis and Achilles endocyopathy here in the same patient. So the second case is that of an acute bone pain, acute foot pain in a runner, in which there is a sharp uptake in the sesamoid bone. So this may be due to sesamoiditis. Another patient in which in the blood pool there is a linear uptake along the linear uptake, and in the delayed phase there is a sharp focal uptake in the lateral aspect of the calcaneum. So this is due to the peroneal tendinitis. And ending the slides with the most common cause of foot pain, that is the stress fracture. This is the typical stress fracture in the fifth metatarsal, that is the Jones fracture, which can be picked up in a bone scan. Although MRI is a better imaging modality, still sometimes three-phase skeletal scintigraphy may be useful in these sort of patients which present with acute foot pain, especially in athletes or runners. So that was a small presentation regarding various nuclear medicine procedures in short done in the foot. So thank you organizers for making me part of this event, and also all the listeners for their patient listening. Thank you very much.
Thank you, Dr. Shelvin. That was a very excellent presentation, especially for about the diabetic foot, what you're talking. But what I want to know is, do you regularly do leukocyte imaging, or for all the cases of this Charcot joints?
No, sir. Not regularly. We will not be doing regularly the leukocyte imaging in every patient, but in the setting of an acute neuropathy, if there is a background of acute neuropathy, then most likely it is only the planar bone scan only sensitive. It cannot differentiate between an infection. So
yeah,
leukocyte imaging is most likely necessary. Now, if the most specific is FDG labeled leukocyte study, but that may not be available in many of the centers.
I don't think any center, very few centers.
Very few centers like PGI can afford
PGI
that because it's a technically demanding procedure also. But in other
for
centers,
a common diagnostic center or for a common center, what is your
technician level leukocyte study?
What is the advice? What do you do?
Technician level leukocyte studies can be done. Especially now every center has PET-CT also advantage. So it can sort out most of the issues.
Okay. Thank you. Dr. Karthikeyan, any?
So that is a nice talk. Actually, I was expecting some more rheumatological entities of feet. Yeah, of course, a common thing. Yeah, we see day-to-day practice. We see more of diabetic food, right?
Yes,
so it's supposed to be. Yeah, it is supposed to be taken as a priority. No doubt in it.
And the major challenging issue is the diabetic food. The other cases in three-phase bone scan is pretty much it's a spotter type of cases. So
a single shot we can able to give at
yes, sir. Because this diabetic food need more attention. That's why I included that in the main major part.
Understood. Yeah.
And of course, the time is only 13 minutes, so we have limitations in that too.
Things are supposed to be given a priority. Thank you. It was a nice talk. Thank you.
Okay. Thank you, sir. Thank you so much.
Shall we move on to the fourth last part of the session?
Yeah. You want to introduce Dr.
Yes, yes, sir. So move on to the last part of the session. So Subbu Jacob, consultant head, Amara Institute of Medical Science, and the topic is focused on facial asymmetry. I am awaiting to look into the topic. What is the discussion part on facial asymmetry? Because we see more of JA cases. They come with the involvement of one aspect of temporomandibular joint. They come with the micronathia, retrognathia. Rarely we see PRS, pair Robinson sequence BC. So just I want to know like what will be the discussion part. Sir, over to you, sir.
Yeah, please proceed, Dr. Shelby.
Welcome all. I'm Dr. C. Jacob from Department of Nuclear Medicine and PET-CT, Amala Institute of Medical Science, Thrissur, Kerala. So I'll be talking about role of MDP bone scan in unilateral mandibular condylar hyperplasia. And a special thanks for Dr. Philip Matthew, maxillofacial surgeon in Jubilee Mission Hospital, Thrissur, who has given me all these cases, referred all these cases. So unilateral condylar hyperplasia is nothing but non-neoplastic overgrowth of the unilateral mandibular condyle without any pathological change in any other joints. So it often results in facial asymmetry, deformity, and malocclusion, and sometimes associated with obvious pain and dysfunction. Commonly, it occurs in age group during the growth phase, especially in adolescents at the age of 10 to 30 years. Females appears to be more affected than the males, and etiology actually is not known. Local circulatory problems, endocrine disturbances, and trauma could be attributed for the same. The categories and a classification has been given by Obwegesser and Mackek, where we have three types. One is hemimandibular elongation, hemimandibular hyperplasia, and combination of both this. So hybrid form. So in the first type 1, in hemimandibular elongation, what we see is there is a chin deviation towards the contralateral side. You have a midline shift to the contralateral side, the lingual deviation, and a possible posterior crossbite. So crossbite is nothing but there is a misalignment of the upper and the lower teeth, where bite is not properly done. In type 2, we generally don't see a midline shift and there is a minimal chin deviation, but what we prominently see is a sloping rima oris to the contralateral side. Supra eruption of the maxillary molars on the affected side can be seen in these cases. And in type 3, you have a witching deviation and with sloping rim over. So you have a combination of both type 1 and type 2. You have a midline shift, and you can have an open bite or a closed bite both. So here we can see it in the upper left side. You can see the hemimandibular hyperplasia, where you can see there is no shift of the midline or minimal shift. But in hemimandibular elongation, you can see that there is a clear cut a deviation of the chin towards the opposite side. So what is important here is, while assessing for a condylar hyperplasia, it's very important to see if it is an active phase or a stationary phase. They usually say that activity level of the condyle is considered to be correlated with the mandibular asymmetry, but in some cases it's not true. And some studies have mentioned that there is actually no correlation with the activity level. It doesn't matter if it is a 60% or a 65% of an asymmetry. That doesn't, that's not correlated with the mandibular asymmetry or the extent of the dental occlusion or any other symptoms. So in these cases, as I said, it's very important to differentiate between the active and stationary phase, and bone scan helps in that. We'll see in the coming slides. So actually what we do whenever these cases are being diagnosed, or if there is a suspicion of such a condylar hyperplasia, they usually go with the CT scan initially, and then to see the activity, they go for a MDP bone scan. And MDP bone scan also, you particularly have to do a SPECT CT, which gives you a better, better information. So coming to the pathological features of the condylar hyperplasia, when a condylar cartilage actually is divided into 4 layers. One is perichondrium, then is proliferatory zone, hypertrophic layer, and the calcified cartilage layer. So what actually is seen in the condylar hyperplasia is that you have a thickened proliferative and hypertrophic layer with or without thickened perichondrium. So basically, as I said, the first investigation which they do is a plate radiograph or a CT, where you can see there is an asymmetrical enlargement of the mandibular condyle with elongation of the neck and a symmetrical overgrowth of its body and ramus. It might be you may or may not appreciate much, but still there will be a overgrowth of its body and ramus. No cortical thinning or cortical destruction is seen in these cases. Here, as we can see on the right hand side, you have a coronal section of a CT scan, where you can see on the left condyle there is a expansion of the condyle, and in the left side you can see a reconstructed image. And this is what an advantage of doing a CT scan in these cases, where you can actually see what you can actually come up with that reconstructed image, and they can decide upon how much to be and how much to do the surgery, and how they can align it for a proper facial and symmetrical how to do a symmetrical surgeries. So coming on to the SPECT and bone imaging, the protocol is same. We after 3 to 4 hours after injection of 20 to 25 millicuries of technetium and MDP injected via the elbow veins, we generally have we generally do a scan, and the system we have is G Infinia Hawkeye 4 SPECT CT scanner. The collimator usually what we use is LEHR, and the SPECT scanner is collected over 360 degree in a spherical field of rotation using a 128 into 128 matrix at 15 seconds per frame. So, and this is actually reconstructed to coronal, sagittal, and axial planes. Image analysis actually is done by visual and as well as the quantitative method. In the quantitative method, we draw an ROI, region of interest, which is drawn around the condyle that represents the area of a prominent technetium of an MDP uptake. The ROI is then copied to the contralateral side to avoid any discrepancies. Ratio of the unilateral count to the sum of both the counts was calculated for relative uptake. Here, what we have taken is difference of what 10% or above was considered as an indication of an hyperactive condyle. There is a controversy regarding this. Many Many of the studies also tell that a difference of greater than 5% is considered to be significant. But there are there are other articles which generally say that significance should be given beyond greater than 10% of difference. So why I have taken 10% of difference is that the surgeon which refer the cases to me actually consider 10% as the cutoff and then decide for the treatment. So I have I had 8 number of cases, of which 7 was female and 1 male. In the age group of 15 to 27 years of age, median of 18.5 and mean of 19. 3 of 8 patients had a hypoplasia, hemimandibular hypoplasia, and 5 of 8 patients has had a hemimandibular elongation, of which 4 had a non-like dental occlusion upper and lower jaw misalignments. So of these 8 cases, as I said, 5 cases was having a uptake difference of greater than 5%, and 3 cases had a difference of less than 5%. So of these 5 cases, 3 had a difference more than 10%, and all 3 underwent condylectomy with the corrective surgery like OGS or orthodontics. And all these 3 had an HP changes positive for hypoplasia. The other 2 cases which had 5 to 10% difference, which we generally call it as a indeterminate on a focal zone, they have been followed up. There was no disease progression, and then they have undergone OGS or the orthodontic surgery after the growth age ceased to correct for facial deformity. So here we have to see that these patients are undergoing surgeries, the corrective surgeries, only after the cessation of growth age. That's only because if you correct it early during the growth phase, this condylar hypoplasia may again come up, and you have to do a resurgery, which is very difficult and traumatic for the patient too. So generally they prefer doing it after the cessation of growth age. As I said, 3 cases were having less than 5%, and 2 cases had an orthodontic surgery, which for correction of facial asymmetry in these cases. 1 case actually lost to follow-up. This is one of the case which is an 18-year-old female with a complaint of facial asymmetry and dental malocclusions and other problems. MTP in aspect C shows that there is an increased osteoblastic activity in the right mandibular condyle, about 61%, and then she underwent condylectomy and a corrective surgery by the age of 22 years. As I said, condylectomy was done earlier. The corrective surgery was almost like 3 to 4 years later. So that they generally make sure that beyond which the recurrence of disease doesn't come. Follow-up doesn't show any recurrence, so this patient was treated successfully. So basically, this is the flow chart of the treatment which they do. When the patient comes, they go for a documentation of a dental compensation or any maxillary canting, any occlusive planting. You have to do a classification. You have to see if there is any progression. And if any progression is there, you go for a spec CT. A spec CT, if it shows greater than 10%, you go for a high condylectomy. And when after 6 months, there is no other problem, you have to go for a treatment for the surgery. Like orthodontics, leaf osteotomy or mandibular osteotomy, genioplasty, and mandibular contouring. And this is mainly for facial asymmetry, teeth malocclusions. You have to go for osteostomies for the protrusion or the retraction of the jaws, and such kind of corrective surgeries. So if the when uptake is less than 10%, which is actually controversial. If it is 5 to 10%, still they go for a wait and see for 6 months. Again, they document it. If there is a clinical progression, you go for a high condylectomy. If there is no clinical progression, they usually don't go for any treatment. If they have any major facial abnormality, they go for the corrective surgeries. So this is an example which I have taken from internet. You call this as an orthodontic surgery or OGS. where you can see in the above on a picture, you have a protruding lower jaw. What you can do is osteotomy, that is you cut a certain part of the mandible and you recede it. So in the lower images also you can see that on the left hand side there was an open bite. What they do is they just remove a part of maxilla so as to correct that open bite. In the protrusion, as I said in the above picture, it's the same. You recede it, and if it is a receding, on the third image, you can see that there is a receding lower jaw. So what you can do is you can just cut it and pull it forward. So accordingly, this is mainly the mechanical thing which they do, but it's very but minute surgery which they have to do, because even a 1 to 2 mm or 3 mm of difference will make a big difference in the facial contouring. So in the conclusion, what I have to say is bone scan actually highlights the areas of increased osteoblastic activity, which helps in diagnosis of active or inactive condyle hyperplasia. It eventually guides in treatment decision for condylectomy for high and active CH or definitive operations for inactive and hyperplasia. Definitive interventions may involve the osteotomies, as I already said, to correct any residual malocclusion or facial asymmetry. Post-surgical deformity may develop if the osteotomies are performed while this condylar hyperplasia is in the active phase. So as I said, the active phase should be stopped. The growth phase should be stopped, and then after only you generally do a surgery so that the post-surgical deformity should not happen. So this the last slide, and this is the last slide where we can see what is the false positivity for this cases of kind of bone scans. The only thing is that you have a degenerative or inflammatory arthropathies of the temporomandibular joint, which may complicate the evaluation of the growth activity of the condyle. So which may manifest inherently in the increased MDP uptake in the TMJ. So, but one thing is that degenerative bone changes generally occurs on the opposite unaffected side rather than the affected hypoplastic side. And the CT portion of this PET CT or even the normal CT, which you can do is which you do, can be used to evaluate the underlying bone changes to confirm the degenerative or any other possible causes of increased uptake, such as a trauma or a tumor. So besides this, it's very sensitive, highly sensitive scan, and very helpful to have the management done for the men's facial surgeons. So these are my references. Thank you for patient listening.
Yeah, that was a very excellent presentation, Dr. Sibu. Something new to me also. So what I would like to know is, post surgery, have you followed up any of these patients? Have you again repeated bone scan later on?
Yeah, 2 to 3 patients actually. This the place which I'm working is not where we get these cases. Actually, this is from outside. So, the doctor told that 2 to 3 cases have actually been followed up and they didn't had any recurrences. And, as I said, one patient was already lost to follow up. These patients actually had a very good successful surgery after doing a condylectomy, and then after the cessation of these growth age, they go for a corrective surgeries. So this corrective surgeries actually is mainly done mechanically. Start at the initial part, they do a CT reconstruction part, 3D reconstruction, and then mechanically they will adjust how much they have to cut or how much they have to put in a new bone.
But did anybody have any relapse after this surgery?
Actually, one had, because that was not of this case. That patient actually had in a hyperplasia of the condyle. They have done the condyle as well as the corrective surgery at that time, because that patient had a biting issues. So and having a pain. So in that cases, they actually did both within a span of 6 months. the condylectomy as well as the corrective surgery, but still the growth phase was still gone, and that condyle was actually done a partial condylectomy. So that patient had again relapse, and then resurgery had to be done. But after that, I don't think so. That patient had any relapse after once he had a relapse with that case.
Okay. Dr. Karthikeyan,
Yes, sir.
Now, one quick question for the want of time. We can have one quick question.
Actually, in JAA, sometimes the patient, because of disease activity, they can go into two extreme, where they can go for a condylar hypoplasia or can go for overgrowth. How to deal with the overgrowth, and they go for a condylar overgrowth because of JAA?
So I didn't get the question, sir.
Actually, because of JAA, so when they go for involvement of a TM joint, there will be overgrowth on one extreme where condylar overgrowth can be seen, and another extreme where they can go for hyperplasia. So in disease activity per se, there will be involvement of other joint as well. So the patient will be coming with the systemic involvement. Generally, other joints will be affected, and they come with the TM joint involvement. So only when I control the disease activity from the medical side, so we have to control the disease at the earliest to stop the progression of the disease. From surgical side, you are going to deal in the same way. You will do a condylar osteotomy for the management.
When surgical side, we generally do a condylectomy only, and unilateral with this hyperplasia usually actually doesn't involve any other joints. The only presentation is with the asymmetrical part and the occlusions. If other surgeries has to be done or any other diseases been there, they evaluate with the clinical status of the patient and then go for the surgeries.
Actually, we in our practice we don't have a problem with JAs because those patients don't present to us in this way. What Sibu has presented is only the unilateral condylar hyperplasia cases. So I don't think there is comparison between JA and this unilateral condylar hyperplasia in our cases. Anyway, for the want of time, we'll close the session. I'd like to thank the chairpersons, Dr. Zakir Ali sir, Dr. Karthikeyan sir, and all the four speakers for doing an excellent job. Before we move on to the next session, we'll have the quiz number 7. The answer to the previous quiz number 6 was drug-induced pulmonary injury, and the winner of that quiz was Dr. Mohan Dhruv. So for those who are joining in now, you will have to click on the quiz link in the right lower corner of your conference portal and select the correct option. Just remember that the answers will not be shown, only the options will be shown. So this is a basic investigation that we do day in and day out of our nuclear medicine practice. I'm not giving any history. I'm not giving you any hints. These are the images. These are the splash page images. So what is the diagnosis? Option A, transplant kidney with hydroureter. Option B, it's a labeling error. Option C, it's a right multicystic dysplastic kidney. And option D, it is a single functioning renal mass with hydroureter. I'll show you the images once again. Well, thank you. We move on to the very interesting endocrine session. Endocrine session is going to be divided into two. The initial first part of the endocrine session will be chaired by Dr. R.V. Parameswaran sir. He needs no introduction. He's an extremely famous extremely famous person, nuclear medicine physician from Bangalore, Manipal Hospital. And to chair the session, we have Dr. V.L. Balaji, who is a young and dynamic surgical oncologist from Trichy. I hand over the session to Dr. Parameswaran sir and Dr. Balaji sir.
Thank you, Hari. Am I audible?
Yes, sir. Yes, sir.
Am I audible?
Yes, sir. It is very clear, sir. Yes.
Okay. At the outset, let me congratulate you for the wonderfully organized event. It's a beautifully well-streamed conference, and I'm really proud of you youngsters. You're really doing a fantastic job of this. So coming to the interesting section as what you're talking about, it's an endocrine session. And the first speaker is Dr. Sumit. Sumit is my colleague from KMC in Udupi. And he's a winner of the nuclear medicine quiz at SNMI in Baltimore with a lot of publications and an extremely high nuclear oncology enthusiast. Over to you, Dr. Sumit.
Good evening, everyone. So on the onset, I would like to thank the organizers for asking me to present on this topic. My topic is low-risk thyroid cancer. And I'll be explaining you like whether it's really low and on what parameters we should base our decision on. Okay, so it's actually a kind of high-risk decision. Okay, so we all know that the overall survival, disease-free survival, progression-free survival, everything is very well with thyroid cancer. And this is, as they say, the best cancer to have. The overall survival of well-differentiated low-risk thyroid cancer is more than 99%. And the mortality rate, we all know, is around 0.3%. There has been an overwhelming increase in incidence of thyroid cancer across the globe. This is equal for all the regions, be it US, be it our country. So when we looked at the US data, so there is a significant increase in the incidence. However, most of the cancers are papillary in nature. This coincided very well with the increase in imaging which they did, be it for thyroid or not for non-thyroidal illnesses. And if you see the ultrasound, the number of ultrasounds done across the age groups are slowly increasing. The same trends we see it in our country also. Both in women and men, the incidence was increasing. And particularly in South India, this was very surprising. Like the blue is Tirunelveli. In Tirunelveli, there are overwhelming increase in the incidence rates, as you can see over the years. They did not attribute this to the availability of the healthcare setup in Kerala, which is pretty good as compared to other parts. They, in that particular article, they said that even though all the other cancers incidence rate were actually relatively compared with the previous years, thyroid cancer was the one which was increasing significantly. And they attributed this to increasing diagnosis. However, we should note here that more than 50% of the tumors are less than 1 centimeter, that is papillary microcarcinomas. Where does this so-called papillary microcarcinoma stay? They're right there at the bottom, right? It's the lowest risk one can ever have. But however, we do know that there are certain patients whom we see there who presents with metastasis, but when they undergo thyroidectomy, it's just a microcarcinoma. Maybe we have all come across such patients. And therefore, there are certain controversies in primary treatment of low-risk papillary thyroid carcinomas. This paper had put that controversies very well. Basically, the whole idea or whole controversy is how to differentiate between the clinically unimportant thyroid nodules, which the patient may have stayed with throughout their life, versus, oh, we should have diagnosed them earlier, right? They presented with metastasis now, and we think that if we had diagnosed them earlier, we could have treated them better. This is the whole controversy about. So when they looked at treating papillary thyroid microcarcinoma with active surveillance, right? with curative intent indeed. They analyze whether it was time to shift from surgery to active surveillance. Okay. And if you see at the conclusion, they have told that active treatment can be delayed until the cancer shows signs of significant progression. That means you need to follow these patients up. And here is the caveat: in properly selected patients. Now, what are these properly selected patients? That means you can't just follow up each and every one, right? You have to select the patients whom you can actually follow it up. So the whole thing boils down to this, right? How well can we assess a tumor behavior when they are found small, right? Most of them can relate with this image, I think. If those who don't know, this is Lord Voldemort. He's a small kid whom the elderly guy is Dumbledore. He actually takes this kid to teach him magic, who later, turns bad and creates all sort of havoc. And what tools do we have actually to see through the small tumor and assess its behavior? Let's begin with imaging. So ultrasound is most commonly performed imaging, easily available, economical. So how we can use this tool to actually assess the tumor? So when they actually looked at all the ultrasound images of the patients who were low risk or papillary microcarcinomas, they wanted to look what are the imaging features in patients who presented with lymph node metastasis but had papillary microcarcinomas as primary. So most of the people came up with these features. The first one is papillary carcinomas with microcalcification. It's not microcalcification, it's actually punctate heterogeneity. The second one is multifocality of the tumors. And the third one is the size. So most of the papers, they say more than 5 mm, the probability of lymph node metastasis is pretty high. Now, when they did a review and meta-analysis of all the studies which are done, this is something surprising, like absence of elasticity came up to be the most sensitive and specific parameter and had a very good post-test probability of detecting lymph node metastasis in a patient with papillary, with the thyroid nodule less than 1 centimeters. But we know that elastography is not done across the sites, and very few people actually do elastography. However, in conclusion, they have maintained that there is no clinical and radiological features can reliably predict the indolent or aggressive behavior in low-risk thyroid cancer. So you can't rely only on ultrasound to make the judgment. Can FDG PET-CT help? Yeah, they did see how we can analyze the metabolic behavior of thyroid cancers. When they did an univariate variances, they did find that SV max was significant, although quite narrowly achieving the margin. The p-value was 0.02. However, in multivariate analysis, they found that it was not significant. We all know that SV max is quite difficult actually to maintain or to analyze, particularly in Indian setup when you have a lot of patients coming over, when you have infections in the oral cavity. It's difficult to actually rely on SV max. Opened MR. MR, they actually analyze the radiomics which is available right now. They did T1 weighted contrast enhanced MR imaging, T2 weighted and diffusion weighted imaging. And also they combined all the three features and they looked at whether they can actually diagnose metastasis in them. When they drew the ROC curve and they got a significant area under the curve was 0.83 when they combined all these three features and developed a RAD score for that. Coming back to ultrasound, actually, this is where the new AI or machine learning is coming into the picture. So when they analyze the thyroid nodules their texture, how they are. Based on all the inputs, they will give extrathyroidal extension, microcalcification, size, etc. And they developed a machine learning tool for this. The lymph node probability was astoundingly 90.5%. I mean, with machine learning, they could identify certain features of the nodules in whom they could predict lymph node metastasis. Coming next to FNAC, what we can do with FNAC? So right now, molecular markers are the new generation predictive prognostic factors. Apart from telling that it is a papillary thyroid, we need to look beyond that. So there are a few mutational sequences which we know, that is RED PTC, RAS mutation, BRAF, and PIK3 pathway. So one of the very good paper which I found was from Professor Hagen and Martin Schlumberger, the progress in molecular-based management of the papillary differentiated thyroid cancer. Based on FNAC and these molecular markers, they generated this particular algorithm chart, where for the first three categories, Bethesda 3 categories, they had a high sensitivity or negative, they developed a high sensitive or negative predictive value molecular markers. Versus if it was category 4 or 5, they developed a high specificity and positive predictive value marker. What they saw was the RAS, PIK3, and PTEN mutations increasingly occur and coexist in the thyroid tumors. And they increase from low grade to high grade. So their coexistence could thus favor or predict progression of thyroid cancer. So if you have a papillary microcarcinoma, you have done an FNAC, it turns out to be PCT. If you analyze these three mutations, if they're positive, they're coexisting, probably this is a guy who will, whose tumor is actually aggressive, and in coming days, it's going to progress. What are the clinical pathological features which we can analyze? So we all know when we get patients, actually, like if it is young patient, we do know that the thyroid cancer behave in a slightly aggressive manner in younger age groups. Some of the histologies, when we read the histopath report of the patients, we come across certain histological patterns, and some of them we do know that they are aggressive, like tall cell variant, columnar variant, or diffuse sclerosis variant, and all. Third is the size. Size margins are across cancers, I think it's the same. If it's the size is more or the margin positivity, everything relates that the tumor is aggressive and they need probably some additional treatment. The same is with the thyroid cancer also. And the last is the mutational status, of course. So how do subtyping of, when we see the pathology, does subtyping actually help in choosing the patients who will go for more aggressive treatment? When they saw that papillary thyroid with tall cell variant had a recurrence rate of 5.4%, which is slightly higher than the low risk. If you compare the papillary microcarcinomas and or the T2 tumors who still come under low risk, microcarcinomas with tall cell variant actually had a recurrence rate of 5.4%, which is slightly more than the general low risk, which is around 2%. Coming to other histological characteristics, what they found was the tumor diameter. If you see here, more than 5 mm tumor diameter, actually the patient starts to present with neck node metastasis. And more than 8 mm, they start to present with distant metastasis. So this is the pattern which they saw. And when they analyzed patients who actually had papillary microcarcinomas but distant metastasis, they wanted to see what other histological characters they could find out. So when they analyzed those patients, they saw that patients who had distant metastasis but microcarcinoma in thyroid were most commonly elderly in nature. When they looked at the histopath, they had diffuse sclerosis variant of the cancer and capsular invasion. You can see here the tumor invading into the capsule and multifocality. So these were the features which came up across most of the patients in whom they thought that even though the tumor was a microcarcinoma, they presented with distant metastasis with these features. So if at all you get a patient, if you read the histopath report, you see a diffuse sclerosing variant or a multifocal variant, you need to be a little careful in them. When they analyze the mutational status, of course, the RAS mutation pathway with PIK3 and BRAF was positive. And the third promoter region. So they say the BRAF and the third promoter, when they mix together, it forms an aggressive cocktail, which will drive the cancer. It will be very aggressive in coming days. Now coming to when you actually see the patient, so there is something called as incidental papillary microcarcinoma, non-incidental. Incidental means the patient has undergone thyroid surgery for some different reason, probably for a benign thyroid malignancy, benign thyroid disorders, versus non-incidental. Non-incidental is, the patient has some thyroid nodule. You go in, do hemithyroidectomy or so, then find out that it is a microcarcinoma. So this is non-incidental. So when they analyze, large systemic review was done, they saw that the size of the tumor of incidental thing was very less as compared to the size of the tumor for non-incidental. That means in the patients whom we knew that there was a thyroid node. And what they saw, the lymph node metastasis pattern. If you look at this, only 19 patients of 728 patients presented with lymph node metastasis if it was incidental finding. If it was a non-incidental finding, there were overwhelming increasing lymph node metastatic rate. So what was the clinical implication of the study? Tumor recurrence actually overwhelmingly occurred in non-incidental papillary thyroid microcarcinomas. And crucially, our study showed that nodal recurrence is the main site of recurrence in these patients. So when you look at the predictive factors, so age less than 55. So here is the controversy. If the age is less, they can progress. If the age is more, there is high chance that they have already progressed and they might present with distant metastasis. So if you get an elderly patient, you have to look for distant metastasis. To get a younger patient, you have to watch carefully because he can progress shortly. Multifocality, lymph node metastasis. So these are the three features in whom aggressive behavior was predicted. Most of the lymph node recurrence occurred in central compartment as compared to the lateral, and very less had distant metastasis. So in conclusion, that's to say, more than 55 years, multifocality and lymph node metastasis at diagnosis are good initial predictors of recurrence. Same thing was told in this paper also in surgical oncology, European Journal of Surgical Oncology. They said more than 5 mm was a predictor of distant lymph node metastasis. When you look at all these things, there arises a question that should we treat all the thyroid microcarcinomas aggressively? So when they analyzed 18,000 cases, they found that one is age less than 45. Then second one is extrathyroidal extension. Third one is lymph node metastasis. So age, extrathyroidal extension, lymph node metastasis, and distant metastasis. If you find people with either of these features, you have to obviously treat them aggressively. So what is the take-home message? Since we're all sitting at home already, so it's a recall at home message. Not all microcarcinomas are low risk. On ultrasound, make sure you see the features of the ultrasound. First thing is to look at the size, the microcalcifications, if there are any capsular invasion which is seen, or lymph node metastasis which is present. Lymph node mets on ultrasound, it is little difficult to identify the central compartment nodes. However, do make an effort to either ask your radiologist to look for them, particularly if the nodule is small. And clinically, if it's the young age patient, they are more prone to progress. You have to have active surveillance or maybe short follow-up. Elderly, do look for distant metastatic sites if you find a microcarcinoma in them. On histopathology, do read the histopath report. So you can find aggressive histologies like tall cell variant, diffuse sclerosing variant. Look at the multifocality, look at the lymphovascular invasion and extrathyroidal invasion. Of course, we have mutational analysis. The thing about this is that it's not easily available outside. It's very costly too. Actually, it's more costlier than the treatment which the patient receives. So at the end, this is the message, like, do not own the disease, respect it. Don't just shrug it off that it's a microcarcinoma. These are the patients which will come back to you if they have certain risk features with them. What is the future? The future is radiogenomics, of course, and machine learning. They will see beyond what we are seeing. The machine will tell you like whether the particular node which we are seeing, even though small, has certain characteristics which can predict distant metastasis. And secondly, molecular thyroid medicine, like every patient probably in near future, we will be treating based on their molecular setup in their body. So this is something which I found very interesting. Probably you will also dwell upon it. In 1970, the mortality rate of thyroid cancer was 0.3%, okay, of all deaths. In 2021, it's still the same, right? This is something we should think on. Thank you.
Thank you, Dr. Sumit, for the wonderful presentation.
Thanks.
Should we move on to the next speaker? Or any questions are there?
Dr. Balaji, sir, you want to ask anything? Okay, if there are no questions, we can proceed.
I think let's move to the next speaker, Dr. Ranadhir. Ranadhir, I think, needs no introduction, to be honest. He's a rising or rather the shining star of nuclear medicine of our society. He graduated from JSS Mysore. Can I have the CV, please, Hari? For the people who don't know Ranadhir, which is rare.
Uday, can you? Yeah.
So he's presently a professor and head Institute of Oncology at Hyderabad and consultant at Nuclear Medicine Advisor at Mallareddy Cancer Hospital in Hyderabad. Over to you, Ranadhir.
Hello.
Yeah,
Hello, Hari.
Can we start his video?
Yeah, 1 second.
Good afternoon, dear colleagues. I am Dr. Ranadhir, Professor of Nuclear Medicine, MNJ Institute of Oncology and Regional Cancer Center, Hyderabad. Thank you. First, at the onset, I thank Dr. Harishankar and the team for giving me this opportunity. Today, I am here to present my views on tyrosine kinase inhibitors in thyroid cancer. But due to paucity of time, I have restricted my topic to tyrosine kinase inhibitors in radioactive iodine refractory differentiated thyroid cancers. Prior to learn or take any topic for learning, we need 5 W's and 1 H. That is what, where, who, when, why, and how. In this present context, what are tyrosine kinase inhibitors? Where is the evidence in thyroid cancer? Who among thyroid cancer benefits from thyroid cancer tyrosine kinase inhibitors? When should TKIs be stopped or withhold? Why they fail? And how do you manage their side effects? So, as the disease process evolves and we are having good follow-up with the biochemical and availability of drugs, Now we are seeing around 20% of our practice, 10 to 20% of patients become radioiodine, active iodine refractory over due course of time. So let us know how they can be dealt with. And in radioactive iodine refractory disease, let us know their applications. What are tyrosine kinase inhibitors? Tyrosine kinases phosphorylate specific amino acids on substrate enzymes which alter signal transduction, leading to downstream changes in cellular biology. This constitutive action or inhibition lead to dysregulated signal cascades, leading to malignancy and other pathologies. Therefore, blocking these initial signals via tyrosine kinase inhibitors can prevent the aberrant action of the mutated or dysfunctional tyrosine kinases. So we are blocking tyrosine kinases using tyrosine kinase inhibitors. Tyrosine kinases are nothing but the enzymes which stimulate the signal transduction. So what are the common tyrosine kinase inhibitors in thyroid cancer which we can use? So if to know this, we should know the pathway. The two common pathways are RAS and phosphoinositol 3 kinase pathway. The RAS pathway stimulates RAF, that is rat sarcoma gene, stimulates rapidly activating fibrosarcoma gene, which further stimulates MEC and further stimulates ERK. ERK causes stimulates cell replication. And the other pathway is phosphoinositol 3 kinase pathway, stimulates ACT stimulates mammalian target of rapamycin, and which further stimulates cell division. These, however, RAS is activated by multiple agents. Those are VEGF predominantly, RET, MET, and HER2 and to some extent phosphoinositol 3 kinase. Phosphoinositol 3 kinase can be activated by HER2, IGFR, and RAS as well. RAS can activate phosphoinositol 3 kinase as well as phosphoinositol 3 kinase can activate RAS, but it is normally RAS which stimulates phosphoinositol 3 kinase. So by blocking the signaling pathway, either at the membrane level or intracellularly. At the membrane level, RET can be blocked by cabozantinib, vandatinib, ALK can be blocked by crizotinib, ceritinib, and many other things. VEGF can be blocked by sorafenib, lanreotide. HER2 nuclei can be blocked by lapatinib. And MEC and the coming to the downstream pathway, RAS can be blocked by tipifarnib, HRAS only. So in HRAS mutant, we can use tipifarnib. The results are yet to be out. RAF can be blocked by vemurafenib and dabrafenib, and MEC can be blocked by selumetinib. mTOR can be blocked by temsirolimus, everolimus. Once we are good with this pathway, then it is easy to understand all our drugs. So now the common tyrosine kinase inhibitors used in thyroid cancers are selumetinib, sorafenib, lenvatinib, and cabozantinib, and larotrectinib, presetinib. Let us go one by one. So mechanism of action of sorafenib and selumetinib. The VEGF stimulates RAS stimulates BRAF, BRAF stimulates MEC stimulates ERK blocks sodium iodide synthetase expression onto the membrane. Those sodium iodide synthetase gene and protein are amplified in the thyroid cancer cells. They are not expressed on the membrane. That's why they lose their ability to concentrate radioiodine. So the reason is ERK and mTOR both block NAS to be expressed on membrane to become membrane bound NAS. So this can be if we block these signals, then NAS can be expressed on membrane, making it radioiodine sensitive. The BRAF can be inhibited by dabrafenib, MEC can be inhibited by selumetinib, and pathway VEGF can be inhibited by sorafenib. So sorafenib and selumetinib, we have a lot. We have trials. So I am concentrating on sorafenib and selumetinib. And there is another pathway which is like our parents, which want have the same milieu to be maintained. So NAS to be expressed on membrane. That is Notch pathway. Notch pathway tries to keep NAS on membrane, whereas BRAF and phosphoinositol 3 kinase prevent that. So by stimulating Notch pathway, we tried, but it is of meager results. Now, so sorafenib is predominantly acting only on VEGF and to some extent on PDGFR, whereas lenvatinib not only acts on VEGF but also acts on RET and fibroblast growth factor, inhibiting the downstream pathway, thereby decreasing, preventing the cell proliferation. Cabozantinib not only acts on VEGF, RET, but also acts on MET and AXL and c-KIT and FLT3. All these, especially the MET and AXL, are the genes which cause lenvatinib resistance. So we are fighting lenvatinib resistance also with cabozantinib. And now we come to the newer class of drugs, tropomyosin receptor kinase inhibitors. That is NTRK gene fusion inhibitors, especially neurotropic variant of this tropomyosin receptor kinase is overexpressed in thyroid cancers. These NTRK, apart from NAS and phosphoinositol 3 kinase, the JAK and PLC also can be inhibited. So the alternate pathways which can be activated and create lenvatinib resistance can be blocked with tropomyosin receptor kinase inhibitors. Larotrectinib and entrectinib can be used in radioactive iodine refractory disease. And the other thing is RET. RET stimulates phosphoinositol 3 kinase pathway as well as KRAS pathway. This can be blocked by pralsetinib and selpercetinib. These are the newer class of drugs. I don't have any experience in using them, but I know the mechanism of action. They block both KRAS and phosphoinositol 3 kinase pathway. Where is the evidence? Selumetinib evidence is there since 2013. Selumetinib, what does it do? It's a MEK inhibitor. Given 75 milligrams twice a day for 4 weeks, can increase the iodine uptake of the tumors. It is used in low iodine expressing tumors as well as those who are not responding to iodine or those who are not concentrating iodine. Decision trial was used to treat, not only to make it them radiosensitive. Sorafenib was used in 400 milligram per day 400 milligram twice daily, and it showed improved progression-free survival compared to placebo. It was the phase 3 randomized trial in comparison with placebo, which had a 5.8 months overall progression-free survival. Sorafenib showed 10.8 months progression-free survival. So that had showed better results. But lenvatinib, which is a multi-kinase inhibitor, which not only inhibited VEGF but also inhibited PDGFR, RET, and KIT, showed further improvement in progression-free survival at 18.3 months versus 3.6 months compared to placebo. So lenvatinib had showed better results than sorafenib. But there was lenvatinib and sorafenib failures also. Then came the Cosmic 311 study, that is cabozantinib, which was used in radioactive iodine refractory who are resistant to sorafenib and lenvatinib or failed on sorafenib and lenvatinib. And it is not only inhibitor of VEGF2, but also AXL and MET, which are commonly called lenvatinib resistance. And this showed prolonged progression-free survival compared to placebo. And because there are not many options in thyroid cancer, so cabozantinib was taken as a very good option. And now it is indicated in patients who have failed to sorafenib and lenvatinib. So those are the studies, those are the trials. But does it make into the guidelines? Yes. NCCN shows, recent NCCN shows for progressive or systemic therapy who have failed on radioactive iodine, then lenvatinib is the preferred and followed by sorafenib. Cabozantinib can be used if it is the patient is progressing on lenvatinib and sorafenib. And larotrectinib or entrectinib in only patients with NTRK gene fusion positive products. Selpercatinib and pralsetinib, that is ARROW study, which was the reason for pralsetinib to be accepted for patients with red gene positive patients. ATA guidelines, which was framed in 2015, did not give much emphasis because at that time the use of lenvatinib was not that much, and those studies did not show improvement in overall survival. But still, in recommendation 96 shows kinase inhibitor therapy should be considered in radioactive iodine refractory thyroid differentiated thyroid cancer with metastatic, rapidly progressive, symptomatic or imminently threatening disease, not otherwise amenable to local control. Symptomatic disease not adequately addressable using directed therapy. And presently, a new indication that is in conjunct with radioiodine. There are few case reports, but one of my colleagues, Chandra, is doing lenvatinib plus radioiodine for aggressive thyroid cancer, especially in bone metastatic thyroid cancer, and seeing in 2 arms whether adding lenvatinib in low doses will it help in attaining over improved progression-free survival. Who among radioactive and refractory patients benefits from TKIs? Who among radioactive patients need early initiation, and who should not be subjected? Those who have metabolic progression compared those who have low, even into their structural progression is slow, but if their metabolic progression is faster, then initiating TKIs then has better results than with that of those who have already symptomatic. So growing with several months without symptoms, but there is a metabolic progression, then they are, if they target them, then they have better results. The genetic factors, BRAF, RET, and NRAS have a good product. This is only for lenvatinib, though have better predictor for lenvatinib response. HRAS mutated thyroid cancers have negative prediction and they do not respond. Pulmonary metastasis more than 1 centimeters, asymptomatic, good performance status, had good response. Liver and brain metastasis with bad performance status are negative predicted timing. Thyroglobulin timing fast. The rapid the thyroglobulin time, the good prediction for lenvatinib. And those with tumor burden less than 35 mm lesions had good response, and more than 7 centimeters lesions had bad response. Hypertension is not only a side effect but also partial. It's a effect. So if there is hypertension, that means the drug is acting. Treatment emergent diarrhea and hypertension can be seen that the patient is having effect from tyrosine kinase inhibitors. Who needs early initiation of TKIs? Those with increased risk of bleeding. If you have wait and watch upon initiation of measure TKIs, there may be increased risk of bleeding, especially those lesions near the carotid artery, skin, or mucosa of esophagus and bronchi. Those should be started early treatment. But if the lesions are not near, there is no chance of bleeding, then active surveillance can be taken care. Who should not be initiated on TKIs? TKIs cause VEGF receptor stimulation is needed for neovascularization, which is in having old healing. So anywhere there is recent bleeding or recent cerebrovascular, and TKIs can cause thrombosis. So bleeding disorders, thrombosis, thrombotic conditions, poorly controlled hypertension, prolonged QTC, all these are contraindicated. And when there is poor expected survival or untreated brain mets, then also the TKIs should not be given. When should TKIs be stopped? When should TKIs be interrupted? TKIs should be stopped when there is evidence of disease progression. TKI-induced prolongation in QTC, TKI-induced grade 3 proteinuria, or TKI-induced common toxicological criteria for adverse effects, grade 3 or grade 4 hepatotoxicity. When and how long should TKIs be interrupted? If the intolerable toxicities occur, say 8 days after starting TKI, then you interrupt for 7 days, again restart TKIs, continue for 7 days. Means 8th day the severe side effects came, so you only use 7 days, again interrupt for 7 days, again start and use for 7 days. If the disease progression occurs, then till the maximum tolerate, how many days you can tolerate that many days. If there are no toxicities, then but if the toxicities do not recover, you can give a drug holiday up to 14 days. Why do TKIs fail? Upregulated VEGF receptor expression mediates lenvatinib resistance, activating RAS, MEK, and ERK signaling, or alternate growth pathways, which I have already showed, but it cannot be covered in a single slide. These are the two reasons for failing of TKIs. How do you manage side effects? For to know how to manage, you should know the side effects first. The side effects of TKIs are hypertension, diarrhea, fatigue, hand-foot syndrome, prolonged QTC, thrombosis, MI, proteinuria, and hepatotoxicity. Mechanism of hypertension in TKIs, decreased nitric oxide production leading to capillary rarefaction that will lead to rise in BP. Effect on lenvatinib on glomerulus, decreases glomerular filtration barrier leading to proteinuria and decreased GFR. Hypertension, frequent blood pressure monitoring most critical, and AC and calcium channel blockers can be used, but there is no specific guideline as of now, but they are better. Diarrhea, if 1 to 2, grade 1 to 2, loperamide is the drug of choice. If grade 3 or 4, apart from loperamide, with all TKI, still the side effects regress to 1, and intravenous fluids. Cutaneous or mucocutaneous toxicities, if grade 1 or 2, topical treatment, grade 3 or 4, local plus oral antibiotic, especially tetracycline, and sometimes methylprednisolone, and with drug interruption till regression to grade 1. Hand-foot skin reaction, 10% urea cream can be tried. Cardiotoxicity, if the QTC is prolonged more than 488 milliseconds, it can happen during therapy also, not only at the onset. If there is a QTC prolongation, it can happen after 4 weeks, 8 weeks, 12 weeks. Sudden MI, sudden death, cardiac death can be because of this. So you should always have, whenever the patient comes for the follow-ups, you should have ECG. And echo is recommended when there is congestive heart failure or coronary artery disease or whenever the clinically indicated. Hepatotoxicity, dose reduction is required in hepatotoxicity. Nephrotoxicity, proteinuria, treatment of proteinuria in TKI-induced proteinuria is a complicated thing, and withdrawal, after withdrawal also there can be persistence. A reduction of ARBs and ACEs inhibitors can be used, but always if grade 1, grade 2 proteinuria, if there is it's okay, but if there is edema, hyperlipidemia or hypercoagulability, TKI should be stopped. Now comes the other T for teachers, that is MCQs for testing. We need to test whether the students have understood or not. So decision study or trial proved that sorafenib in comparison to placebo had improved overall survival, but no difference in PFS. Lenvatinib showed improved PFS, but no difference in overall survival. Sorafenib in comparison to placebo had improved PFS, but no difference in overall survival. Lenvatinib in comparison to placebo had improved PFS, but no difference in overall survival. So if you would have gone through the talk, easily you can answer this. Lerotrectinib is useful in among the options, red fusion product positive well differentiated thyroid cancer, or NTRK gene fusion positive well differentiated thyroid cancer, or VEGF expression well differentiated thyroid cancer, or ALK expressing well differentiated thyroid cancer. Which is the common side effect of TKI, which is not the common side effect of TKIs: hand, foot, mouth reaction, hepatotoxicity, diarrhea, or neurotoxicity. Drug of choice for TKI-induced hypertension, beta blockers, ARBs, CCBs, no specific guidelines, but CCB is preferred. Which genes cause VEGF receptor resistance? RET, ALK, AXL, HER2. So I'll give the answers after the class. Any doubts? You can ask. Thank you.
Thank you, Ranadir, for the wonderful presentation as usual. Any questions?
Dr. Balaji, sir? Sir, please unmute yourself.
Sorry. For most of these patients, they are already to be exposed on high doses thyroxine for quite some time. Yes? These patients who progress on thyroid cancers.
Yes, sir.
They will be having a suppressed TSH for quite some time. Would they really be able to tolerate all these agents clinically?
Yes, sir. We have our experience of 13 to 14 patients of lenvatinib and 40 to 50 patients of sorafenib. They will not tolerate at the textbook doses of 400 milligram BD, but we titrate them. We give 400 milligrams OD or 200 milligrams BD, and lenvatinib. Those who are not tolerating 24 milligram, most of them don't tolerate 24 milligram. They will be given a 10 milligram OD, sir. So there are two approaches: step down and step up. We use step down approach. When they can't tolerate 24, we decrease to 14, then to 10. And if they can't tolerate 10 also, then we explain other options, sir. So sorafenib, they tolerate 200 milligrams. BD, they are tolerating, sir.
And your experience with redifferentiation, sometimes they say they make them more radio sensitive. Have you ever encountered such cases who are initially radioiodine resistant? After these things, they redifferentiate and then become radio sensitive again. Have you radioiodine sensitive again? Have you actually encountered such cases, sir? Or?
See, there are 3-4 causes for this thing, sir. That is, we are restoring the notch pathway, but we limited results, sir. In our clinical experience, we have given around 30 to 40 patients of valproic acid, and who are followed. 3 to 4 patients regained. Whether we will falsely negative at the initial study because we did not give an empirical dose at the initial thing. So, or really valproic acid has helped. But definitely those patients who received valproate had slower progression compared to those who did not receive valproate. But this has to be done in a larger studies. And more structured trial has to happen, sir. and we did not have any experience with selumetinib because it was costly and patients could not afford procuring selumetinib. So we had experience with valproic acid, and we also tried retinoic acid. Retinoic acid patients could not tolerate. So we stopped. There was a lot of mucositis. So retinoic acid we did not, patients did not tolerate. Valproic acid we tried in number of patients. They tolerated. There was no issue of tolerability only. All patients who received valproic acid had minimal side effects. So but the efficacy point of view, 3 patients became iodine sensitive. But that is my experience, sir. There are larger meta-analysis has to be done, and larger randomized control trials have to be done.
Okay.
Selumetinib is also single center experience, sir.
Thank you.
Thank you, sir.
So we'll move on to the next presentation.
Dr. Balaji, can you introduce the speaker if you don't mind?
Yeah, it's a great pleasure to introduce Dr. Suganya. She's a consultant breast and endocrine surgeon who's done her DNB in general surgery and has completed her MCH from endocrine surgery in CMC Vellore. She's a specialist in breast conservative surgery. Over to Dr. Suganya, please.
Good morning, everyone. I'm Dr. Suganya from Velamal Hospital, Madurai, consultant endocrine and breast surgeon. I'm happy to be among you all in this wonderful meeting. I'm thankful to Dr. Harishankar for giving me this opportunity. Now I'm going to discuss with you about the surgeon's perspective in the endocrine section. The organs which we are dealing are thyroid, parathyroid, adrenals, neuroendocrine tumors, and the breast. Among the thyroid diseases, we require nuclear medicine help in cases of hyperthyroidism, carcinoma thyroid, and ectopic tissue, to find any ectopic tissue is there. In cases of hyperthyroidism with nodules in both the lobes, with a large toxic multinodular goiter, we control the toxicity and subject the patient for surgery. So in those cases, we may not require the iodine scan, but patients with large grades also, here also we control patient and take them for surgery as they may not require therapy for huge gland. But for small diffuse gland with hyperthyroidism, we would like to differentiate it from thyroiditis, because in case of thyroiditis, our treatment is different compared to the grades, where in thyroiditis, we have to explain the diagnosis and also the prognosis of the patient, as the patient may continue hyperthyroid drug for some time and later will be switching on them to hypothyroidism drugs. But in case of grades, where patients will be continuing hyperthyroid drugs for some time, and later if they are resistant or having contraindications, then we may subject them for iodine therapy. To me, mostly for glands which are smaller, I prefer, which are resistant to medical therapy, I prefer them iodine therapy, as they have no major morbidity. In patients with carcinoma thyroid, carcinoma thyroid, we debulk, that is, we remove the thyroid gland or the nodes entirely, and the patient will be completing treatment only after giving the iodine therapy. In these scenarios, we will be encountering remnant tissue in the scan or presence of nodes or presence of metastatic foci or elevated thyroglobulin with negative scan. These are all the scenarios we will be encountering. In cases of remnant tissue, do we really need to ablate the remnant tissue, which may be the normal thyroid tissue? So, to consider these, the American Thyroid Association, they have given recommendations that In case of papillary thyroid carcinomas, a well-differentiated thyroid carcinomas, which have a great prognosis, patients are having near normal life expectancies. There are options to not even do total thyroidectomy and subject them for lifelong supplementations, or they may have some complications and morbidity due to that. To avoid those scenarios, patients can be given options of endotheliectomy. We are also having patients who have been done endotheliectomy and are on follow-up, provided those patients should have consistent follow-up, to be willing to follow under you regularly. These patients, we can follow up with regular ultrasound, and if needed, we can proceed with completion thyroidectomy and later with iron therapy. There are also studies coming up where they are only following those thyroid carcinomas well differentiated with no extrathyroidal extension, with no lymph nodal spread. Patients are of younger age group, those are the low risk category. They are only subjecting them for follow-up and not even doing surgery. So those are all the cases in carcinoma thyroid because of its very good prognosis. So among those patients whom they have followed, they found that less than 5% only has required surgery for in a period of 15 years when they have developed new nodules or when it was growing up and they had a new lymph nodes, are not willing for full follow-up. Those patients were subject to surgery. Can we avoid altogether this remnant? Is that now let's see, this is a head end of the patient, the thyroid lobe we are holding. This is the area of the Peris ligament. This is the area where the nodule lower end is in close proximity to the recurrent laryngeal nerve, which is pointed by the artery clip. Sometimes the recurrent laryngeal nerve can go very close to the nodule, wherein to preserve the nerve, we'll be leaving some tissues in the Peris ligament, which is the remnant. So those tissues sometimes are unavoidable to completely, we cannot remove it, so we are leaving it. Next, coming to the nodes. Nodes, according to ATA, they come into the intermediate risk category. So patients having spread to the nodes, their thyroid cancer having spread to the nodes will have intermediate risk of recurrence. That is, a risk of recurrence is a little more higher. Those patients, there are options because of the risk of recurrence. There were practices of doing prophylactic central neck dissections. But the problem with prophylactic central neck dissection is the consideration of the parathyroid injury, where the lower parathyroids are more viable to injury while doing central compartment neck dissection, causing permanent hypoparathyroidism, where patient is have to take calcium supplement lifelong. So to avoid in those patients, those complications, we are following not prophylactic central neck dissection, we are doing central neck dissection for those patients who have nodes in their preoperative ultrasound or during surgery. If we encounter nodes during surgery for papillary carcinoma or well-differentiated carcinoma thyroid, during dissection, if we have suspicious nodes, if we feel nodes in the region, in the central compartment region, we are proceeding with central compartment neck dissection. And also central compartment neck dissection comes as a part of lateral neck dissection. So in those cases, we are doing central compartment neck dissection. The problem with these nodes are when we are removing nodes, central or lateral nodes together with the fatty tissue. So those which we are seeing, but there are about 300 nodes in the neck, which can pop up later in the disease when even though you have removed everything entirely, all the nodes, whatever you are seeing, they can pop up during the period of follow-up and give trouble in case of elevated thyroglobulin, which cannot be avoided as process of the disease. So in those cases who have elevated thyroglobulin but negative scan, as they may not be picked up in the iodine scan, we are giving empirical therapy for some patients. In cases of metastasis, surgery, the value of surgery is less, where the patient's sole treatment is in the iodine therapy. The value of surgery is only to remove whatever is possible for us. We'll be doing total thyroidectomy of nodes are that we are doing nodal dissection. But for patients who have bony metastasis, single region metastasis, we are even resecting the metastatic mass and then subjecting to iodine therapy. I wanted to share a story of a patient in Gujarat known to me, contacted me for an opinion. It is a 67-year-old female, hemithyroidectomy done for solitary nodular thyroid. The patient had a follicular variant of papillary thyroid carcinoma and histopathology. Later, in PET scan, they found the patient unfortunately had metastasis in the liver, in the pelvic bones, but she was asymptomatic for it. They have done completion thyroidectomy to facilitate further iodine therapy, but to their surprise, the thyroid stimulating hormone was not raising even though 1 month after stopping the thyroxine or any iodine supplements, iodine drug, food materials. But the reason for this non-raising TSH is because of the metastasis. The metastasis are secreting thyroxine, and those are the reason for non-raising TSH. What else? What else can cause increasing non-raising TSH are sometimes in patients may have thyrothymic rests, which were disconnected from the thyroid gland, so they are overseen. They are not seen during surgery or in the previous images when we are doing only ultrasound of the neck, proceeding with oral thyroidectomy and MRND. When thyrothymic rests are missed later, they may also cause normal TSH. So in those cases, we have to go in back and again remove the thyrothymic rest and then subject them for iodine therapy. Next, coming to the parathyroid gland, hyperparathyroidism is a diagnosis by biochemistry. There are primary, secondary, and tertiary hyperparathyroidism. Our concern is primary hyperparathyroidism, where the gold standard in previous era was traditional bilateral cervical exploration. This is the gold standard as we see with the rise all the 4 parathyroids and remove it whichever is enlarged. So we are confident that there are no diseases in the other parathyroid glands. But by the advent of newer images, by the advent of SNMI, we were able to do minimally invasive parathyroidectomy, that is focused parathyroidectomy with a very small incision and with a local anesthesia. Patient go as a daycare procedure, patient discharged on the same day. Their morbidity is much less. This is possible only with the advent of 4DCT and also SNMI. So there is paradigm shift in the management of those cases. We'll be doing ultrasound. This is a nodule. This is not in the thyroid. This is a parathyroid, which is hypoechoic. So in areas where we are not having SNMI, we may replace it with 4-dimensional CT. The 4th dimension is the time where arterial phase delayed images are compared and differentiated. Parathyroid is differentiated from the nodes and also from the thyroid nodules. In SNMI, what do we expect? We expect, and we are very happy to see a light bulb. We love to see a light bulb parathyroid. This management is very simple, removing that and curing the patient. But there are scenarios where you have all 4 parathyroid enlarged or a nodule intervening, or you may have a double adenoma. In case of hyperplasias, patients may have vitamin D deficiency, osteoporosis leading to secondary hyperplasia. When that is ruled out by biochemistry and you are having a primary hyperplasias, we will follow the traditional bilateral cervical exploration, do the surgery, remove the 4 parathyroids, or also in case of thyroid nodule complicating with the parathyroid, we resort to intraoperative PTH monitoring and frozen section to see whether we are curing the patient, whether we are completely removing the disease. But in case of double adenoma, when you remove the adenoma and patient presents with the persistent hyperparathyroidism, they may present, but this is avoided by SNMI, where it is more sensitive enough to pick up the double adenoma and help us in curing the patient. This is a picture of the parathyroid, which is huge compared to the thyroid. And this is a 40-gram enlarged parathyroid adenoma. From 40 milligram, which is a small size, it is enlarged to 40 grams. In SPECT, we will be more happier to combine CT with SNMI because, see, in cases of like this, an adenoma, we'll be wondering whether this is a descended superior gland or an inferior gland. What is the difference with us? With us, the difference is you go anteriorly, check everywhere and find an inferior gland which is anterior. But when you see the images here, when it is close to the esophagus, and we are sure that it is descended superior. So we'll be more venturing, even though we are not finding the place where we were about to, we will go beyond, dissect more and search in the posterior region, even beyond the retroesophageal region to find out the gland. So in such a way, it helps us to go deeper into our dissection and helps us to retrieve the gland. In case of adrenal tumors, we use MIBG for pheochromocytomas, which are larger, which are metastasized, for further therapy when they have persistent elevation of metanephrines. In case of medullary CA thyroid, even after surgery when they are hypercalcitonemia, we resort to MIBG therapy if they are positive, if they are picking up. With the advent of somatostatin receptor PETs, in tumors like medullary carcinomas, pheochromocytomas, paragangliomas, carotid body tumors, and all the NETs. In these cases, when we are wondering, it is not evidence in CT and MRI, we are wondering, we are searching for the disease, these PET scans are of immense help to us, where they help us in finding smaller lesion and multiple lesion or even for therapy. Last but not the least, where we are seeing handling major cases are the breast. We do sentinel node biopsies to avoid lymphedema, which is a major morbidity in cases. We do breast surgeries. Sentinel node biopsy with an isolated blue dye technique may have false pickup rate. That is, some of the cases may be missed. So in those cases, we always like to combine them with radiolobal colloid, which increases the sensitivity and helps us to take sentinel node and avoid lymph node dissection. Thank you. Thanks a lot.
Thank you, ma'am. Any comments from the chat?
I think, Hari, we are running behind schedule, isn't it?
Yes, sir. Yes. So we can, thank you, ma'am. We'll move to the next session, next talk then.
The next speaker is Dr. Vignesh, a consultant endocrinologist from Dr. Vignesh Endocrine and Diabetes Center, Trichy. Also an executive committee member of AP at Trichy chapter. Over to you, Dr. Vignesh.
Good afternoon, everyone. At the outset, I would like to thank the organizers, Society of Nuclear Medicine, Southern Chapter, for having given me this opportunity. For next 10 minutes, I shall be discussing about thyroxine replacement after thyroidectomy. So this will be my agenda. So I shall be discussing about thyroxine replacement and how to monitor thyroid function test on oil on replacement and TSH suppressant therapy for disease. So to begin with, oral thyroxine, that is T4, is nothing but thyroxine. When consumed orally, 80% of which is absorbed from the upper jejunum and upper ileum. And this absorption is dependent on the gastric pH, that is acidic pH. So when somebody consumes food or consumes proton pump inhibitor, the absorption will be impaired. And absorption may be less than 50% in such scenarios. And 99% of the observed thyroid hormones are bound to the plasma proteins, especially thyroxine binding globulin, transthyretin, and albumin. Only 1% of free hormones are metabolically active. So there are certain things we need to keep in mind while we start thyroxine therapy for patients. Thyroxine has to be taken in the empty stomach and in the fasting state, and the patient has to be remain in the empty stomach for next 30 to 60 minutes. They are not allowed to consume anything except for water. And we all know thyroxine has a long half-life of 7 days. So the textbook says if sometimes a patient forgets to take a medicine on a particular day, they can consume 2 tablets the next day. Generally, we don't try this in common practice because patients tend to do that routinely more often. And guidelines say there is no need to restrict any vegetables or any specific diet will help them in bringing down the TSH levels. So as thought previously, there is no need to restrict cruciferous vegetables like cabbage, cauliflower, broccoli in the diet. There are various other preparations available in the pharmaceutical companies. So like T3 preparations, leothyronine, or a combination of T3, T4 are generally not preferred or recommended because it can cause unphysiological rise in the T3 levels, which can cause adverse cardiovascular effects. And desiccated thyroid preparation like beef or bovine thyroid extract, again, it is not bioequivalent to thyroxine, so it is not recommended by any guidelines. So before, in the old school of that, we were taught during our UG college days by professors like for a supplement for hypothyroidism, start with 100 microgram. For substitution, for after thyroidectomy, start with 200 microgram of thyroxine. For suppression therapy for thyroid carcinoma, start with 300 microgram. This is a very crude way of titrating, replacing the thyroxine. So it is not followed these days. So when we start thyroxine replacement, we have 3 goals. One is resolution of patient symptoms, normalization of TSH levels, and third is to avoid the overtreat, that is iatrogenic thyrotoxicosis. So empirical dose of thyroxine after thyroidectomy for a benign indication like multinormal goiter or Graves' disease is usually 1.6 microgram per kilogram. Approximately, nearly most of the patients will require dosage adjustments on follow-up. In such case, the target TSH would be for young adults will be like 0.5 to 3 milli-international units per liter. For elderly, they will be given a little linear target, like somewhere between 4 to 6 international units per liter. There are various factors that decide the dose of thyroxine. Most important is the body weight. So higher the body weight, higher the dose of thyroxine. And pregnancy, they require a higher dose of thyroxine. And age, and last 3 factors, age, higher the age, we'll start with the lower possible dose. Patients with poor cardiac reserve, they'll start with the lower cardiac dose, lower dose of thyroxine. There are various formulas to calculate the exact dose of thyroxine, which include weight-based formula, BMI-based formula, or weight, age, and BMI-based formula, or body surface-based formula, but it is cumbersome to use in regular clinical practice. Generally, we go by common rule of thumb, like for adults, we start with 1.6 microgram per kilogram, and children and adolescents, they require a higher dose compared to the adult. Elderly, we start with a lower dose and gradually update it over a period of weeks. This is a rough estimate for a 60 kilogram male who underwent a total thyroidectomy. So they require a 150 to 100 to 150 microgram. Those who underwent subtotal thyroidectomy, they require a lesser dosage. So if we were to initiate thyroxine for overt hypothyroidism, that is nothing but low T4 and high TSH. So for a young healthy adult, start with a full replacement, that is 1.6 microgram per kilogram. For elderly or those with poor cardiac reserve, start with the lower dose like 25 to 50 microgram per kilogram and gradually update it over weeks. While monitoring the thyroid function test on follow-up, the TSH is the most important and sensitive parameter. And this TSH value is not affected by food or thyroxine tablet taken on the day of testing. So this TSH can be done at any point of day. No need for fasting. And generally, we don't need a free T4 for monitoring, but many times it is combined with the we always ask for free T4 and TSH, because if the TSH value is extremely low or extremely high, then we may like to see the free T4 values. Suppose if you want to draw blood for a free T4, it has to be done in the empty stomach, because thyroxine taken on the day of testing will increase the free T4 for next 4 to 6 hours. So it has to be done before the thyroxine dose. So once we start the treatment for a patient, always recheck the TSH after 4 to 6 weeks, not too early, because it will take 1 or 2 months for the TSH to get normalized slowly. And follow 6 to 12 monthly as directed by the guidelines. And free T3 measurement is not generally required. And coming to the brands, there are various brands of thyroxine available, and not all the brands are don't have equal bioequivalence. Means every different brand will have some different plus or minus dosages of thyroxine. So it is generally not advisable to change the brands, especially for pediatric and pregnancy patients. This is a classical case. I just want to show an example. A multinodular goiter, 50 female with MNG, post-thyroidectomy on full dose replacement, 150 microgram per kilogram, compliance good. Non-fasting thyroid function test. See, TSH is normal. It is within the desired level. But see, when you see the free T4, it is higher than the reference range. Means the patient has consumed thyroxine in the morning on the day of testing, so it raises the free T4. Since the TSH is in the desired range, no need to change the thyroxine dose for this patient. Continue the changes. Suppose if we reduce the thyroxine dose for this patient, then we'll be under treating them, and next follow-up TSH will become high. There are various factors affecting the TSH absorption. Malabsorption or any celiac disease or tropical sprue can affect the absorption of thyroxine, or a chronic atrophic gastritis or pernicious anemia can decrease absorption. Various drugs, most importantly proton inhibitor, decreases the acidic pH of the stomach and decreases the absorption of thyroxine. And iron and calcium will decrease the intestinal absorption of thyroxine. There are various other preparations like liquid preparations of thyroxine, soft gel preparation of thyroxine. At this point of time, most of the guidelines recommend against using liquid preparation of thyroxine for replacement. But nowadays, there are new studies are coming up saying that liquid preparation have equal bioequivalence, equal distribution of drugs throughout the solution. So it is easier for absorption, and its absorption is quicker than the tablet, and it can be administered without need for fasting, and it is useful in malabsorption. But at this point of time, we have studies to say the liquid formulation is equally good as oral tablet. But till now, there are guidelines advice against using liquid formulation. Coming to thyroxine suppression therapy. Differentiated thyroid carcinoma expresses TSH receptor on the cell membrane. So TSH stimulation leads to increased expression of cell-specific proteins and cell growth. So generally, we do TSH suppression by giving supraphysiological dose of thyroxine in thyroid cancer. This is to prevent the risk of recurrence. And TSH suppression therapy is not without side effects. It can cause thyroid toxicosis, it can cause adverse cardiac effects, it can cause osteoporosis or osteopenia in elderly, and it can lead to weight loss, anxiety, and so many CNS effects. So we need to have a dynamic risk stratification. So differentiated thyroid carcinoma, generally we classify as low risk, intermediate risk, and high risk at initiation, and follow after 1 or 2 years of therapy. Based on their response to therapy, we need to reclassify the risk and change the therapy according to that. So as per American thyroid guidelines, so when we classify the risk into low, intermediate, and high, our desired target TSH will be 0.5 to 2.0 for a low risk of recurrence, low risk group, and it is 0.1 to 0.5 for intermediate risk group, and for high risk group, the TSH is to be suppressed to the extent of undetectable. So after a period of 1 to 2 years of therapy, we need to assess the response to therapy. Based on that, we classify them as excellent response or biochemically incomplete response or structurally incomplete response or indeterminate response. So based on the response to therapy, our TSS targets has to be individualized. So if there is an excellent response and there is a low risk, very low risk of recurrence, the TSS targets can be somewhat less stringent, like 0.5 to 2. If there is an indeterminate response or biochemically incomplete response where there is a rising TG or ATG, our target would be 0.1 to 0.5. If there is a structural incomplete response, that is a recurrence of disease, we need to suppress the TSS to undetectable levels. So all these are based on this study, National Cancer Study Registry Analysis. So where they studied nearly 5,000 patients over a period of 6 years longitudinally, like stage 1, stage 2, and stage 3, stage 4. In stage 1 patients, TSH suppression, it is not proven to be beneficial. So there is no recurrence even in the unsuppressed group. In stage 2, overall survival is improved when the TSH was suppressed to subnormal levels, but there is no incremental benefit when the TSH is suppressed to undetectable levels. In stage 3 and stage 4 disease, the overall survival is improved when the TSH is suppressed to undetectable disease. But the TSH suppressor targets has also to be individualized based on the other risk factors, especially age. Elderly age, history of osteoporosis or atrial fibrillation, they have to be a little less stringent target to avoid the risk of complications. So while we start the patient on thyroxine replacement therapy, so there are certain other factors that causes unsuppressed TSH. That is most common component in our setting is a lack of compliance. The patient often skips the medicine or forgets to take the medicine while they go out of station. This is a very common scenario we see in day-to-day practice. The other things, change of formulation. Already we discussed different bands have different bioequivalents. And dosing errors, the patient may be consuming the old dose or changes in the body weight. So increase in body weight, they require more dose. Probably it leads to increased TSH. And other interfering drugs can lead to increased TSH. So in summarizing, TSH is the most important and sensitive parameter in monitoring the thyroxine replacement therapy after a thyroid surgery. And sampling for TSH, it can be done in the non-fasting state. It can be done at any point of time, unlike T4 sampling. And for TSH suppression therapy, always use a dynamic stratification for TSH targets. And TSH suppression therapy targets should be individualized based on the risk versus benefits ratio. Thank you for your patient hearing. I'd like to thank the Society of Nuclear Medicine for having given this opportunity. I'd like to take the question from the audience.
Thank you, sir. Dr. Vignesh, sir, will be joining our endocrine panel discussion, so we can have the questions together, the panel discussion. Yeah. At the outset, I'd like to thank the chairpersons, Dr. Parameswaran sir and Dr. Balaji sir, for chairing this session. Before we move on to the next endocrine part 2, we'll have one quiz question. So this is the quiz question number 8. Quiz question number 7, the right answer was single functioning kidney with hydroureter. The correct answer was given by Mr. Vigneshwaran. So again, the answer to the quiz has to be given through the quiz link, the right lower corner. Kindly remember the correct option to answer. So this is the history. This is a patient of carcinoma of prostate. A PSMA PET scan has been done for a staging workup. This is the PET scan image. These are the fused PET CT findings. I'll show the images again, video again. I know this is little difficult case. We can please look at the images very carefully. The options are, what is the PSMA PET staging? Option A, it is T1, N1, M0. Option B, it is T2A N1M0. Option C, it is T2B N1M0. And option D, it is T2C N1M0. I can show you the images once again. These are the images. This is the section at the level of prostate. This section at the level of little below the pelvic bridge. Okay, we move on to the next session. This is endocrine part 2. For this, I'd like to invite Dr. Anand Kumar Annamalai sir, who is a physician and endocrinologist practicing in Madurai, Ashwini Hospital. And along with him will be Dr. Arun Sasikumar, nuclear medicine physician from Kerala. Over to the chairpersons.
Thank you, Dr. Hari. It has been a scintillating session till now. So continuing the tempo, without wasting much time, we will move on to the penultimate session of the day. There are 2 talks scheduled back to back. So for the first talk, Gallium in endocrinology, we have Dr. Julie. Requires no introduction among the nuclear medicine fraternity. She is a professor at CMC, Vellore. Now over to you, ma'am, for the talk.
Good evening, everyone. And at the outset, I would like to thank the organizers of the Southern Chapter of Society of Nuclear Medicine of India for giving me this opportunity. I will be talking on gallium in endocrine diseases. And I will not be touching on neuroendocrine tumors and also on the gastroenteropancreatic tumors, which has been done by other speakers. So the outline of my talk is I'll be talking on a bit on pituitary tumors, thyroid malignancies, few and paraganglioma, and also tumor-induced osteomalacia. To brush up the basics, we know gallium is produced from the germanium-68 generator, and the most commonest radiopharmaceutical of gallium-68 is gallium dotatate, which is 1,4,7,10 tetraazocyclododecane 1,4,7,10 tetraacetic acid octreottate. Quite a tongue twister. Gallium is the daughter product of germanium-68. Gallium has a half-life of 68 minutes, and it further decays into stable zinc-68. The normal gallium-68 dotatate uptake is as follows. There is a physiological low uptake in the pituitary, thyroid, and the breast. Accumulation is also seen in liver, spleen, kidneys, and the bladder. This imaging is also used to select patients likely to receive PRRT, and its positivity suggests that it's a good prognostic marker of neuroendocrine nature of a tumor. There are false positives, especially in areas of inflammation or infection containing activated lymphocytes and macrophages, such as in radiation pneumonitis, gastritis, sequelae of recent surgeries, reactive lymphadenopathy, and granulomatous lesion. In non-neuroendocrine neoplasia-related sources of uptake include accessory spleens or splenuncules, which could be erroneously interpreted as lymph nodes. The false negatives are commonly related to lesion size, as a spatial resolution is about less than 7 mm. And if patient has had recent analog therapy, although this issue is debated. Alteration of receptor expression by recent chemotherapy or truly receptor negative disease, which is like high-grade neuroendocrine neoplasias, can be false negative. The most frequently used modifications of octreotide are tyrosine 3 octreotide, tyrosine 3 octreottate, and sodium iodide octreotide. When combined with the DOTA chelator and gallium-68, they are called DOTA-TOC, DOTA-TATE, and DOTA-NOC. DOTA-TOC has very high binding for somatostatin receptor 2, which is the most commonly expressed receptors in tumors. And in DOTA-NOC, it binds also to somatostatin receptor 5 with intermediate affinity and 2. In DOTA-NOC, it has high affinity for receptor 2, 3, and 5. What about the somatostatin antagonist? This has been explored as a potential gallium-68 agent. Although antagonists fail to induce somatostatin receptor 2 internalization, they have been shown to label a higher number of receptors than agonists in vitro assays and have shown higher tumor accumulation in vivo. The most commonly studied somatostatin antagonist is gallium-68 no-DAGA. Coming to the utility of gallium dotatate in pituitary pathology, it's useful in suspected recurrent Cushing's disease following previous surgical resection and ACTH-dependent Cushing's syndrome secondary to suspected ectopic ACTH production, recurrent central hyperthyroidism, recurrent prolactinomas. The latter two is not much studied. However, the absence of dotatate ability in the pituitary fossa is useful in excluding pituitary disease in recurrent Cushing's. Cushing syndrome, as we all know, is due to inappropriate and excess production of cortisol. It may arise due to excessive ACTH production from the pituitary gland or ACTH or corticotropin releasing hormone secretion from an extra pituitary source or autonomous cortisol secretion from adrenal glands. Gallium-68 cortisol CRH PET CT is based on the binding of 68 gallium CRH2 CRH1 receptors on corticotropinoma, which are upregulated as compared with the surrounding corticotroph. And this seems to be a promising radiopharmaceutical for gallium. This is from this journal. This is an image of a 31-year-old male with recurrence of Cushing's disease 7 years after successful transsphenoidal surgery for macroadenoma. The coronal T2 weighted and GADO enhanced T1 weighted images show post-operative changes. However, gallium-68 CRH PET fused with MRI, SELA shows focal uptake in the right half of the pituitary, which is suggestive of corticotropinoma. In ectopic ACTH producing tumor, I would like to show you a case of a 44-year-old male who had been diagnosed with ectopic ACTH dependent Cushing syndrome. He had a bilateral adrenalectomy in 2007. Symptoms were persistent and he had high ACTH, serum ACTH was significantly elevated, and a dotatate scan was done which showed a lesion in the right bronchus, and he had excision, right middle lobectomy, and the resection showed the biopsy was shown as reported as typical bronchial carcinoid with an MIB index of 1.5%. Prior to surgery, his ACTH was more than 25,000 and it has significantly come down. This patient was also subjected to PRRT. Coming to thyroid, in differentiated thyroid cancers, gallium DOTA is a promising tool in patients with TENIS, that is thyroglobulin elevated, normal or negative iodine scan. This dotatate should be considered especially in poorly differentiated and oxyphilic subtypes of DTC if FDG PET-CT fails to localize the tumor relapse. An example of a patient who was diagnosed with oxyphilic thyroid carcinoma presented with TENIS, and this is an iron 124 PET-CT negative and an FDG negative, and a dotatate imaging showed a lesion in the right side of the neck. The patient did not have any treatment, came for follow-up after 15 months, and it showed the lesion localized to the neck and it had progressed in size. Another image showing a flip-flop mechanism wherein the gallium DOTA lesions, DOTA scan shows significant skeletal uptake, whereas PET, the FDG PET shows no uptake, and where the lung lesions were more intense on FDG PET rather than on DOTA PET. Another tracer called gallium-68 RGD. This is the tumor vasculature and several tumor cells express alpha V beta-3 integrin. The angiogenic markers such as arginine, glycine, aspartate, RGD peptide are better suited for their detection. Gallium DOTA RGD2 PET-CT is more specific for tumor-related neovascularization, and it has been useful in patients with TENIS. This is a image of a patient who has been diagnosed with insular variant of papillary thyroid carcinoma with TENIS. And this image of gallium-68 DOTA RGD shows uptake in the neck and also in the thorax. The authors of this paper have also proved that the specificity and the positive predictive value is almost 100% for DOTA RGD in thyroid malignancies for tennis, and the negative predictive value and accuracy is significantly higher than the FDG PET. Coming to medullary carcinoma thyroid, the sensitivity and accuracy of DOTA-TATE is about 100% and 93%, and the detection rate of somatostatin receptor increased in patients with higher serum calcitonin levels. Although DOTA-TATE PET-CT is not an optimal whole body imaging technique as a single imaging modality in patients with MTC, it detects 100% for bone mets, and it was found to be superior to bone scan that identified 44% of osseous lesions. This is an image showing mechanisms of uptake and localization of different radiopharmaceuticals which can be used for medullary thyroid cancer. But this is beyond the scope of the topic that has been given to me. And I want to also say that F-DOPA is the imaging of choice for medullary thyroid carcinomas. A patient who was diagnosed with medullary thyroid carcinoma had undergone an MIBG scan, and his calcitonin was significantly rising in spite of MIBG therapy. The patient underwent gallium-68 DOTA-TATE, and we found that he had extensive skeletal metastasis, which was not picked up on an MIBG scan at all. In pheos and paragangliomas, pheochromocytoma, as we know, is a rare neoplasm, and it originates from the neural crest, arises from the chromaffin cells of adrenal gland medulla in 90%. It can also be located in extra-adrenal chromaffin tissue in 10%, in particular from sympathetic nervous system ganglia, which is referred to as paragangliomas. So what is the role of molecular imaging in pheo and paraganglioma? It's useful in the diagnosis, especially when metanephrine levels are borderline, and also helpful in identification of tumor multiplicity and metastasis with certain genotypes such as in SDH, B, A, D, or MAX, succinate dehydrogenase mutations, and assessment of potential future aggressive behavior and detection of therapeutic molecular targets. The first line choice of radiopharmaceutical according to mutational status, as I have depicted here, is mostly F-DOPA, but in the succinate dehydrogenase mutations, DOTA-TATE is the first line imaging choice. So how does it fare in terms of comparison of different radiopharmaceuticals? So DOTA-TATE has a specificity, gallium-68 DOTA-TATE has a specificity of 90%, sensitivity in sporadic cases of 98%, and sensitivity in mutational, especially in the succinate dehydrogenase mutation, is about 99%. Patient who was diagnosed with pheochromocytoma and the CBT, there's a MIBG scan which is showing a right adrenal pheo, had an adrenalectomy, and patient was doing well for some years, and he had recurrence of symptoms, and then DOTA scan was done, which showed a carotid body tumor. Patient was subjected to PRRT. This patient also had a mutation in the SDHD gene. So in metastatic SDHB related paragangliomas, we see in, these are the images, that is DOTA, FDG, FDA, and F-DOPA. So you can see the DOTA-TATE and FDG identified similar number of lesions, and it performs superior than the FDA, that is fluorodopamine and F-DOPA. And the localization of skeletal mets is similar on DOTA-TATE, FDG, and FDA, whereas it is suboptimal in F-DOPA. How about the comparison of functional imaging modalities in metastatic pheochromocytoma, which is SDHB related? DOTA-TATE and FDG are showing most of the lesions, whereas these lesions are silent on DOPA, FDA, and MIBG. So if you look at an algorithm of which imaging modalities to choose from this paper, you can see for pheochromocytoma, if it is sporadic, the first choice is DOPA or MIBG. If it is not available, then DOTA is the second best choice. In inherited, if the mutational status is not known, DOTA is the first choice or FDG. If the mutation status is known, if it is SDH related, then DOTA is the first choice. In paraganglioma, if it is sporadic, the first choice is DOTA. If it is inherited, it follows the same path as the pheochromocytoma. Coming to tumor-induced osteomalacia, this is also known as oncogenic osteomalacia, which is a rare paraneoplastic syndrome. It is characterized by hypophosphatemia resulting from excess levels of tumor-secreted fibroblast growth factor 23, phosphaturia with normal serum calcium, osteomalacia in the absence of a nutritional or drug history suggestive of vitamin D deficiency or generalized renal tubular defects. The tumors are of mesenchymal origin, often benign, small, and difficult to detect. Patient typically presents with progressive and non-specific symptoms, which includes bone pain, multiple pathological fractures, and proximal muscle weakness. The PET tracers that are useful are FDG and gallium dotatate, but gallium dotatate performs better than FDG, and in clinically suspected cases of hypophosphatemic osteomalacia, dotatate may be performed as first-line imaging investigation. This is a case of a 18-year-old girl presented with bone pains over hip, thigh, back, and shoulder. She had history suggestive of proximal muscle weakness, has been able to walk only with support, and a gallium DOTA imaging was done, and the culprit lesion was localized to right proximal tibia. She underwent an excision, and you can see that progressively she has improved, both clinically and in terms of biochemical phosphorus level, and the FGH23 also has significantly improved. The biopsy was phosphaturic mesenchymal tumor. Another patient with similar complaints, and his blood pool imaging was done, which was done initially. This image was negative, and FDG picked up the lesion in the right distal femur. This was excised, but the patient came back with recurrence of symptoms, and an FDOPA was done after a year, and this showed the recurrent lesion in the same area, and patient is doing well after the excision. In our own study of 27 patients, we found that 81 patients were found to be positive on DOTA imaging, the most common site being the lower limb, and the most common presenting symptom was bone pain. So what's the take-home message? Gallium PET agents have significant clinical promise, and it can be produced from the germanium generator, obviating the need for an on-site cyclotron. Somatostatin receptor targeting has become a mainstay in clinical workup of neuroendocrine tumors, and target-specific gallium radiopharmaceuticals have revolutionized molecular imaging in endocrine-related diseases, thus adding to the armamentarium for surgical strikes. Thank you very much for your patient hearing, and I'm now open for questions.
Thank you, ma'am, for a very comprehensive talk. Ma'am, just one single quick question. In a case of focal versus diffuse nesidioblastosis, do we have a choice of exendin as well as gallium exendin as well as FDOPA? Which one would you prefer, ma'am?
If you have a choice between exendin and FDOPA, I will prefer FDOPA. And one of the problems is that it is not available very easily. Therefore, we are forced to go for gallium-based imaging.
Dr. Anand, sir, you would like to ask something?
Yes. Thank you, ma'am. That was a very fantastic, session, which basically, had a very good clinical snippet. I just have one question. I mean, you were talking about gallium scans specifically for pituitary diseases. I just wanted to know your comments specifically with relation to C11 methylene PET in comparison to gallium dose-stop. Given the fact that basically, most of the hormones are peptides, and obviously methionine being, an amino acid for all the peptides. How do you think that would perform? And I know that we don't have the availability universally in our country, but basically, if that were to be used, how do you think that would compare with the gallium scans?
So gallium scans, especially the DOTA scans, are very useful in the post-op setup. And there are not many studies comparing C11 methionine with gallium. So honestly, I do not have an answer for that.
The only reason I ask is basically technically because of the possibility from an endocrine side. We would look at this. These are peptide hormones, and wouldn't it be better if there are, especially for Cushing's disease, when we have a very small lesion, or we look at imaging, routine anatomical imaging, and we don't get lesions that's very tiny or not detectable or questionable. Then does this have a better image, or does the gallium have the better sway? As a clinician, that would be interesting.
Shall we move to the next talk?
Yeah, if you permit me, I will just ask one quiz question now.
Sure, please, sir.
So coming to the penultimate question, quiz question number 9. I think all of you know how to answer by now. So this is a 56 years old female. She has history of treatment for pelvic malignancy. Now she is complaining of progressive edema of bilateral lower limbs and back pain. So this is the lymphoscintigraphy study. You can have a look at the images, early images, late images, anterior, posterior. So what is the level of obstruction? Option A, bilateral inguinal regions. Option B, bilateral popliteal regions. Option C, bilateral pelvic lymph nodes. Option D, retroperitoneal lymph nodes. I'll show you the images once again. So we have a winner for the last question. It was Sheikh Bashiruddin, and the correct answer was option D, because both lobes of prostate were involved. Regarding your question, Arun, we have the top expert of hyperinsulinism who is talking. He is the next speaker. I think he will clarify everything. Can you share Dr. Srinageswar's CV slide?
So good evening, everyone. It's indeed a great pleasure to actually introduce Dr. Sri Nagesh, who's a consultant endocrinologist from Hyderabad. Dr. Sri Nagesh, to introduce to this particular audience, he's very renowned. He's renowned nationally and also internationally. He has had accolades across his career, right from the undergraduate, postgraduate, and super specialty. He has multiple presentations, and he has actually chaptered multiple endocrine chapters in textbooks, and also has got multiple peer-reviewed articles across basically countries. So it's a pleasure today. He's going to talk to us about hyperglycemia, hyperinsulinemic hyperglycemia. He's going to talk about investigations, but in particular correlation to the imaging and also in terms of genetics.
Respected faculty and dear friends, I am Dr. Sri Nagesh, an endocrinologist from Hyderabad, and it is a great honor and pleasure to be a part of this meeting. Before I begin, I would like to thank Dr. Hari Shankar and the other organizers of this conference of Society of Nuclear Medicine South Chapter for inviting me to be faculty. Today, I'm going to speak about the genetics and investigations of hyperinsulinemic hypoglycemia. This is my topic, and this is going to be my method of presentation. This is my overview. I'm going to give you a brief overview of congenital hyperinsulinism, a case scenario to explain it better, a small note on adult hyperinsulinemia, a case scenario to make it easier, and a few conclusions. Congenital hyperinsulinism is the commonest cause of hypoglycemia in infancy. Can be transient or it can also be permanent. The transient variety is less common and the permanent variety is more common. The incidence varies between 1 in 28 to 50,000 live births in the general population. But if you got a family history of consanguinity, it can be a lot more common. The main importance of this particular disorder is that if it is left untreated, the severe and recurrent hypoglycemia can lead to neurological damage, recurrent seizures, and can lead to long-term neurological sequelae and developmental delay. And that is the reason why we need to evaluate this disorder, diagnose it, treat it medically, or if not possible, surgically by pancreatectomy, so that the neurological development stays normal. And if you look at the monogenic and the genetic picture of hyperinsulinemic hyperinsulinism, this is actually a monogenic disorder, which is dominated by the ABCC8 and the KCNJ11 mutations, which can be transmitted either in a dominant or a recessive manner. Some of these variants can also cause transient hyperinsulinism and can also be associated with a focal histology, especially if inherited from the father. Less commonly, there are other disorders like glutamic acid decarboxylase deficiency, which can present with protein-induced hypoglycemia. Surprisingly, a lot of mutations which can cause MODY or majority onset diabetes in young can also present with hyperinsulinemic hypoglycemia, like glucokinase, HNF4 alpha, and HNF1 alpha. HADH mutations can present with protein-induced hypoglycemia. Uncoupling protein 2 mutations can usually present with a mild hypoglycemia, which is very responsive to diazoxide. And rarely, there can be very mild mutations which can be unmasked only by exercise, like in mutations of SCL1-6A1, which is transmitted in a dominant manner. As time goes on, we are increasingly recognizing more and more mutations which can cause this kind of picture. And sometimes you can have syndromic disorders of hyperinsulinemic hypoglycemia. A classic example is what you see in this picture, the Beckwith-Wheatman syndrome, which is transmitted by uniparental disomy with typical clinical features. Kabuki syndrome, which is another syndrome which is increasingly being recognized to be associated with hyperinsulinemic hypoglycemia with the typical Kabuki mask-like appearance of the child. Even disorders like Soto syndrome, which can cause macrosomia, are being recognized as rare causes of syndromic hyperinsulinism. And these are all the disorders which need to be considered when you evaluate a child for hyperinsulinism. And going ahead with the case scenario, this is what the case the child presented at 2 days of life, who was referred for evaluation of hypoglycemia, born at 36 weeks of gestation of a non-consanguineous marriage. The birth weight was 3.3 kilos, which was slightly higher, but for somebody born at 36 weeks. The mother had a very history of a very mild gestational diabetes, well managed on dietary therapy. And uncharacteristically, the child presented on day 1 of life with seizures, which tells us that this is a very severe form of hyperinsulinism, because children with hyperinsulinism usually present on day 2 or day 3 of life, never on day 1. Day 1 is more likely because of ischemia. These were the investigations. A definite hypoglycemia with a blood glucose level of 14 milligrams per deciliter, a very high serum insulin level. Growth hormone and cortisol were detected, but they were not as high as would be expected in the case of hypoglycemia. But on the other hand, we have to understand that the pituitary apparatus is not very well developed in a 1 or a 2-day-old child. And it takes up to 3 weeks for the pituitary, neonatal, and the infantile pituitary to develop. So that growth hormone and cortisol might not be very high during episodes of hypoglycemia in a neonate. The urine for reducing substances and the urine ketones were absent, and the TSH was normal. This fit in very well with the diagnostic criteria of hyperinsulinemic hypoglycemia as recommended by the Pediatric Endocrine Society. When the blood glucose level is less than 50 milligrams per deciliter, the blood insulin should be more than 1 microunits per ml. Where you have glucagon available, there should be a minimum of 30 mg per deciliter rise in blood glucose levels after IM or IV injection of glucagon. And you need a high glucose insulin rate to maintain euglycemia, at least 7 mg per kg per minute, which were seen in this particular case. And the supportive finding, beta hydroxybutyrate was should be less than 2 millimoles per liter. We did not do a blood beta hydroxybutyrate. We did a urine ketones, which were negative, and wherever available, blood-free fatty acid should also be very low. Unfortunately, these tests are not widely available, but this case fit in very well with the diagnostic criteria of hyperinsulinemic hypoglycemia. Initially, the child was managed with glucose infusion and hydrocortisone. Subsequently, he was started on diazoxide, with which he had only partial relief with breakthrough hypoglycemias. The next course of action, he was then started on second line treatment, which was nutritional therapy with IV glucose infusion. Sometimes you can give cornstarch, which is broken down very slowly so that you tend to have lesser hypoglycemia if the child is feeding and slightly older. And frequent feeding if the child is feeding. If he is not feeding or having recurrent seizures, you can continue feeding through a nasogastric tube or a gastrostomy. In case these didn't work in this child, and then he was started on medication with octreotide subcutaneous. Wherever glucagon is available, glucagon can be used as a rescue medication. And in some situations where you have very poor response with octreotide and diazoxide, you can also try the use of nifedipine. Hydrocortisone can also be used IV 2 to 3 times a day, but it usually does not work beyond the first 48 hours of life. So going ahead with the guideline, the child was evaluated genetically because in patients who are unresponsive to diazoxide, it's always recommended that etiological diagnosis should be performed. Genetic testing for ABCC8 and KCNG11 is the first line investigation. And it was found that the mother was heterozygous for the novel ABCC8 missense variant. The same mutation was found in the baby, whereas the father's genetics were found to be normal. And the genetist labeled this as unlikely to be pathological, as the mother had had the same mutation but did not have any history of hypoglycemia, so they could not come to a conclusion. The next, the treating neonatologist and endocrinologist ordered nuclear imaging, and they went ahead with gallium-68 exendin-4 PET-CT, which showed a diffuse uptake, but the nuclear medicine physician labeled it as indeterminate. At this point of time, the child was referred to me, and I did a relook at his clinical picture. The ultrasound and the MRI were normal. The child had presented with severe hypoglycemia and developmental delay. The gold standard test for imaging, nuclear imaging in a child with hyperinsulinemic hypoglycemia is 18F-DOPA and not exendin-4 because it is not well validated in units. But this was unfortunately not available. And then I went back and had a look at genetic testing. And I had my own doubts about the bioinformatics. Generally, according to the guideline, this is how you should approach a clinical case of congenital hyperinsulinism. If he is not responsive to diazoxide, do an ABCC8 or a KCNG11 mutation. If it is maternally, you find a maternally heterozygous mutation, it's a compound heterozygous mutation, or the child is homozygous, it's more likely that it is a diffuse congenital hyperinsulinism. Manage on medical therapy. Unstable, go ahead with a subtotal or a near total pancreatectomy. If there is a paternal heterozygosity, it makes it more likely that you're dealing with a localized lesion. Go ahead with an 18F-DOPA PET-CT. You find, more often than not, you'll find an atypical congenital hyperinsulinism, a local lesion. Try to manage on medical treatment, but it's always better to go ahead with a subtotal pancreatectomy, or if you find a demarked lesion, do a focal lesionectomy. In case you do not find any genetic disorder in the parent or a mutation is not identified, go ahead with an 18F-DOPA. Try to manage medically. Not managed, go ahead with pancreatectomy. Sometimes you find other mutations like HNF4 alpha, glutamate, decarboxylase, GCK. Most of these mutations are pretty mild and they usually respond very well to medication. So in this case, a pancreatectomy is usually not recommended. So this was what I went ahead. I wanted to repeat the genetic analysis again. And this is what we found. The mother was heterozygous for the novel ABCC8 missense variant. This time the genetic evaluation, because we had sent the samples to Exeter in UK, which is one of the best labs in the world for this disorder. They had better bioinformatics, better genetic analysis, and the father was found heterozygous for the ABCC8 missense variant. And the child ended up actually being a compound heterozygote with two mutations, one inherited from the mother, one inherited from the father. The mutation in the mother was pathological. The mutation in the father acted as a promoter for the pathological mutation in the mother. And consequently, that was the reason why the child developed hypoglycemia while the mother had not developed hypoglycemia, because she had not inherited a promoter mutation, whereas the child had inherited a promoter mutation from the father. And at this point of time, with this picture, it was concluded that you're probably dealing with a compound heterozygote with diffuse congenital hyperinsulinism, and he was posted for near total pancreatectomy. I'm sorry, it's not thyroidectomy, it's near total pancreatectomy. If you look at this was what we did in this case, did the genetics, found out a diffuse hyperinsulinism, tried to manage medically. Since this was not very successful, we went ahead with a subtotal pancreatectomy. And a brief look at the non-KATP mutations. GLUT1 mutations are usually mild but can present with seizures and developmental delay. Surprisingly, mutations of the MODY genes like HNF4 alpha, ABCC8, and KCNG11 can present with a transient hypoglycemia in infancy and can present with neonatal maturity onset diabetes in the adult. So don't be in a hurry to do a pancreatectomy in these patients. HADH mutations are uniformly very responsive to diazoxide. And in some cases, where you do not have any identified mutations, a few studies actually recommend doing an intra-arterial calcium stimulation test and transhepatic portal venous sampling, which is extrapolated from the adult data, but unfortunately, these are not very useful in children. And surprisingly, in the last 1 year, we had one study which actually looked at extending for PET imaging in focal congenital hyperinsulinism in a child. And this was what they concluded. Extending PET has higher clinical sensitivity and better inter-observer correlation for the detection of focal congenital hyperinsulinism than DOPA-PET. But the consensus of the opinion actually tells us that it's actually 18F DOPA-PET, which is still the gold standard for localization of lesions in congenital hyperinsulinism. Extending PET, the studies are very limited. So even though we have one study which actually endorses extending PET, I think we'll actually need more evidence before we go ahead with an extending PET evaluation, which becomes standard of care in congenital hyperinsulinism, unlike what is seen in the adult. Coming to the second case scenario, a brief overview of hypoglycemia in the adult. In non-diabetic adults, hypoglycemia is very rare. Most of the cases of hypoglycemia you see in the adults are adverse events because of anti-diabetic drugs like insulin, sulfonylureas, or glinides. Whenever you look at an adult for hypoglycemia, the Whipple stride is always mandatory, characterized by diagnosis of biochemical diagnosis of a low blood glucose, patient presenting with symptoms of hypoglycemia, and you should have history of relief with glucose administration. Only when the triad is satisfied do you go ahead with a diagnosis of hypoglycemia in an adult. And you should always rule out factitious hypoglycemia in an adult. And that is the reason why I always recommend clinicians to take critical samples. I have seen this tendency of doing early morning cortisol, early morning growth hormone. These have no value in people with hypoglycemia in an adult. It is always a critical sample drawn during an episode of hypoglycemia. Once we confirm hyperinsulinism, the next step is localization because insulinomas are much more common in adults. The case scenario, this was a 45-year-old who presented with recurrent episodes of sweating and weakness relieved by eating, an 8 kg weight gain over the past 6 months with documented hypoglycemia, the lowest value being 40 during these episodes of hypoglycemia. The patient had a prior abdominal ultrasound and CT, which were inconclusive, and he was then referred for evaluation. I took his clinical history, found out that he correlated perfectly well with hyperinsulinemic hypoglycemia and recommended doing critical sample. In case you do not have spontaneous hypoglycemia, it's recommended that you do an induced 48 or a 72-hour fast. Don't give him anything except water. Let the blood glucose levels come down below 50 to 56 milligrams per deciliter, and then take critical samples for insulin, C-peptide, beta-hydroxybutyrate, proinsulin, and sulfonylureas. C-peptide values are high and the insulin values are low. It indicates a hyperinsulinemia of pancreatic origin. Only insulin is high, rest everything C-peptide and proinsulin are low. Probably factitious insulin administration. If your insulin, C-peptide, and proinsulin, all three are high and the sulfonylurea screen or the meglitinide screen is positive, it indicates factitious hypoglycemia because of administration of sulfonylureas. And if sulfonylurea screen is negative and the rest of the things are high, it indicates that you're dealing with a true hyperinsulinemic hypoglycemia. This was what we found. The blood glucose level was low. The serum insulin level was high. HbA1c was low, consistent with hyperinsulinemia. The C-peptide and the proinsulin were high and the sulfonylurea screen was negative. Creatinine was normal and the cortisol was high, correlating perfectly well with hyperinsulinism. TSH was normal and the MRI abdomen which was ordered was negative for the tube. So now that we have diagnosed hyperinsulinism, the next step is localization of a tube. The first option which most endocrinologists would use for hyperinsulinemia is endoscopic ultrasound. It is one of the best tests with more than 86% sensitivity and specificity for diagnosis of hyperinsulinism, but it has a few caveats. It is a purely operator-dependent test because you're depending on ultrasound. It is invasive, and because it is ultrasound-based, you can miss isoechoic tumors. If you have a low body mass index, a female gender, young age, there might be risk factors for negative imaging. And if the tumor is located in the head of the pancreas, it is very sensitive, whereas mutation lesions located in the tail of the pancreas or the body might not be well picked up. In this case, we actually found out an endoscopic ultrasound, which was EUS was negative. This brings us to the next step, the nuclear imaging. I'm sure all of you are familiar with this, and this is the most important step in the localization of an insulinoma. I'll give you a brief overview of the various radionuclides and methods used to diagnose it. 18F-DOPA, we've discussed a lot about it in pediatric hyperinsulinism. In adults also, it can be used, and it has an advantage that it is better at detecting the pancreas head lesions. But it has a few disadvantages. Prominent activity is seen in the gallbladder, the biliary tract. Some activity is also seen in the salivary gland and the stomach. And its utility in adults is not very well validated. So at this point of time, this is an imaging which is restricted only to children. The present gold standards in the past decade worldwide has been GLP-1 receptor imaging, glucagon-like peptide-1 receptor, or the so-called exendin-4 imaging. It is very widespread in the West now. It is increasingly becoming widespread even in India. The cost was initially high, it's coming down. And it has the advantage of a short half physical life, which has made it the best test for nuclear imaging of insulinomas and hyperinsulinism in adults right now. Its main disadvantage is that it is less useful in malignant tumors. The other test with which I'm sure all of you are familiar is FDG PET CT, which is almost always used for detection of a metastatic insulinoma. And coming to the other very important test, which has been the mainstay for many decades in the evaluation of nuclear imaging of hyperinsulinemia, it is the somatostatin receptor imaging. There are multiple radionuclides like dotatate, dotatalk, dotanoc, but the preferred one for a lot of endocrinologists and nuclear physicians is 68 gallium dotatate, because the somatostatin receptor 2 is the predominant subtype in a lot of insulinomas, and this is best picked up by dotatate. It has advantages that the cost is low, there is very low radiation, it's very widely available, and of specific interest to nuclear physicians is that it can act as an initiator or a stepping stone for stereognostic investigation to determine the suitability for peptide radionuclide therapy of metastatic insulinomas. The disadvantages with this are, in the past decade, we've had lesser studies with dotatate because the emphasis has shifted to exendin-4 imaging. And especially dotatate PET CT, we have very few studies. The largest study has looked at less than 30 patients, and that is the reason why we are increasingly shifting towards an exendin-4 imaging for hyperinsulinemic hypoglycemia. So this was what we did in this patient. We did a GLP-1 receptor imaging, which showed a 1 into 1.2 centimeter tumor in the head of the pancreas. He underwent surgical resection, and he is now asymptomatic. And one caveat, whenever you're evaluating hyperinsulinemic hypoglycemia, always you should be mindful of these other causes. NIPHS or non-insulinoma pancreatogenous hyperinsulinemia syndrome can present with typical postprandial hypoglycemia, which is almost indistinguishable from insulinoma, with a negative localization and negative imaging. One important factor which can help you differentiate is the fact that hypoglycemia always tends to be more postprandial because of disorderly release of insulin, and it can resemble a dumping syndrome. A lot of times post-bariatric surgery, many patients present with classical hyperinsulinemic hypoglycemia because of focal development of small islets of beta cells, a typical nesidioblastosis like picture. Factitious hypoglycemia is a true possibility in the adults. And sometimes you also have to look at the development of insulin antibodies, especially in relation with other endocrine disorders, which is typical presentation like a Harata syndrome, which can almost be indistinguishable from NIPHS or hyperinsulinemic hypoglycemia, and which can be detected only by measurement of insulin antibodies, which is easily treated by glucocorticoids. To conclude, hyperinsulinemic hypoglycemia is rare in adults. It is not so uncommon in children. Children usually present more commonly with a diffuse form, but they can present with a focal form, especially if you have an isolated paternal method of heterozygous transmission. The gold standard test in children is always genetics, followed by 18F-DOPA if you suspect a local focal lesion. Treatment is always by diazoxide, use of octreotide, fortification with glucose, and going ahead with a pancreatectomy if you fear neurological damage. Situation in adults is slightly more different. Factitious is more common in adults. There are many other disorders which need to be ruled out. So you need a confirmation with a Whipple stride and critical sample evaluation. Then you need to localize the tumor. And one important factor which is different in adults as compared to children is multiple endocrine neoplasia type 1 is a possibility in adults. An adult presenting with insulinoma right now can very well be a case of multiple endocrine neoplasia. He can present later on with the typical parathyroid and the pituitary lesions of multiple endocrine neoplasia. And in the setting of a suspected men or a family history of men, these patients need to be maintained on a lifelong surveillance. And you all should always make it a point to rule out all the other causes of hyperinsulinism with a special note on NIPHs, insulin antibodies, and factitious hypoglycemia. That's it. With this, I come to the end of the presentation, and I'd be happy to take questions from you.
Sir,
Thank you very much, Dr. Sri. Sorry, go on.
No, sir, I was asking you if you want to ask some questions.
Sure. Thank you very much, Dr. Sri Nagesh. It was a phenomenally fantastic talk as usual. Enjoyed it right from the beginning to the end. So I think you've kind of listed it in an excellent way. I think, with the clear clinical cases, it's pretty clear. I just had a question. I mean, as an endocrine colleague, I just wanted to know your usage of sirolimus, specifically in these diazoxide unresponsive patients, and your experience with usage of these agents in particular with congenital hyperinsulinemia. I mean, do you think they have a role, especially in our subset of people?
I'm not able to get the question right.
No, sorry. I was just asking about your experience with the use of sirolimus. Sirolimus.
I haven't used in a lot of cases. Right now, sirolimus I haven't used in a lot of cases. I think it's been used in only one very resistant case. Overall, we've done pretty well with diazoxide, and a few cases we can use octreotide, but we've generally gone ahead with surgery where we have not responded very well to diazoxide because the CNS damage is pretty bad. We've been doing whatever cases here, we've been doing fairly early pancreatitis, as early as 5 to 6 months, because the neurological damage can be very bad.
Sure.
Because
and the other
if,
area is,
you might get relief, but that might end up knocking off around 15 to 20 DQ points of the child.
Sure. Thank you. And the other thing is, you mentioned about the possibility of, a negative genetics and also a negative scan.
Yes,
how often do you face that kind of a scenario? So, and that's always a dilemma, isn't it, as to how to go about from there. Whether you offer pancreatic surgery or just wait and watch.
Sir, my personal experience is that's dependent on the bioinformatics and which lab you use. Generally, personally, Indian labs are not very good at bioinformatics, because if you go into the depths of the bioinformatics and the kind of the systems we use, like FEN2, whether you're using the FIND database or the FEN2, Indian bioinformatics are not very good, and we are too dependent on next-gen sequencing. We're not very good with Sanger sequencing. So usual rate of pickup internationally, I used to use a lot of Exeter before. Exeter people were my friends. I used to use a lot of Exeter for these genetics. Their pickup rate was something to the tune of 75 to 80%. 20%, like I've shown you, the case I've shown you, in India, the genetics were negative. Exeter, they picked out the promoter mutation. Their pickup rates are 75 to 80%. The other 20%, if they are mild, we do try to manage with diazoxide. If they are bad, then we'll have to go ahead with pancreatectomy. But the pickup rates are actually improving a lot. Maybe in 2012-13, they were to the tune of 40%. Now they've almost gone up to 80%. And I think with time, they're only going to get better.
Thank you so much. Much appreciated.
Sorry, sir. I've had a problem logging with my, so I have to do it over the phones. I'm not very clear. I'm very sorry about it.
Okay. Thank you. Due to lack of time, we'll have to rush. We'll conclude this session and then we'll continue the panel discussion.
Yes.
I'd like to thank Dr. Anand Kumar sir for graciously accepting the offer to chair the session. Arun, can you take over the quiz?
We move on to the last quiz question for the day. So before that, I'll announce the winner for the last quiz, question number 9. It is Dr. Sunita. The correct answer was bilateral pelvic lymph node, obstruction at the level of bilateral pelvic lymph nodes. Now we move on to the last quiz question quickly. Now I think by now everybody knows how to answer the question. So here we go. The 50-year-old female recently diagnosed hypertensive, borderline elevation of urinary VMA levels, non-specific abdominal pain, CT abdomen and pelvis has shown a left adrenal nodule. Now you can see the PET CT images. I will play the video for you. Carefully watch at the level of adrenals. I'll play the video again. Okay, one last time if anybody has missed. Okay, so these are the options. What is the likely diagnosis? Adrenal adenoma, left pheochromocytoma, adrenocortical carcinoma, or adrenal metastasis. If anyone wants to see the video once again. Okay, that's it. Thank you.
Okay, we'll move on to the next session, which is the endocrine panel discussion. To moderate the session, we have Dr. Gayana from Bangalore Fortis Hospital. We'll have some quick case scenarios, which we usually encounter in our practice. Over to Dr. Gayana.
Good evening, everyone. Since it is already time, I would be sharing my screen directly. Sir, it is not allowing me to share the screen.
Uday?
Yes, sir. Yes, sir.
Yes. Okay.
Yeah.
So in this session of panel discussion, we will be discussing 3 cases on thyroid disorders and other endocrine dysfunctions. We were supposed to discuss 5 cases, but we have brought it down to 3 because of short of time. So without undue delay, I would be proceeding with the questions. This is case number 1, which is a 24-year-old female patient with an elevated serum calcium level of 11.5 milligram per deciliter on routine health check.
Sorry, Gaina, we are seeing only your first slide.
Okay. There is an error again, sir. I'll have to. There is some.
Try now, ma'am. Try now.
1 minute. I'll have to share my desktop. Somehow sharing the open presentation is not working.
Shall I share the screen?
Sir, I'll be doing it. 1 minute.
You can try.
Click on play, madam. Click on play. Play.
Yes. Can you see this?
Yes, ma'am. Yes, ma'am.
Yeah.
Continue.
Okay. A 24-year-old female patient with elevated serum calcium levels of 11.5 milligram per deciliter on routine health check. She is married for 6 months and she is not conceived yet. So other than this, she does not have any complaints. So this is an incidental finding of elevated calcium levels. My question to the endocrinologist: what is the clinical approach? How do you proceed in such cases?
I'm Dr. Vignesh here.
Yes, sir.
It is so I would say it is an asymptomatic young women on routine evaluation found to have high calcium. Still, though the patients say they don't have any complaints, still I would like to put some leading questions to the patient. Do they have bony pains? Do they have any past history of renal stone, which the patient may not find it relevant to say, but so we can put a leading question: do they have any past history of renal or ureteric stone or bony pain or any treatment for dyspepsia kind of thing? So if all the answers are negative, so I would like to repeat the calcium levels along with the albumin. So I look to check the albumin corrected calcium levels along with the phosphorus alkaline phosphatase. If the repeat calcium is high, then I'll go. It's probably we are definitely dealing with a case of hypercalcemia. Then I would look to go for PTH. The one thing, most important thing you should remember while collecting the sample for PTH is it has to be collected in EDTA. Many times it is collected in room temperature. The most important thing, PTH is a labile peptide. It has to be collected in a cold chain, pre-chilled syringe, cold chain, and it has to be transported in the ice pack. Then only we could able to get the actual value of PTH. Suppose if the PTH sample is collected at the room temperature and it is since it is a labile peptide, every hour there will be a fall in the PTH levels. At last we may be we can get an error in this report. So my clinical approach will be ask for a grading question. If everything is negative, then do a repeat calcium, phosphorus, albumin, and the PTH in the cold chain.
Okay. That is a very good way, sir. And then now, what are the important relevant clinical history? We've already covered this, sir. So we'll be going to the next question. So what are the investigations to be performed? As you said, you will be ordering for intact PTH levels. Now, if at all, if the intact PTH levels come high, what is the next preferred investigation? Is it going to be ultrasound neck or is it going to be technetium labeled maybe scan?
So it is there is no preference of ultrasound or nuclear medicine imaging. It is about the availability. So in most of my setup, I think it is easier to get a ultrasound at my local place, and I just try to confirm adenoma anatomically. So it is easier for me to do, and many times patient will be convinced to do ultrasound first. And if I get some localization ultrasound, straight away I have to send to the nuclear medicine for functional imaging.
Can we get an opinion from the endocrine surgeon also? Subhanya ma'am is also there.
Yes. Ma'am, would you be giving us insights on how to proceed if at all, if there is elevated IPTH level and elevated calcium levels and you are suspecting primary hyperparathyroidism, would you want to go with the ultrasound neck first or would you be ordering for a maybe scintigraphy?
I agree with sir. As ultrasound is widely available, we prefer to do ultrasound first. And then your approach is for focused parathyroidectomy. Okay. So when we want to confirm it again with another imaging, so that we have two concurrent imaging to go for a focused approach, we would love to do another imaging, that is nuclear medicine imaging maybe.
Ma'am, if at all, if the ultrasound is negative for any adenomas, that is, there is no localization of adenomas on ultrasound, so would you be ordering maybe scintigraphy?
Yeah, of course, to localize when that is an ectopic gland.
Okay.
It is situated in the mediastinum, or when it is more posterior, when they are not able to localize it by ultrasound. Maybe is more sensitive to pick up those cases. So we would like to order first maybe.
And you are classically in all the cases, even when the parathyroid adenoma is localized on ultrasound, would you still be doing maybe scintigraphy?
When there is only one gland that is in one side, like right or left, and there is only one gland localized in ultrasound. Okay. So doing another imaging, by the recommendation, we can do focused approach, that is looking at only one parathyroid and exploring and taking out. Is possible only if you do another imaging and confirm it. Okay. This is just to avoid parathyroid hyperplasias, which maybe are double adenomas, which can be missed by one imaging. So that is the reason for combining both, either ultrasound or maybe or ultrasound or 4D-CT.
Okay. Okay, ma'am. So with this, I'll come to the next question. This is to a nuclear medicine physician. Either Dr. Sumit or Dr. Randhir can take this question. Subtraction imaging versus dual phase imaging. Are you doing both dual phase as well as subtraction in all the patients, or do you choose the patients?
You go for dual phase only, maybe dual phase. And
You
for all
don't
cases,
routinely-
yeah, we don't do routinely subtraction imaging. And I go for all patients, SPECT CT we do.
Okay. So now why do you want to avoid, Dr. Sumit, the subtraction imaging?
Basically, we can, like it's not that sensitive. Technetium maybe with dual phase is more sensitive and specific for adenomas. And doing dual tracer imaging, subtraction imaging, it takes again time for the patient. So we don't do it. I don't know whether Dr. Harishankar might add
Can
something.
I comment?
Consider,
Yeah, can I comment?
yes,
Yeah,
sir.
yeah.
Yes,
See,
sir. Please.
subtraction imaging, personally, I feel it is like technically too difficult in a busy department. Most of the times the patient does move. So it ultimately the entire purpose of doing the imaging gets wasted. Dual phase is just as good, and along with the SPECT CT, it is just as good as any other investigation.
Okay, sir. With that, shall I move on to the next question?
So, ma'am, I have one doubt with the endocrinologist. Like, if they find a single nodule on ultrasound, they go in do an robotic or very minimally invasive
Minimally
procedure.
invasive parathyroidectomy.
After they remove the gland, do they visualize the other glands, or they do an intra PTH levels, or how do they proceed with? If only ultrasound is done.
Suganya, ma'am?
If only ultrasound is done and no other images or no other imaging is possible in the setup where they are working, it is better to go for bilateral cervical exploration and avoid focused or minimally invasive approach, because where we can see or visualize all 4 parathyroid glands and confirm that they are not
Ma'am, we can't hear you. Okay.
Sir, can you hear now?
Yes.
Yeah, no, my internet problem. Sorry, my bad. Okay, I heard it.
Yes,
I think ma'am has given the answer.
Yeah.
Okay. So this is the scan of that patient. We have done both subtraction imaging, and in that we can see that it is normal. And here, this is the dual phase imaging. Here also we can see normal uptake in the gland and normal washout without any retention. So scan wise, we will interpret it as negative. So in this patient, when IPTH is elevated, IPTH levels of 160 and scan negative on MIB and ultrasound has not localized any adenoma. So how would you proceed? Suganya ma'am or Vignesh sir, please.
Yeah, if ultrasound, it all depends on the experience. So generally, we'll say easily it's ultrasound, but I would say not all the sonologists are good at are trained to look at the parathyroid. So experienced senior senior sonologist who's good at localizing parathyroid, still if he could not localize the adenoma, and if it is negative on maybe, then probably Colon CT would be the PET CT would be the next choice. Still, it could pick up. It has a high sensitivity pick up the adenoma, or 4D CT if it is available. If it is available at the place.
My next question to nuclear medicine physician. In this scenario, would you suggest any further investigation from your side, Dr. Sumit or Randeep sir?
We don't do FAT choline PET CT, so I have no experience in it. However, only thing what I have read is that it's very specific and far more sensitive than MIB. So if at all it is available, however, the cost is an issue. It's very costly wherever it is available. So that's one thing. 4D CT is actually coming in a big way. Not many radiologists actually do 4D CTs. Even in our center, they don't do 4D CT. So when we were a few days back when we were discussing, actually I told like 4D CT is one of the modalities for adenomas. They don't do it routinely actually.
4D versus MRI?
MRI have no.
C11 methionine PET CT we have done for few cases and it was good.
Okay.
And we found C11 methionine. I don't have any experience with F18 choline,
it's as good as theoretical only. C11 methionine we have done, and we used to send to other centers, but we got the CDs and all. So it was good. And the second thing, previously we tried doing dopamine augmentation. That did not help. But what we do in our center is intra-op PTH monitoring. They go for intra-op PTH monitoring, and after dissection of all the 4 parathyroid glands, if the PTH is falling, when C11 methionine is also negative, they are doing intra-op PTH monitoring. They are doing all complete parathyroidectomy and implanting the other one in the elbow. This is what we are practicing.
Sir,
Diana, we have an observation from Dr. Kumaresan, sir.
Yes, sir.
Her feels the right upper is very doubtful for an adenoma. In the case that you are showing.
We are showing right upper.
Yes.
This case actually, sir, even on further 4D CT imaging was done for this case. Even on further 4D CT also, we could not pick up any adenomas.
Also, sir, because she is young, could it be hyperplasias and we have to evaluate for the multiple endocrine neoplasias?
The discussion I would wanted in this case was regarding F18 choline PET CT also, since it is not readily available. So what will be the options left for the clinicians? Whether will you be choosing 4D CT or MRI? And what is the experience with 4D CT and MRI in cases of parathyroid adenoma when other conventional imaging have failed to detect and localize parathyroid adenomas? Ma'am, Suganya ma'am or Vignesh sir, your experience?
Sir, in case of 4D CT, it is very good because it is just adding time to it. Then we can do in all centers where CT is available. Where you will be evaluating multiple phases of contrast excretion, like arterial phase, venous phase, and delayed venous phase.
Yes, ma'am.
So parathyroid has good washout rates. So it will take out the dye quickly and wash it out rapidly.
Correct,
so which will not be so in case of thyroid nodules or lymph nodes. Or in those cases, if 4D CT is available, which it will be the best. Or I have an experience with a patient like this, and we took the patient for surgery and did multiple venous sampling, selective venous sampling for a patient in either IJBs on both sides, and looking how to localize at least in which side the parathyroid is enlarged.
Okay, ma'am. Unfortunately, many of the literature which is available till date, they don't specify when MIBI or ultrasound fails to detect a parathyroid adenoma, they don't specify the lesion size when they detect it on 4D CT or MRI. This is unfortunately not in the literature. So we will have to look into more of these cases probably. And Vignesh sir, is there any role of calcimimetics in these cases?
So if C is almost, we would say asymptomatic hypercalcemia, but the calcium levels are quite high. So she may develop likely chance. She may be having hypercalciuria. She may develop a stone also. So as such, if she develops symptom, probably short duration of calciumity can be tried. Suppose some patients with the refractory hyperparathyroidism, predominantly tertiary kind of thing scenario, secondary and tertiary, we do use short-term bridge therapy. It is not a permanent kind of therapy. We do try short-term therapy for such patients, but as such, there is no guidelines when to initiate and how to follow these patients.
Okay, sir. If at all, if a patient refuses to choose for empirical surgery, if I want to call it that way, because the parathyroid adenoma has not been localized, and they might explore all the 4 parathyroid glands. So will the option of calcimimetics over surgery will any time be given, or is it always surgery preferred over?
It is generally surgery preferred, considering the age and level of calcium, but generally it is surgery preferred over the calcimimetics.
Thank you, sir. With this discussion, we will be moving to the next case. Here we have a 48-year-old male patient with history of neck swelling for 3 years. On examination, there is nodule in right lobe of thyroid, which is palpable. So once we see a thyroid nodule which is palpable, how do you investigate it further? Suganya ma'am, will you please take this question?
Yeah. In case of male patient, considering his age and male gender, with a nodule in the right lobe, we have to follow the quadruple assessment for thyroid. That is, usually we'll do triple assessment of clinical examination, investigation, and pathology, FNAC. But here you have to also evaluate his thyroid function test, ultrasound, FNAC, and thyroid function test, and look for the characteristics of the nodule in the ultrasound. So when there are high suspicious features in ultrasound, you proceed with a guided FNAC. If it is a solid cystic nodule, you guide it for more good specificity. You do an ultrasound guided FNAC and take it from there, depending upon the pathology. Or if he is a functioning solitary thyroid nodule, then he can have options of controlling it and further proceeding with iodine therapy.
Yes, ma'am. In this case, the patient was found to have a nodule with features of hypervascularity, and a suspicion of possibility of neoplasm was raised, and the patient underwent FNAC, which showed papillary CA thyroid. So is there any role for preoperative CT MRI in differentiated thyroid cancer? Ma'am, this is question to you again.
Yeah, CT is usually done for patients who have locally advanced thyroid malignancies. That is, a patient is having a hard fixed nodule, where you are suspecting invasion to the adjacent structures, where you want to delineate those invasion, whether there is invasion to the esophagus, trachea, or neighboring vascular structures. We need to do CT for those patients, or for a patient who's having a large nodule, although not malignant, you want to compare it with the neighboring structures. Or if you suspect a retrocranial extension, then we'll be doing a preoperative CT. Or a patient is having a bulky nodal disease, bilateral nodal disease, to look at this mediastinum, we'll be requiring a CT. So only for these 4 scenarios, we require CT other than the usual ultrasound. Get more information from the CT.
Ma'am, is there any role for MRI at all in differentiated thyroid cancer?
MRI is required if you are suspecting involvement with the muscle, your paravertebral muscle. Soft tissues can be better delineated with MRI.
Okay. Ma'am, is there any nodule size cutoff where you will consider on ultrasound, say there is a nodule size, based on that cutoff, do you anytime recommend CT?
Not really. When it is a, you see, when it is a huge nodule, meaning more than 5, 8 or 10 centimeter.
Okay, ma'am.
But more than the size of the nodule, we'll be more concerned about the fixity. If it is a solitary nodule which is good mobile, you know where it is vascular structures are well away from it, you can feel the pulse. And it is really mobile. Even for a size of 7 to 8 centimeter, when you are feeling the lower border, that is not retrosternal, it is not having any nodes palpable, and it is very mobile. In those cases, still we don't require CT.
Okay, ma'am. And if at all, if you have to consider neck dissection in these patients with, say, nodule of more than 4 centimeter, then also you would not be wanting a CT, ma'am?
CT, if you are having a small node, for example, 2-3 centimeter or 2 centimeter node, which is palpable, and the patient is having a small ipsilateral nodule.
Okay,
still we don't require CT for those patients where we didn't expect a major nodal bulk in the mediastinal region. We are not going to proceed with mediastinal dissection. So in well-differentiated carcinomas, when you have a bulky nodal disease, bulky nodes in the sense, nodes are palpable in all 3, 4, 2 regions, and when they are larger than 5 centimeters. When you are suspecting mediastinal involvement and going to proceed with mediastinal dissection, those patients will proceed with CT. Because in ultrasound, the characteristics of the nodes are actually the vascularity, calcification, cystic consistency, or everything is well shown in ultrasound itself.
Is there any role for contrast CT in these patients?
Contrast will help you to see the difference between the vascular structure and the nodule, whether it is invading the vascular structures. So if we are doing CT, we'll be preferring contrast enhanced CT only.
Okay, ma'am. I mean, what about the radioiodine therapy? If we are considering later in an already proven case of differentiated thyroid cancer, would you still be wanting a contrast enhanced CT, or can we manage without contrast?
We can, of course, your question that is iodine contrast will interfere with the iodine therapy,
Yes,
radioiodine therapy, where you have to give a gap of 4 to 6 weeks, where you cannot fast track your iodine therapy scans.
Yes,
that is why we have to be very choosy in wanting a contrast enhanced CT. Only in those scenarios where it will be very really helpful.
Can I make a quick comment?
Yes,
sir.
Yes, sir.
So, see, even if we are asked to do a CT, we will do it with contrast. You will have to accept that. So, without the contrast, it is absolutely difficult to identify any of the nodal structures, or especially the invasion. I think if a CT is done, then it has to be a contrast CT. That is my opinion.
Yes,
sir. Here in our setup also, the surgical oncologists, they have only one site. If they are unsure about the extent of the nodule, like on clinical examination, they go for contrast CT only, just to delineate whether there is vascular invasion. And the plain CT, either they will not know what to do, it will be waste examination. So they will go with contrast enhanced. We do give Lasix for 1 month tablets, so that just to remove all the contrast materials. So that's one method if the patient has underwent a CCT and they have been advised radioiodine ablation, they come post-op. So we start them on 1 tablet, 40 milligrams Lasix for 1 month.
So what does our guidelines say? Does guidelines say to proceed with contrast enhanced CT?
What if the practitioners are advising for MR without non-iodine contrast? So because then the surgeon definitely he wants anatomy. So then instead of going for recommending or suggesting for contrast CT, so what can't we suggest them to go for a non-contrast MR than contrast CT?
Sir, I beg to differ. Anyway, betadine is being used during surgery. Anyway, we are going to treat the patient only after 4 weeks. I don't think it matters, because the purpose of imaging is not just to image. It should have some actionable effect on the management. So to have an actionable effect on the management, if we are considering cross-sectional imaging, then it has to be a contrast enhanced study.
Sir, in thyroid where R1 resection is also acceptable in certain cases, so how useful will be the preoperative exact anatomical delineation?
I think it is the surgeon's choice. Whatever they feel comfortable, it should be left to them.
Because on the operative bed, anyway, they are going to assess the fixity. And even though the pre-op imaging has been done, sometimes
they will have to know what they are dealing with, right?
Yes, sir. So this patient, we did a non-contrast CT of neck. There was 4 into 3.5 centimeter nodule in right lobe of the thyroid. And there were a few right cervical lymph nodes as well, which was the largest lymph node was 8 by 10 mm, and some 6 to 8 mm, 3 to 4 lymph nodes in compartment 6. So, I mean, we guided the surgeon to go ahead with right neck dissection along with thyroidectomy and central compartment clearance. Ma'am, this is question to you. What is your opinion of open versus robotic thyroidectomy in such cases, ma'am?
Robotic thyroidectomy, as we know, madam, it has better cosmetic result, but what we are more concerned is whether it can be safely done in patients with thyroid cancers with a nodal disease. But it has been shown in many studies that The surgical oncological outcome is comparable between the open and the robotic approach, provided it is done in a center where there is high volume, where it has been routinely done. So even in ATA 2015 guidelines, they have said that it can be safely performed in centers where it is done in a large volume. Still, MRNDs and total and central compartment neck dissection have been done.
Yes, ma'am. In our center, basically the surgeons routinely perform robotic breast insufflated surgery with the lymph nodal dissection, minimally invasive neck dissection. But this patient underwent open thyroidectomy with central compartment clearance and neck dissection. So on the table, there was trap muscle invasion, and histopathology showed T3N1B MX. There was no extracapsular SPED, no lymphovascular invasion, no perineural invasion. In this case, what is the next approach? I mean, after the surgery, the surgeon will refer to a nuclear medicine physician. So, Dr. Sumit, would you be doing a diagnostic scan in this patient, or already you know that it is T3N1B? Would you want to go ahead with the therapy directly?
We always do baseline stimulated thyroglobulin and whole body scan before we go for therapy.
I mean, even if it is a histopathologically intermediate,
To know the extent of disease, definitely.
You would still prefer to.
Because first dose of radiodine, I
Mhm.
prefer to give the proper dose. Like if metastasis is identified,
Mhm.
I would definitely go with a higher dose. And if only lymph node metastasis, around 50 to 100.
Harishankar, sir?
Definitely stimulated thyroglobulin and a scan, pre-therapy scan.
Even in intermediate and high risk category
No,
patients.
no compromise, no compromise.
So we are in consensus that any case we would still be doing a diagnostic scan and a pre-treatment thyroglobulin levels. Yes. So after 20 days, I usually don't wait even for 3 weeks because if we know surgeon is really good and they're clearing the most and they're not leaving much of the remnant for us, then I would get the TSH levels done by 17th or 15th to 18 post-op days. And if at all, if TSH is more than 30, then we will proceed with the thyroglobulin estimation and administration of iodine for the diagnostic scan. Would you agree with this approach, sir, or you would traditionally want to wait for 3 weeks?
No.
No, you all agree that if it is more than 30,
it depends on the age actually. Like elderly takes time to increase more than TSH more than 30. However, again, the keyword there is elderly people, no, they can't tolerate hypothyroidism much. And in our people, they can't afford RHTSH also.
If you give me 20 seconds time, I will share an interesting fact.
Okay.
Yes, sir.
The cutoff of TSH more than 30 was on a paper which was published some 30 years before.
Yeah.
Yes, sir.
So there is the cutoff of 30. I don't know from how it was not a randomized control trial. We have been using it for 30 years without questioning it. The thing is, the time under the area under curve, the time under which the TSH stimulation has been occurring is more important than the peak of TSH. So I think it is 15 days, 20 days. When TSH is more than 30, it is still fine.
So after 20 days, the patient comes to me and the serum THS was 66.8 microinternational units per ml. So proceeded with thyroglobulin levels. The serum thyroglobulin level is 2.3 nanogram per deciliter. ATG is antithyroglobulin is not raised. It is 12 international units per ml. So we'll proceed with the diagnostic iodine 131 scan. Dr. Sumit, I would want you to interpret this scan and tell me what you're going to do next.
Yes.
So this is the scan. Thyroglobulin is 2.3. It is PT3N1B.
Okay.
But the post-op thyroglobulin is 2.3 nanogram per deciliter. ATG not raised. And this is the scan.
Scan is normal. I don't see anything in the thyroid bed or lymph nodes or anywhere else in the body. However, thyroglobulin is still 2.3. If there is no disease at all on the whole body scan and there is no uptake, see, there is thyroid bed remnant and we are seeing around 2 milligrams. it is acceptable. Not saying no. Basically, my consideration would be micrometastasis in these cases. So, and with the known lymph node metastasis, I would prefer to give radioiodine therapy. However, I will definitely give an option of wait and watch. Some young people do respond, like a delayed response is seen. 6 months later, 1 year down the line, the TG will gradually decrease. So, in younger patients, we can actually follow them up also. But the choice I will definitely give to the patient.
Okay. Hari sir?
See, I will, this is a low dose scan. I will not go by the findings of the low dose scan.
So even with
to treat the patient. So the patient has had T3 disease, nodal mets, and the TG is slightly high. 2 is still not normal. So I'll proceed. I will give the option to the patient, but I will personally want the patient to go ahead with the radioiodine ablation. If post therapy is negative, then I'm fine.
Okay, so that is what exactly when we did. We gave the option to the patient, and the patient actually opted for empirical therapy. So empirical therapy dose, how much will you consider?
It is a very tricky question, and it will generate a lot of discussion and content.
I want the discussion to happen. So
I would give 100.
Huh?
I would give 100. It is a nodal mets. I would give 100 minimum.
Okay, Dr. Sumit.
Empirical, if not seen, 100 is better because the absorbed dose per theoretically it will be better if we give 100. But if I see nodal metastasis on iodine whole body scans, then we opt for 50.
Okay, so we all agree
but
on
T3B gross extrathyroidal extension 100 definitely.
T3B strap muscle invasion completely clear.
Strap muscle again, that's the keyword. Like minimal invasion is not taken as T3B now.
T3B.
Yeah, it's still
T2.
T2.
Yeah. So we went ahead and gave 100 millicurie of iodine therapy, high dose iodine therapy. Even I agree with you. Whenever I'm not seeing anything, thyroglobulin levels less than 2.5 of stimulated TG is still a therapeutical goal to achieve post treatment. But still, we thought the patient was educated patient, and the patient opted for empirical therapy. So this is the post therapy scan. So can you interpret?
Yeah, definitely. I think this is either a residual or a central compartment node. Can't tell, definitely.
So in this patient,
usually central compartment nodes are the one missed rather than a residue in.
Yeah. So, I mean, with this case, we would still want to highlight that, I mean, sometimes going ahead and treating the patient is better whenever we find high risk category on pathology rather than wait and watch approach. Do you agree with me, sir? And what does the Dr. Vignesh or Suganya ma'am, what do you have to say?
Yeah, I agree, ma'am. Rather than wait and watch for such a locally advanced disease, like an N1 disease, better to give therapy and cure the patient.
Yes, ma'am. So 100 millicurie of iodine 131 therapy, essentially we'll have to counsel the patient that 100 millicurie is not going to harm patient much. But if it has a benefit, especially in identifying the lymph nodal metastasis, and we all know that there is around 16 to 22% of discrepancies in diagnostic scan versus post-therapy scan. So that we will have to always keep in mind. And if at all, if patient chooses for empirical therapy, we should go ahead and give the therapy. So next case number 3.
Gaina, can you
wind it up quickly?
Yeah, quickly.
Yes, sir. Okay. A 38-year-old male presented with sudden onset of hypertension. So young male presenting with sudden onset of hypertension. How do you evaluate? Vignesh, sir, will you take this question?
So young male, it's basically a direct question. Young hypertension, we have a lot of set of investigations starting from the creatinine, potassium, ESR, everything. So I would like to concentrate on the endocrine part. So if you consider hormone setting, we have 3 possibilities. One, it could be a Cushing's, or it could be a FIO, or it could be a primary hyperaldosteronism. So in which case, so leaving around other causes, for want of time, I'm just cutting short to the endocrine cause. So first we need to confirm biochemically before to proceed for imaging. So I will just clinically examine the patient for look for any signs or symptoms of Cushing's or any history to suggest a FEO or a primary hyperaldosteronism like hypokalemia. So then based on the clinical history, then I will like to choose a hormone investigation. For a Cushing's, I would just go for a cortisol testing, overnight dexamethasone suppressed test, urinary cortisol, so and so. If it is positive, then I will have to go for a ACTH and respective imaging of the MRI of the pituitary or a CT of the adrenal assets. Or if it then next come list on the list is a FEO. I would like to go for a 24 hours with metanephrine collection, metanephrine and normetanephrine. Many times normetanephrine is elevated. So if it comes to be elevated normetanephrine or metanephrine, then I will go for adrenal imaging.
Okay,
so preferably a CT of the abdomen. So if it confirms a mass, then I would like to go for a nuclear medicine imaging. Previously, we were doing MIBG for a FEO. Nowadays, I think Protonac is easier for us. So other less likely option is a primary hyperaldosteronism, where we have elevated aldosterone levels, where we do confirm the diagnosis by CT. So evaluate hormonally, then go for an imaging. That's a key.
Is there any role for ultrasound in this case, sir? Ultrasound abdomen?
There is no role for see. Only thing, if the young hypertensive presents with the role of we do a Doppler. We do renal artery stenosis. As if there is no need, there is no role for ultrasound to look for any lesion in the adrenals. CT is a better imaging.
Okay. So I mean, this patient, however, underwent ultrasound abdomen, probably Doppler, on which a lesion in the right suprarenal region measuring 4.6 into 7.1 centimeter was found. So the next approach, sir, you have a lesion in the adrenal. What investigation would you want to order in this patient?
So such a huge lesion in the adrenal. So two things I will keep it in mind. One, it could be a adrenal carcinoma with a Cushing syndrome. So I would like to always easier to go for a overnight dexamethasone suppressed cortisol.
Okay.
So if it is suppressed, then Cushing's is ruled out. Next cause will be a pheochromocytoma. Then we'll go for a 24-hour urinary metanephrine or a plasma metanephrine. Fraction meta and normetanephrine. So if it is positive, like a high metanephrine, then we go for a CT and nuclear medicine imaging.
Sir, urine versus plasma metanephrines, which do you prefer, sir?
So most of us, we prefer a 24 hours urine metanephrine because plasma metanephrines, there are assays are not much standardized in labs. So we prefer to do a 24 hours urine meta and non-metanephrine. So there are certain good labs, they do plasma metanephrines. Still, we prefer to do a 24 hours urine metanephrine and non-metanephrine.
And how much elevated urine metanephrine levels would you consider significant?
So metanephrine more than 180 microgram per day, and normetanephrine more than 600 is higher. But anything more than 2 to 3 times the upper limit of normal, we consider to be more predictive. There can be false positives in a stressful patient. There are so many reasons to get a false positive metanephrine. So anything higher the value, more chance, like 2 to 3 times the upper limit of normal, more chance probably will be dealing with a fee.
Okay, sir. So, sir, as you told, you will order for either MIBG or gallium dotanok PET CT study. So this question is for Dr. Sumit or Hari, sir. One of you can take this question. So when a physician calls you and asks you for an investigation, what would you advise, MIBG or gallium dotanok PET CT?
We have MIBG only, so I'll advise MIBG. But dotanok is more specific.
No, I'll just, can I add?
Yes, sir.
We will check what is elevated. If it is normetanephrine which is elevated, MIBG is a noradrenaline analog, and it is unlikely to be positive in norepinephrine secreting tumors. So if what is elevated is more important, that guides me to choose what. If it is only dopamine which is elevated, dopamine secreting pheochromocytoma, F18 dopa alone. If it is norepinephrine secreting tumor, it will be FDG PET or gallium dotanok. If it is MIBG, I mean adrenal secreting tumor, then it will be a MIBG scan or gallium dotanok. the secretory behavior of the or genetic mutations guide us to the real agent. It is not just the diagnosis of pheochromocytoma. What is elevated and whether we have a known familial mutations guides us to the proper agent. This is my take.
Yeah, I think Dr. Ranathir has a point, but I would choose gallium any day.
Why is the?
I can do the scan even at 8 o'clock in the night.
Sir, is that the only thing or anything else?
See, when you are, scientifically speaking, okay, Dr. Ranathir has made the point, but practically speaking, what is available any day, any time is should be the one. I'm not contradicting what Dr. Ranathir said. He is absolutely correct. But practically, I would go with gallium dotanok any day.
Sure, that is also no need of preparation. That is a convenience, cost. Gallium dotanok will be beat other investigations any day.
With this, can any of you say? I mean, how much is the difference, and what is the accuracy of investigation? Gallium dotanok versus MIBG.
See, there is a European paper in comparison, but their reports are also controversial. There is no meta-analysis as such because they did not compare it along with the secretory behavior. That is a problem. Many papers did not take the secretory behavior into consideration. That's why till date, theoretically, based on secretory behavior or mutation, practically gallium dotatate. This is what we are following as of now. Well, I don't disagree with Harishankar, but when we are talking to students, we should be clear theoretically what is this, practically gallium dotatate. If it is, and the advantage of gallium dotatate is it can also identify medullary carcinoma thyroid if it is a MEN2 or any other conditions are there. And the reporting of MIBG is trickier, whereas gallium dotatate reporting everyone is well versed with.
Yes, sir. I agree, sir. And you said FDG PET CT, sir. So in metanephrine secreting tumor.
Not metanephrine secreting tumors because succinate dehydrogenase mutation will lead to increased Warburg effect. SDH mutation. Succinate dehydrogenase blocks the Krebs cycle. So there will be increased glucose metabolism. That's why FDG will be positive. And SDHB mutations are more prone for metastasis. So the sensitivity of FDG PET will be higher in those with SDHB mutation. But knowing whether the patient is SDHB mutated prior is unlikely. So those which who are secreting normetanephrine are normally VHL or SDHB mutation. VHL also, there is an enzyme deficiency of phentolamine N-methyl transferase. So I would prefer in those secreting normetanephrine have FDG PET CT.
Okay, sir.
My options are only two, FDG or gallium dotatate. That's it.
This will be considered as an unfair situation, right? Okay, we'll talk
in the last 2 minutes.
Okay. So this patient showed gallium dotanok that is somatostatin receptor expressing lesion in the right adrenal, which was around 7 into 6.8 centimeter. What is the treatment options in cases of unresectable pheochromocytoma? Localized, non-metastatic, unresectable pheochromocytomas because of the vascular invasion, loss of fat planes with the liver, and
directed
IVC.
question to endocrine surgeon or anyone can answer?
Anyone can answer, sir.
So there are 4 options: chemo, and the second thing is prior treatment with neoadjuvant gallium lutetium dotatate SSTR treatment, chemo, and third thing is there is nothing called unresectable. It is as much resectable as possible. So that is the ask them to remove as much resectable as possible and treat with lutetium dotatate if it is clinic score is more than 3 or more than 4.
Okay, sir. So in scenario of therapy, whether would you choose MIBG or lutetium or actinium based?
So you are it is I choose lutetium dotatate. I don't have specific guidelines to say why.
Okay. Anybody else? Hari sir?
Theoretically, I feel iodine should be better. MIBG theoretically should be better.
Iodine labeled MIBG.
Theoretically also MIBG will not score an advantage because of bone marrow toxicity and patient preparation. and patient preparation is cumbersome in IVN that even MIBG. All 3 patients which I gave MIBG had issues. So that is my personal experience, but it is not professional. There are no what do you call proper randomized studies.
Yes, sir.
We have overshot our.
And actually, it should be compared 3 hours.
Yeah, we have overshot our planned timing by 1 hour. So I'd like to thank Dr. Gayana for moderating the session, and special thanks to Dr. Vignesh sir for staying till the end of the panel discussion. Suganya ma'am, thank you very much. Dr. Sumit, Dr. Anadir, thank you very much. So we come to the conclusion of day 1.
Thank you all.
I request all Southern chapter members to log off, and then you can use the GBM link to log into our GBM. Your GBM has already begun. Thank you. Good night. We'll meet you tomorrow morning.